Hello, everyone. I hope you're all doing well, and I hope you're staying cool. I know in lots of the world right now it is very, very hot, so hopefully that is going well. First announcement I wanted to make today is that I recently published a new puzzle, so if you're someone who enjoys doing puzzles, it's a set of 6x6s called vignettes. Tristan can post an LMD link, hopefully, in the chat, just so that you can see it if you are interested in doing that. People have been enjoying it so far, I am happy to see. So if you want to give it a go, I know Kodak gave it a go earlier, so Kodak seemed to enjoy it. So hopefully you'll enjoy it. Today we're going to be continuing our Sudoku tutorial series. So I'm going to open with a tutorial this time on arrows. The way this works is that I pick one every Wednesday is how I'm going to do this. I'm going to pick one sort of standard variant, and I'm going to do some number of puzzles with that variant. Some of them will be easier, then one will sort of be medium, and I'll sort of try and go over what I think the key things you need to know are for that mechanic. So last week I did Kropke. That video has gotten snipped. Tristan can put a link to that as well in the chat. So you can also see last week's intro to Kropke if you like. This week we're doing arrows, and as it turns out, there is no shortage of vanilla arrow puzzles. And by coincidence, or perhaps because people knew the theme was coming, actually even the puzzle that was voted on by the most of the supporters to do today is also a vanilla arrow puzzle. So we're going to do vanilla arrow puzzles by all kinds of setters today. So you'll get to see a whole bunch of cool stuff of that sort. So just in case you were not here last week, I'll note I run the stream just a little bit differently during these tutorials. So I'm trying to make this so that it clips for a nice video. So our precious channel mascot, Zach, will be on the side taking notes. He is trying to learn to do Sudoku as well. So we will save Zach for until the tutorial is over. I'll interact a little bit less with chat than normal, although if people in chat say things, I will read them and I might say things. So particularly if people say things like, oh, hey, this would be a good point to make about like standard arrow techniques that you're just not seeing that you could use. That is the kind of thing that I'm likely to mirror. But last week I did about 90 minutes as sort of the official tutorial. I'll probably do something similar today, and then we'll switch over. Today, the rest of the puzzles we're also going to do lots of arrow puzzles. But I should say, I'm not going to sort of call the tutorial. We'll sort of switch back to stream as usual after we do a few of these. Alrighty. So with that, I'm going to start. And so usually when I'm looking for easy puzzles that highlight mechanics, the thing I go to are the gas puzzles. So there's a gas puzzle every day that is posted over on the Cracking the Cryptic Discord. If you're not on the Cracking the Cryptic Discord, I really recommend it. These are meant to be doable in 5 to 10 minutes, depending on how quick you are. I'm not going to speed run these. I'm going to try and go slowly through these and explain the deductions so that you can sort of follow along and get these sorts of things if you've not seen these things before. So in this case, I could not find too many pure arrow gas puzzles that did the thing I wanted to highlight. So I actually have gone and grabbed, and people have recommended to me, thanks by the way, people have recommended to me good tutorial puzzles that are not officially gas puzzles, but that highlight various elements of arrow Sudoku. By the way, I said last time, and I will say again, if you have puzzles, or if you make puzzles that you think are in the 2-star difficulty range that really highlight a particular vanilla constraint, please let me know. I didn't say last time, but I should have. If you know of other puzzles by other setters that do a really good job of highlighting a particular constraint, then you should let me know about that too. So in particular, actually, I had said last time I was probably going to do Kuraban's puzzle as an example, and Kuraban said, hey, actually, I think the perfect 2-star puzzle to highlight to highlight arrow stuff is this puzzle by Playmaker that we'll do later. So I'm going to do that puzzle. But people have sent me lots of other arrow puzzles, so I'm going to have plenty of things to do arrow-wise. And I will, of course, still do Kuraban's arrow puzzle later. Sorry to hear that, Derektionary. All right, so how do arrows work? The way that arrows work is that the digit that goes in the circle is the sum of the 3 digits, or however many digits, lie along this line. So, for example, this could be 2. For example, I could turn my keypad on. So, for example, this 7 could be 2, 1, 4, because 2 plus 1 plus 4 is 7. Okay. Now, I chose this puzzle to start because I think this puzzle really highlights what I think is the most important part of arrows, which is length 3 arrows. So I prepared a graphic. So here is all of the length 3 arrows. And so this looks like a lot, but it's actually not that much. If you do many arrow puzzles, you will not have to do them for very long before you sort of internalize these. So the first thing to note is this is every possible length 3 arrow where all 3 cells on the arrow see each other. So if I had an arrow that went, say, like this, went like that, then this arrow would not apply to the thing I'm saying for the reason that arrows can have repeats. So, for example, that was probably a terrible example. But what I'm talking about here are arrows where all 3 digits on the arrow see each other. So this arrow, for example. And so this is all of the ways to fill them in. Derektionary points out helpfully that there's too many 1s in column 1, which I will acknowledge. So you'll see that whenever you have 3 cells on an arrow that all see each other, the minimum possible value they can go in the circle is a 6. And so that means that quite often, and if you watch Cracking the Cryptic very often, you'll see this all the time, the first thing you do in an arrow puzzle is fill 6, 7, 8, 9 in a bunch of arrow circles. Now, of course, in this puzzle, all of the arrow circles have been filled in. But that means that this puzzle is going to do a very good job of letting us sort of use this list and sort of see how this works. So, for example, a 6 arrow in 3 is always 1, 2, 3. A 7 arrow in 3 is 1, 2, 4. 8, there are 2 flavors. There's 1, 2, 5 and 1, 3, 4, but this box has a 3. And so this is 1, 2, 5. 7 is always 1, 2, 4. Again, 8, there are 2 flavors. There's 1, 2, 5 and 1, 3, 4, but there's a 5 in the box. So this is 1, 3, 4. This 8, again, there are 2 flavors, but there's a 4 in the box. So this one's the 1, 2, 5. This one is 1, 2, 3. And then 9 is the one where there are 3 flavors. And a thing that's going to come up an awful lot as we do a bunch of arrow puzzles is that the 9 arrow is the only one where there's a flavor where none of the digits are 1. Namely, it's possible that a length 3 9 arrow is 2, 3, 4. Now, as it happens, this 9 arrow can't be 2, 3, 4, and it can't be 1, 3, 5 either. So in fact, this is 1, 2, 6. But it will often come up that you'll be thinking about 1s, and we'll see this later, where it will turn out that, yes, we get a 1 on this arrow or whatever. All right, so in this particular puzzle, we've just done a bunch of examples of sort of how length 3 arrows are forced, and now the rest of this is going to be Sudoku, because if I look across here, I've got a 1 and a 3 looking at this cell, so this cell's a 2. And now I've got a 1 and a 2 looking at this cell, so this cell's a 4. This cell now has a 4 and a 2 looking at it, so it's a 1, and that's a 2. This has a 1 and a 2 looking at it, so it's a 3, and therefore this is a 1. This cell... Sorry, I was looking for another cell. Maybe there's not an easy... there probably is another easy gimme. Let's see. Where is... What's the next gimme here? I was trying to do this as slickly as possible, which we don't have to do, of course. We can just do things like fill in this column. This column's got 1, 2, 3, 4, 5 already, so it needs a 6, 7 and a 9. That cell's not a 7, that cell's not a 6, that cell's not a 9. And this column needs, it's got a 1, 2, 3, 4, 5, 6, it needs a 7, 8, 9. Those aren't 8, so this is 8. This one's not 9 either, so it's a 7 and a 9. 7 looks over there and goes and makes that a 6, that a 9 and a 7. And so these are complete with cheat sheet, indeed. 1, 2, 3. We need a 4 in here, and we've got a 5, and we need a 6. Again, when I'm center marking anything, just in case you haven't seen this before, what I'm doing is I'm marking every possible digit that can go in these cells. So this has to be, these digits have to be from 1, 2, 5. These have to be from 4, 6. I'll also use corner marks later, and I'll mention exactly what how that works. But in particular, these 3 cells are a 1, a 2, and a 4, so this can't be a 4, because it has a 1, a 2, and a 4 looking at it. In particular, it has a 4 looking at it, so this digit has to be a 6, which now means that digit has to be a 4. Now I ask where 4 goes in row 2. We've got 4s here and a 4 here looking over, ruling 4 out of all of these cells, so that's where the 4 goes in this box. These 2 digits are a 7 and a 9, just to finish that off. Let's see. That's right. Simon saying how scary Tallcat was I do find Tallcat quite a scary setter. That was quite nice. That's right. I'm not supposed to be chatting. Tristan will chide me later. Let's see, we can fill in these digits as to what's left in this box. This 4 looks up here. That's not a 4. That's not a 1. That 1 looks down there. That's not a 1. Where does 6 go in this box? Let's do that. 6 in this box is here. So we can fill in that. Let's see, so now this digit's a gimme. Chat can chat all they want. I'm just supposed to try and keep it so that people can watch in the VOD. I will still talk a bit, but I'm basically just trying to make it good for someone to watch later. So 3 not here. That makes this a 1, 2, 5 triple. And so that means we've got the 1, the 2, the 3, and the 4, and the 5 in the column, and the 6. So these are from 7, 8, 9. That one's not a 7. Let's see. Alrighty. Let us continue, which we will do by looking at, let's see, let's look at row 9. We've got 1, 2, 3, 4, 5, 6. We need a 7 and a 9 down here. And that 7 tells me that's the 9 and that's the 7. This is the 2. I did not fill that in correctly. This is the 2. That 2 looks over here, makes this a 1, 5 pair, makes that a 2. That 2 makes that a 1, which then makes that a 5 and a 1. Means these aren't 1. We've got 1 looking over here, so this isn't 1. Neither of these is 4, in fact, so that's the 4, the 3, and the 1. That 1 means that's not a 1. In fact, this 2 means these aren't 2, so that one is 2. That 1 looks over means that's a 5 and a 1. That 2 looks over means that's a 3 and a 2. These 2 cells are a, let's see, we've got 1, 2, 3, 4. We need a 6 and a 5? Is it a 6 and a 5? Yeah, we need a 6 and a 5. So the 5 goes there, the 6 goes there, owing to that 5. That 6 looks down, gives me a 2 down here. These aren't 2. These are from, let's see, we've got 1, 2, 3. We need a 4, which has to go there. We've got a 5, 6, 7, and we need an 8, which has to go there. So those are not 8. These digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 5, and 7. This one's not a 3 or a 7, so it's a 5. So these aren't 5. They are 3 or 7, which you'd think would be resolved, but if it is, I don't see it yet. This cell is not 1, 2, or 4, so it is a 1. Sorry, it's not 2 or 4, so it is a 1. That's a 2, that's a 4. 1 looks down and makes that a 6 and that a 1. This is not a 6 anymore, so this cell is an 8 or a 9. Let's see, we've got a 6 here already. Let's see, this column, we've got 1, 2. We need a 3, which we know where it goes. The 3 goes there. We've got a 4, a 5, a 6, a 7, and we need an 8, which has to go there. Here, we've got, let's see, we've got 1, 2, 3, 4. We need a 5, 6. We've got 7, 8, and we need a 9. So let's see, this is not 5 or 6, so it is 9. These aren't 9. They are from 5 and 6. 1, 2, let's see. Okay, so I need a 3 in here, and then an 8 and a 9. This one's not a 9, I know. This one's not an 8, I know. It's all beautifully worthless. Okay, this row, I need a 7, 9. Oops, I don't need a 7, 9 here because there's a 9 in the row already. So that makes that a 7, that an 8, that a 9, and that a 6. And that 9 makes that an 8, a 3, and a 9. 3 makes that a 7 and a 3. And so we've got here 1, 2, 3. We need a 4 here. Let's see, 8 and 9 look at this cell, meaning that's a 7. This has to be a 5 or a 6 for the row, but it's not the 6, so it's the 5, that's the 6, that's the 5. This has to be an 8 or 9 for the box, but by the column, it is not an 8, so that's a 9 and an 8. The 9 looks up, makes that a 7 and a 9. And then we are done. Alrighty. So that's a sort of demonstration of the power of knowing the possibilities for a 3-cell arrow. And we're going to see, as we go on, increasingly sophisticated ways of using this knowledge of what the 3-cell arrows are. I really liked the resolution of this. It might have just been that I was slow, but I liked the resolution of this 6, 7, 8, 9 in the middle. It ended up sort of unwinding everything around it. Okay. In contrast to the previous puzzle, this one has no 3-cell arrows. So we're going to get to talk about other things in this. And a thing that shows up a lot in Sudoku puzzles of many, many genres is paying attention to the digit 9. And the key observation about the digit 9 is that the digit 9 can never go on an arrow. And so when I ask where 9 goes in box 9 here, for example, one of the things I can do is say, okay, well, it's not going on these arrows. 9 is not 7, it's not 8, and it's not in the column with a 9. So the 9 actually has to go there. Okay, and so we get that. Now, there are some pieces of logic that you can pull from other genres. So in Killer, XV, and whatnot, it shows up that there's actually only 2 ways to add 2 numbers to get 5, which are 2 and 3 or 1 and 4. And because of this 3 here, I know which this is. Namely, you can still think about what the possibilities are for a 2-cell arrow, even if I think it's probably more a distraction than an aid if I threw them all up over my face over there. So now we can fill in the rest of this box, and so we'll get 2, 6, 7, 8. And now here's a really useful time to ask yourself the question, how are these numbers adding to 9? Well, a 6 would need a 3, and an 8 would need a 1, and both of those are gone. So in fact, this arrow we can actually figure out as 2, 7, and so these are a 6, 8 pair. And so we're sort of off to the races in terms of that right away. If you know these offhand, then that could be helpful. But even if you don't know the possibilities offhand for an arrow, if it's a 2-cell arrow, you can just write them in and look, and then you can kick stuff out pretty quickly. So speaking of looking at ways to make things, how are we making this 8? Well, could there be a 1 on this arrow? No, because then I would need a 7. Could there be a 2 on this arrow? No, because then there would need to be a 6. Could there be a 3 on this arrow? Well, yes, if it was 3, 5. Could there be a 4? Well, no, because then I'd need 4 and 4. And I can't put 2 4s in a Sudoku box. But now, actually, if I start going higher than 4, then that's not going to work. Because then I'm going to start needing the 1, 2, 3s again. So in fact, actually, if you look, this arrow has to be a 3, 5 pair. And so now what's this 6 arrow? Well, could it have a 1? No, it can't, because if this had a 1 on it, it would need to be 1, 5, and there's a 5 on this arrow, so it's not that. So the only other option is 2, 4, which has to be what this arrow is. Again, if I go up one more, I'm at 3, 3, and then I'm going down and looking at the combinations I've already written down the other direction. All right, and so now I ask what digit is missing in this box. It's a 1, and so we get to fill in a 1 there. You can do a similar thing here. For example, if we just looked at what the combinations for 6 are, there are only 2 ways to make 6. There are 1, 5, and 2, 4. This one can't be 2, 4 because there's a 2 in the box, or more sophisticatedly because there's a 2, 4 pair looking at this cell. But both of those ways tell you that this is a 1, 5, and in fact we know the order. It's a 5 here and a 1 here. And so, again, we can play the same game with this 7 arrow. Is there a 1 on it? No. Is there a 2 on it? No. What about a 3? Well, then that would be 3, 4. But I need a 1, 2, or 3 on it, and I can't have a 1 or a 2. So this has to be 3, 4. And there's already a 3 in row 9. So this is a 4 and a 3. And so I can then go ahead and fill out these cells. 1, 2, 3, 4, 5, 6, 7. These are an 8, 9 pair. And actually, that's even resolved by the 8 down here. So that's a 9 and an 8. Okay, so we're off to a pretty good start here. So here's an arrangement I want to highlight that comes up a lot. Namely, these 2 6 arrows that are looking at each other. And so the point is, there's 2 ways to make 6. There's 1, 5, and 2, 4. But whenever you have an arrow vertically that looks at one horizontally, like this, of the same flavor, they can't be the same. Because this can't be a 1, 5 arrow because it's got a 1, 5 looking at it. And so every time, and in fact, actually, the same pattern was true over here, every time you have a horizontal arrow of one of these that's looking at a vertical one, they have to be different. And so this one has to be the not 1, 5 one. This one has to be the 2, 4 one. This is, again, one of those things that shows up in Sudoku of all kinds. It shows up in Killer Sudoku. It shows up in XV Sudoku. It shows up at a bunch of different places. But it's useful to pay attention when you have sort of like 2 of the same thing looking at each other in that arrangement. Okay, so this 2 looks up and gives me the 4 and the 2 there. Like that. And so now this 9 arrow is looking sus. So it could have an 8 on it, if it's 1, 8. Can't have a 2 on it. It can't have a 3 on it either, because that would need a 6. And it can't have a 4 on it, because that would require a 4. And it has to have a number that's less than 9 over 2 on it. So it has to have a 1, 2, 3, or 4. And we've just shown the only one of 1, 2, 3, and 4 it can have on it is a 1. This 1, 4 pair looks down here to tell us that this isn't the 1. So that is an 8 and a 1. And so we have that now filled in. So we have all of that. This 2, 7, by the way, I am looking, the 2, 7 looks down here and makes that a 4 and a 2. While we're looking at Sudoku stuff. let's see. Where else can we look? I think we're going to look at this 9 arrow now, and I think we're going to have the same pattern show up that showed up before with the 6 arrows. So, can't be 1, 8, because there's an 8 in the box. Can't be 2, 7. That's the hard one to see. It can't be 2, 7, because it's looking at a 2, 7. And so if I filled in 2, 7 on this arrow, it all looks good until you realize that you've put 3 2, 7s in the row. So it's not 2, 7. It could be 3, 6. But it can't be 4, 5 because there's a 5 in the box. And again, we've gone through the version that involves a 1, a 2, a 3, and a 4. Alrighty. And so that's a 3, 6 now. So that is cool. So the 3, 6 here ends up looking at this 8, 6. Now we've got 1 arrow left. So could this arrow be 1, 7? It sure looks like it. Can it be 2, 6? It cannot, because there's a 6 in the box. Can it be 3, 5? It cannot, because there is a 3 in the box. So this is a 1, 7. Again, it's disambiguated by that, so that's a 1 and a 7. 1 and a 7. This 1 looks over, makes that a 4 and a 1. I noticed at some point that this 3 looks down here and gives me a 5 and a 3. Does really nothing look at these? Maybe nothing really looks at these. What are these 2 cells? They are a 2 and a something. 2, 3, 2 and a 4, it looks like. Okay, so that's sorted out by this 4. Makes that a 2 and a 4. The 2 looking over makes that a 7 and a 2. You can get rid of the coloring. And this 6 looks up and gives me the black and the 6. It looks up and gives me the 3 and the 6. And now, oh, I guess we do have an arrow left. Sorry, I thought we were done our arrows, but we're not yet done our arrows. We still have this mysterious 6 arrow that we have yet to fill in. But let's fill in all of our pairs. So these digits are a 2 and a 7? That doesn't... Oh, no, 2 and 7. 2 and 7 sounds right. Oh, there's also an 8 arrow here. The arrows are multiplying while I'm not looking at them. These arrows are a... or sorry, these cells are a... Let's see, we've got 1, 2, 3, 4... 5, 6, 7, 8, 9. 4 and a 9. Okay, so let's examine the 8 arrow for what it could be. So again, could it be 1, 7? Again, the answer here is even more stealthily no, because there's a 1 and a 7 looking at... Yeah, I do not know where this 8 arrow came from. This 8 arrow and 6 arrow, I think Sven is working on this new feature where clues appear while the solver is not looking. So the software added this this magic 8 arrow. Okay, so it is not a 1, 7. It's not a 2, 6, because there's a 2 and a 6 looking at it. And so that means the only thing it can be is a 3, 5. So that is a 3, 5. I think this 6 arrow is actually still undetermined. I can fill in the possibilities, but there's actually 2 of them. So could this 6 arrow be 1, 5? It can be, but only if this is the 1 and this is the 5. And could this 6 arrow be 2, 4? Yes, but only if that's the 2 and that's the 4. So we're going to have to do some Sudoku. We're going to have to Sudoku our way over here to figure out what's actually going on with this. These 2 cells seem suspicious to me. So let's go at them. So we've got 1, 2, 3, 4, 5, 6, 7. We need an 8, 9. And so that's the 9 and that's the 8. Now where does 8 go in box 5? It's ruled out by Sudoku from those cells. These aren't 8, so that's an 8. Let's see. I have 4 8s looking into this box, so I must know where 8 goes in this box. Yes, 8 in this box goes here. I'm being told that row 3 actually resolves the arrow. I will have a look at that later. What about these digits? These are a 3 let's see, we've got a 4, we need a 5, we've got a 6, we need a 7, and then we've got an 8 and a 9, so these are 3, 5, 7. That's the 5. So this is not 5, this is not 5, this one's not 7 either, so this one is 3, and that one's 7. Alrighty, so these two digits, let's go ahead and fill in. What are they? They are a 2, and a 5. So we have that. This digit, I probably know what it is if I think really hard about it, because I've got all the other digits. So 1, 2, 3, 4, 5. I need a 6, so this is a 6. These digits are, let's see, I need a 1. I don't know where that goes yet. 2, 3. I need a 1 and a 3. So I'll write in 3 and 7 just for fun. I need a 1 and a 3. I don't know the order yet. Let's see. Here I've got 1, 2, 3, 4, 5, 6. I need a 7 and a 9. I don't know the order on that yet. What about... okay, so I want to look at this cell that people are telling me is resolved. If I look closer. I broke box 6. Oh no, what did I do in box 6? Uh-oh. How far do I have to rewind? Did I just fill in the wrong digits or what? Oh, I just made it so there's no place to put a 6 in box 6? Oh, it's because I filled in this pair incorrectly. That's, this 2, 5 is not actually a 2, 5. So this pair is actually a 5, 6. And that's not the 6. Because there's a 6 in there. Okay, thank you. So that's a 5 and a 6. So that 5 makes that a 3 and a 5. This row now is, we've got 1, 2, we need a 3, 4, 5, 6, 7, 8, 9. This is a 3 and a 9. So that's a 3 and that's a 9. Let's see. What is left in... Yeah, what's left in this row? We've got 1, 2, 3. We need a 4. We've got a 5. We need a 6. Okay. So that's going to do it. So this 6 tells me that that's a 4 and that's a 6. And now that 4 looks up here and gives me a 1 and a 5 up there. And now the arrows are done. So now it's just Sudoku, although you've seen already how well just Sudoku goes around these parts. But we'll do our best to muddle through, as they say. These are a 1 and a 2, 3, 4, 5, 6, and a 7. This one's not 1, I see immediately. This one's not 7. This one inexplicably can be anything. Is this 2? This cell is the 2 or 7 for the column, but it's not a 2. So it is a 7. That's a 2. That's a 1. That's a 7. This row needs a 1, which has to go here. 2, 3, and then a 4, which goes there. This row needs a 2, which inexplicably is not resolved yet. And a 3, which mercifully is. So that gives us a 3 and a 2. That's the 2, that's the 5. So that 2 gives me a 7 and a 2. The 7 gives me a 9 and a 7. The 9 gives me a 4 and a 9. And now we need a 4 to finish this row, column, and box. Woohoo! Excellent. So we have successfully finished this, and so I think we're on good shape as far as these sorts of things go. So these were sort of the 1-star arrow puzzles. So we're going to move on to some sort of 2-star arrow puzzles. The stars is just sort of a rough proxy for difficulty. But you'll see what happens in the ones where we sort of jump up a degree is that usually there aren't any given digits. So we will we'll have a look at this. And so this is a puzzle by Playmaker that came recommended by a few people as a good arrow demonstration puzzle. And so going back to what I said about length 3 arrows, the sort of first thing you want to look at is everywhere you can see a length 3 arrow where none of the cells, where all of the cells involved see each other, or where none of the cells can be repeats. And so everywhere I've highlighted in yellow, that is true. And so that makes all of these circles that match those arrows, those are all 6, 7, 8, 9. To make that work. And so now that has in fact actually given us a 6, 7, 8, 9 quadruple in row 3. And so we can fill in these remaining digits. These remaining digits are 2, 3, 4, 5. Okay. Now, I think now we have to talk about math. So when we talked about why a length 3 arrow is always at least 6, the thing we started with was saying, well, it's at least 1 plus 2 plus 3. What comes up in fancier arrow puzzles is that often you want to consider 2 arrows together. So in other words, if I sum all of these cells together, what do I get? And so what I really mean by that is I want to sum this whole arrow, that is all of the yellow cells, and this whole arrow, that is all of the blue cells. And I want to ask myself, what's the minimum value I could get out of that? And so, notably, this given 1, I'm sure, is here to make this digit a 2. But this is at least a 2. And so then the minimum I could do here for this sum would be this. Put a 2 here and make 1, 3, 4, 5 everywhere else. Putting the 2 here minimizes it because remember this cell is counted twice. And so the sum of these is 17 at minimum. Yellow plus blue is at least 17. But because these are arrows, the sum of yellow is this cell, and the sum of blue is this cell. And so what we're saying here is the sum of these 2 cells is at least 17. But there's only one way to get to at least 17, and that is to in fact get to exactly 17, with these 2 being an 8 and a 9. And in order for that to work, we needed this cell to be 2. If this cell was bigger than 2, if this cell was, say, a 3, instead of being a 2, the minimum would be add all of these together, 1, 2, 3, 4, 5, plus 3, that would be 18. You can't possibly get to 18 as a sum of 2 circles that see each other. So in fact, we actually get that this digit is 2, and these are a 1, 3, 4, 5 quad. Okay. Just to say that again a little bit slower, just in case you're having trouble visualizing this. When I think about what the minimum value, the sum of these could be, is, I think about, okay, these are going to be 1, 2, 3, 4, 5 at minimum. That's 15. Plus, this cell's counted twice, so I have to add this digit in a second time to 15. So does 15 plus, and this can't be a 1. So 15 plus 2 is the minimum. If it were 15 plus 2, 3, 4, 5, those all give me a number that's too big to be the sum of these 2 circles. So that is why this is a 2, and these end up being a 1, 3, 4, 5 triple. These being an 8, 9 pair means that these aren't 8 or 9. These are 6 and 7. I want to fill these cells in real quick, because I now know that these are a 6, 7, 8, 9 quadruple. And if you look over at the reference floating above my head, 6 and 7 arrows actually always have a 1 and a 2 on them. So I'm going to fill in that there's always a 1 and a 2. And so I think this is my first time today making these corner marks. The corner marks mean that within this box, I know the 1 is in one of the cells that's marked with a 1 in the corner. And within this box, the 2 is in one of the cells that's marked with a 2 in the corner. It's not that one, by the way. Same is true over here because of this. And ultimately, all of these digits I can also fill in. They're all from 1, 2, 3, 4. All right. Now we get to do the same trick a different way, which is to, instead of looking at the sum of these in the sort of complicated way, let's look at the sum of all the purple digits. What's the minimum value that the sum of all the purple digits could be? The minimum value is 15. Because, again, this is a sum of 5 different digits, because they're all in the same column of a Sudoku. So these sum to at least 15. Now, this digit's only at most 7. So in order to pick up the slack, this digit has to be an 8 or a 9. If I make this digit any less than 8, I'm never getting to a sum of at least 15, which I know I have to. And the same thing happens over here, where I can make exactly the same argument with the green cells. Take these two arrows together. Their sum has to be at least 15, and again, that means that this has to be an 8 or a 9. Now, that gives me an 8-9 pair down here, which is interesting, particularly as concerns 8 and 9 in this box. Because remember, 9 is never on an arrow. So actually, I know one of these digits is 9 now. And so that's ruling 9 out of this cell. Now, I'm sort of trained to be excited that I've removed a 9 from a circle, because normally when you remove a 9 from a circle, it is a sort of exciting moment, because it means there has to be a 1 on the arrow. Except it doesn't do literally anything in this instance, because we already knew there was a 1 on the arrow, so that may have been a bit of a red herring. I'm seeing that these also can't be 2. And I'm seeing also that these are a 1, 2, 3, 4, 5 quintuple. So actually, we can also fill 6, 7, 8, 9 into these cells. So we have that. All right. The arrows taken together trick can also be used sometimes when it's the same arrow. So normally when you have a 2-cell arrow and you ask, what is the minimum digit I could possibly put here? The answer is usually something boring. Like it could be, for example, it could be 3. If I have a 2-cell arrow, I could go 3, 1, 2. I can't actually do that when I have a double arrow like this. So if you think about it, actually the sum of the orange cells is double the circle value. And the sum of the orange cells is, by our sort of triangular number argument, it's at least 1 plus 2 plus 3 plus 4. It's at least 10. And so that means that this cell actually has to be at least half of 10. It has to be at least 5. So when you get this kind of arrangement, it actually gives you a lower bound here. Now, this 8-9 pair is actually doing something very interesting, though. Because this actually can't be 5, for the fascinating reason that if I make this 5, I can no longer put 8 and 9 in this box, right? The 8 is up here somewhere, as is the 9 is in one of these 2 cells. If I make this a 5, where are the 8 and 9 going? Well, the 9 can go here, but now one of them now the 8 has to go on an arrow with a -3. So actually, this can't be a 5, 6, or 7, actually, owing to this very clever 8-9 pair that's hanging out down here. So this is 8 or 9. Now, I'd love to say there has to be an 8 on this arrow with a 1, but I can't yet. But I do know that this is 8 or 9, at the very least. Alrighty, so what do I do now? Let's see. I don't even have something like a quad here. Let's see. Am I supposed to ask about this column? This column would be very exciting to look at. Yeah, so this column, what I'm noticing about this column is I probably can't put many high digits in here. And in particular, I can't actually put a high digit here either. That's a good point. Okay, so that's, I think, the point. So what's the highest digit I can put here? Well, I can't put an 8 here. So the highest digits I can put here are actually 7. I can't put a 1 because the 1 is already used up here. In fact, I can't even put a 7 here because the 2 is also used up here. So actually, these are from 3, 4, 5, 6. Okay, so that means all of these digits are at most 6. This digit's also at most 6 because it's on an arrow that adds to at most 7. So this digit is a 3, 4, 5, 6. And what that gives you, if you look closely, is the channel favorite a sextuple. Namely, because all of these digits, all 6 of them, are from 1, 2, 3, 4, 5, 6, that's the 1, 2, 3, 4, 5, 6 for the column. And so this digit can't be a 6. It's a 7. And this digit has to be an 8 or a 9. So that's awesome. And in particular, it's awesome because it has lots of fancy things. So it makes this a 6. That means that these are a 1, 2, 3 triple. These are a 1, 2, 4 triple. So there is no 4 down here. And I am noting actually now, if I look at this summing to 8 or 9, I have to use a 3 here. If I don't use the 3, what happens? Well, if I don't use the 3, then I'm adding 5 and 6, which do not add up to 8 or 9. So I have to use a 3 here. And now I'm noting that because this digit can no longer be a 3 or a 4. The 4 is here. And so this 5 or 6 matches with those 5 or 6s. We're adding to 7 here, so this digit is a 1 or a 2. I can now look over on the column 9 side and ask myself, how is this arrow ever going to work? And there's a few different ways to see that. One of them is to remember I needed these to add up to at least 15. And well, if this is an 8, that's not going to work. The other is to ask, what is the absolute minimum I could put on these two cells? 1, 2, and 3 in the column are gone, so the absolute minimum I can put is 4 and 5. But that's also the maximum because this is at most 9. And so then that makes that an 8. Makes this a 3, 5 pair, which now comes up and makes that a 6 and a 1. So things are progressing, as we hope. Or as we would hope. So this is a 1 up here. So this is at least 5. Do I even feel like pencil marking that? I don't really want to. This 6 at least sees this circle. So this circle is now a 7 or an 8. What does that do? Okay, so the 6 in this box is in one of these two cells, because I can just do Sudoku on 6s and ask about that. But I don't see that right away. Oh, this 8 does Sudoku this 8, 9 into a 9. There we go, there we go, there we go. The 9 here then makes that an 8 and that a 9. So I now need to make these add to 8, so I need to make these add to 6. And I can't make these add to 6 without a 1. And so it's 1 and 5. And so these aren't 1 and 5, these are 3 and 4. So this digit's not a 5, this digit's not a 3 or a 4. Okay, so if this is an 8 arrow now, it can't be a 1, 2, 5 arrow. If this is an 8 arrow, it's now got to be a 1, 3, 4 arrow. Which means there's always a 4 on this arrow. Okay, so here's a way to play commonalities. By again looking at the little cheat sheet if you don't have all of these worked out. If this is a 7, this has to be 1, 2, 4. If this is an 8, it can't be a 1, 2, 5 because it would make this have no value. So it's a 1, 3, 4, which means there's always a 4 on this arrow, and it doesn't go in the column with a 3, 4 pair. So in fact, that's a 4. In fact, actually, smarter way for Zeta to see this 3, 4 pair tells me this digit can be neither a 3 nor a 4. So this can't be an 8 arrow anymore, because if this were an 8 arrow, we said it would have to be 1, 3, 4, but this could be neither. So in fact, this is a 7, that's a 2, that's a 5. This isn't a 2 anymore. And so we're moving right along. In fact, this 4 gives me a 3 down here as well. These are not 3 or 5. These digits are 2, 3, 4, 5. These aren't 2 at the very least. These digits are 1, 2, 3, 4, 5. We need a 6, 8, and 9. This one's not a 6 at the very least. And I know from my magic 9 down here, pencil mark down here, that that's not a 9. And actually, here's a good thing. This 7 removes 7 as a candidate, and now I actually have a 6, 8 pair. And so the 6, 8 pair in this column means this isn't an 8, it's a 9. So now I know what these two digits are. These two digits are a 2, 3, and a 4. And so that's actually funny because it tells me what this quad is. Because, again, remember from before, there are 4 ways to make 9. There's 1, 8, 2, 7, 3, 6, and 4, 5. Well, I can't use 2, 7 because the 2 in the box is over here. I can't use 4, 5 because the 4, 5 in the box, because the 4 in the box is over here. So I have to use 1, 8, and 3, 6. So here are my 1, 8, and 3, 6. And I can allow myself the luxury of doing some Sudoku, like the 1's not here. And since the 1 goes with the 8's not here. The 3, 4 tells me the 3's not here, so the 6 isn't there. And so I get this 3, 8 pair here, looking up now at this cell, so that cell's now the 9. This isn't a 9. And I now have a 1, 6 pair looking up at this cell, which means that this is an 8 and that's a 6. That 6 chases down to here, means that's an 8. Means none of these are 8. This one's not 6 either, owing to the 1, 6 pair, while we are cleaning up. This column needs a 7 and a 9. Well, for lots of reasons, this cell can't be the 9. So this cell is the 7, and that cell's the 9. So these aren't 9. This digit is now a gimme, because we've got everything else gone. So it's not 1, 2, 3, 4, it's a 5. We've got that. Okay. I'm looking at where 1 goes in this box, and I'm noticing that the 1 in this box has to go in one of these 2 cells, but I'm not seeing anything interesting about that yet. So instead I'm going to fill in these cells. These cells by the column are a 7 and an 8, and we know the order, so that's the 8, that's the 7. Let's see. Okay. What about the row? Let's look at the row. We might be able to force one of these arrows. So we've got a 1 here in the row, or we still need a 1. We've got a 2. We need a 3, 4, 5, and we got 6, 7, 8, 9. Okay, so this is a 1, 3, 4, or 5. What is this cell? So it can't be a 3 because there's a 3 in the box. It can't be a 4 because the only way to make 4 is 1, 3, and for lots of reasons I can't make this 1, 3. So this is at least a 5. Unfortunately, I don't yet see much reason why it can't be basically any of those things. So that's dismaying. I think the same thing is true over here, actually. The minimum this can be is a 5, but I don't see why it can't be anything. Let's see. Let's continue Sudoku. Sudoku's often the answer. This can't be an 8. This can't be a 9. Let's see. Alrighty. This arrow I realize I have not looked at all yet. So what's the minimum value that this arrow can take? So this could be a 1. This could be a 3. So that would be 4. And then this could be a 1 as well. Because remember, this is a length 3 arrow. I should have pointed this out at the very beginning. This is a length 3 arrow, but they don't all see each other. So all of the sort of the strength, the wind goes out of the sails of what this could be. And so 1, 3, 1. I mean, this is at least 5. So this is 5, 6, or 7. I am learning. I see things like, I'm not keen to use it, but I see things like the 3s align in these two boxes. So if I ask where 3 goes in row 9, it can't go in any of these cells because this box already has a 3. It can't go in any of these cells because this box already has a 3. So one of these two is a 3, but I don't even think it helps yet. As we have so far seen. What about this row? Maybe I should think about this row, because I realize I have not even filled in that this is 2, 3, 5 yet. Does that do me any good? Not that I see. It might do. Let's see. Okay. Let's see. So we've got some 5s and some 5s. Okay, so we can ask questions like, where does this arrow go in box 4? And so this is often a good idea to ask is, okay, I should let's give this a color, orange. You can ask, where does orange go in box 4? And so orange is a 5, 6, or 7, so it's not in any of those cells. Orange is not in the same column as orange. But orange also can't go here because this is an arrow that adds to orange. And so the way you'll often hear this is the circle of an arrow will never repeat on the arrow itself. So I know that one of these two cells is orange. I don't know which, but I'm going to mark it that way. And the reason I'm going to mark it that way is that now where does orange go in box 1? It goes in one of these cells. And so the key here for going in one of these cells is these cells are a 9, a 6, and a 7. And so if these cells are a 9, a 6, and a 7, this can't be a 5, because then we'd need to put a 5 here, and we can't. So this cell is only a 6 or a 7, actually. So that's very interesting. Okay, so maybe I should ask, what's the maximum value this cell could be? These could both be 1. And so this cell is at most a 5, is the point. This cell here is at most 5 because these sum to at least 2, and this is a 6 or 7. So this is a 1, 2, 3, 4, 5, but it's not a 1, 2, or a 4 because those are already gone in the box. So, in fact, this digit is a 3 or a 5. Let's see. So so what is that going to do for us? Anything exciting? Okay. I'm going to steal something from chat, which is very nice, which is, where does 8 go in this box? 8 in this box is pushed into exactly the same spots. So these two cells are orange and 8. So in particular, this cell's not 5 either. And neither of them is 9, because one of them is orange and one of them is 8. So these are from 6, 7, 8. That's helpful, I think. So, let's ask ourselves the simplest question in the world. Where does 9 go in this box? 9 in this box can't be in any of these cells, and it can't go on an arrow that adds to 6 or 7. So 9 is here. Let's see. Interesting. Okay. Now, I should actually, now that I've done a lot of work on this arrow, I should actually look at this and see if there's anything I can rule out. Like, for example, this digit can't actually be 8 anymore, because I can't add to 8 anyway. Despite the fact that 4 and 4 are marked, I can't make this arrow 4 plus 4. So the Sudoku stuff has sort of whittled this away to the point where this can't be 8 anymore. Remembering that this is an orange 8 pair, actually, this is the 8. This is the orange. Let's see. Okay. Does that do anything? Okay, this 8 over here. So that. No, never mind. I am seeing there was sort of an alternate path to see that this couldn't be 8 by seeing that we'd ruled 3 and 5 off, or we'd ruled 3, 5 pair off of it, but that's fine. We've got a 6, 7 pair in this row, so this is not 6 or 7. Let's see. This digit is at most a 3. That's another thing I should fill in. So the minimum these sum to is 4. So this is at most a 3. So this is only a 1 or a 2, because it can't actually be a 3, because there's a 3 in the box already. I'm just sort of working my way up to trying to find a triple or something in the row. Chat has noted for me that there is a 1, 3, 4 triple and a 6, 7, 9 triple in row 5. So actually, this can't be a 1. So that's a 5 and a 1. That's nice. So these aren't 1. So these are now a 2, 3, 4 triple. Oops, sorry. These are a 2, 3, 4 triple, so we can fill in the rest of this. So we've got a 2, 3, 4 triple and a 6, 7 pair. So that means the rest of this row is 5, 8, and 9. This can't be 8. This can't be 9. I do know one of these two is a 9. I don't know which one yet. I have the same problem with this cell over here. This cell can't be an 8 either, because it can't be 4 plus 4 because of Sudoku, and it can't be 2 plus 6 because of the 6 in the box. So this actually can't be 8, which does give us a 5, 9 pair here, making this the 8. And once this is a 5, 9 pair, I see that this digit's always odd. This digit's always even, so this digit's always going to be odd. So it's never a 4. Sorry, it's never a 4. is what I meant to do there, is to take away the option of this to be 4. One of those two is the 4. Not yet exciting. Let's see, and I don't know anything nice, like there's always a 3 on here or anything, right? No, I do not. Alrighty, we're slowly whittling this down. The intro of this puzzle was super easy. Was super smooth and clear. This part I'm a little more lost. I'm a little more looking for things. Where does 9 go in this box? There we go. No, 9 in this box has, I guess, 2 places. It could go in one of those 2 places. Let's see. We can look at, like, this intersection. I'm betting this has to be a 1. Let's try the opposite end. Let's try making it a 4. Is it possible that this is a 4? No, because if this is a 4, immediately those two sum to at least 7, and then I need to add that digit. So this can't be a 4. Oops. Can't be a 4. So this is a 1 or 2. Can this be a 2? If this is a 2, so you could go 2, 3, 2, and that would be okay. Or 2, 3, 1, actually, would also be okay, I think. I know this digit goes on this arrow, but of course it goes on that arrow. Let's see. Let's see. So let's see. What happens if this? I'm just eyeballing some things chat is suggesting. But I don't quite see anything yet. Let's see. Yeah, we've got almost all our low digits in row 7, but not quite all of our low digits in row 7, unfortunately. Oh, there we go. Where's... No, not quite. Darn. We almost know where 5 is in this row, but not quite. 5 in this row is in one of those slots, but I don't know which one yet. Let's see. Where is 3 in this box? That'll at least get me 1 elimination. I don't know if it'll do me any good yet, but one of these 2 cells has to be a 3. Because of this box not having anywhere else for 3. So one of these 2 is a 3, so this isn't a 3. That's at least something. That is a 1-2 pair. Let's see. Okay, I think I'm going to fill out this row. I may or may not immediately regret this, but I'm going to fill out this row and see if I regret it. So they're not 1, 2. They could be 3, 4, 5, 6, 7, and they're not 8 or 9. But let's clean that up, because this can't be a 4, because there's a 4 in the box. These can't be 3, because there's a 3 looking at it from over there. Okay, I regret it. I have regrets. Okay, I guess I can do Sudoku on orange. Maybe I'm supposed to do Sudoku on orange, because I'm realizing this is not orange. Or sorry, this digit is the 6, 7 that's not orange. So this is the 6, 7 that is orange. But I don't think that super helps either. Let's see. I'm trying not to use the chainier spots that chat has. I'd use them normally, but I'm trying to do this one in the sort of the cleanest way possible. Let's see. So I'm trying to stick to things. Let's fill these in. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are from those digits. These aren't 7. These aren't 1. Let's see. Someone's mentioning something about the box 8 arrow. I'm not quite sure. Okay, good point. Okay, we did get a quad in column 2. We have a 2, 4, 6, 7 quad here. So at least this isn't a 4. This is a 3 or a 5. Aha! And that'll do it. That's it. That's the point. This 2, 4, 6, 7 quad got rid of a 4 here. And now this is always an odd plus an even. And then an odd plus an even is always odd. So orange is 7. So that digit's a 6. And I bet that will make our lives easier. So these aren't 7. Sorry, I guess that one's not 7. I need a 7 over here. Okay, so this could be a 3 with a 2 plus a 2, or a 5 with a 1 plus a 1. And that doesn't immediately give it to me. One of these is the 6 for the column. So let's get the 7s out of here. One of these is the 6 for the column, so this isn't a 6. Let's see. There's a 7 over here somewhere. Let's see. Okay, what else can we do? Let's see. We've got. I had thought that realizing that this was a 7 was going to sort of resolve life for us, but it has not yet resolved life for me. So these two cells also add to 7, I guess, is one of the points. These are either 3, 4, or 2, 5, because this is the other one. I feel like I'm trying to make this a 2-star puzzle, and I feel like the row 7 thing is beyond a 2-star puzzle. Maybe not, but I'm trying to keep this as intro friendly as possible. Let's see. But I may give up and use it. We'll see. So is there some combination here that obviously doesn't work for some reason? Let's see. Row 3, column 8. Too many 2, 3, 5s in column 8. Let's see. So if this is a 2, this is a 3 or a 5. Okay, so this is a little messy, but we can do this. If this is a 2, it does not work with this combination of cells. Because if this is a 2, how is this working? The only way, or I guess maybe actually, I think the easier place for me to see it is to start here. Can this be a 5 with a 2 and a 3? And it can't be a 5 with a 2 and a 3 because that would be that cell. And that would give me 4 of those. So even if this is a 5, it's a 1 plus 4 kind of 5. But the 9 here can never have a 2 with it. So this is always a 4. And that's a 2, which makes that a 5. These are, of course, now not 5. That one's now a 3 and a 4. This is now not a 3. It's a 1 or a 5, but it's not a 5 either, because there's a 5 looking at it. So that's a 1 and that's a 5. Let's see. So this is not a 1 or a 4. Actually, this is just resolved by the row. This is a 3. This is not a 3 or a 5, so it's a 2. That's the 5. This is not a 4 or a 5 now. This is a 6 or a 7. It's not a 7, though, so it's a 6. That's the 7. That's the 9. Let's see. This is not 5, 6, or 7, so it's a 4. Let's see. That 3 means this 3 is actually here. We've got 1, 2, 3, 4, 5, 6. We've got 7 and 8 left to place. That's a 7. That's an 8. This column needs a 1, needs a 1, a 2. We've got a 3, 4, 5. We need a 6. So that gives us a 1, 2, 6 triple in the row. And so if we've got a 1, 2, 6 triple in the row, that means this can't be a 2, so it's a 4, which makes that a 5 and a 4. This 4 looks over here at least and sees that that's not a 4. We've also got our 1, 2, 6 triple here. Not sure that one's being quite as profitable for us. However, this 8 is. So that's a 3 and that's an 8. That 3 makes that a 6, and that a 1. That 6 means this isn't a 6. This isn't a 1. This is a 2 or a 6. Let's see. That 3 means this is a 5 and a 3. Let's see. I've still got a 1, 2 pair. This isn't a 6, though, so let's nip that in the bud. So these are a 3, 5 pair, which makes that a 9 and a 6. Let's see. Box 8 is now pretty done. So these aren't 2. This 5 looks down and makes that a 3. Makes that a 5. Oops, makes that a 5. Now that this is a 3, I need these two to add to 4, and the only way to do that is double 2. So 1, 6, 2, 6, 4, 1. 2 makes that a 4 and a 1. 4 makes that a 3 and a 4. 3 makes that a 2 and a 1 and a 3. Very nice. And so this puzzle, by the way, is the sort of the first in a long line of Playmaker arrow puzzles. We'll be doing another later as the most voted on. But I've done many of the Playmaker arrow puzzles. This is quite a cool puzzle. I really liked this, and it really did an excellent job at sort of showcasing all of this stuff at the beginning with the what does it look like when you're batching multiple arrows together. Because the batching multiple arrows together is a technique that shows up a lot. Okay. So, by the way, I did want to say what chat was talking about during this, because there's another thing that you often want to do in arrow puzzles, but that I thought was probably a little beyond where we're going for this puzzle. But chat was noticing to think about in this row where you need to put your high digit. So you needed to put 3, 6, 7, 8s. And if you actually thought about it from that point of view, then it was clear that you could make some eliminations based on that, because a few of the combinations for these arrows would have put too many low digits into this row. That's a sort of a more advanced technique, but one that is very useful in a lot of arrow puzzles, because arrows like to have big digits in the circles and little digits on the arrow. All right, I want to do one more arrow puzzle before we call the tutorial done, and then go back and do more arrow puzzles. And the one more puzzle I want to do is this puzzle, Somersaults, by Derektionary. So we have one more of these to look at. And so this features some length 5 arrows. And so your brain should immediately be sus about any length 5 arrows that you see. And so let's just think, how am I ever going to make this circle a single-digit number? And so what's the minimum I could possibly do? Well, I could put a 1 and a 2 here, and a 1, 2, 3 here. Well, that's already 9. So this digit does have to be a 9. These digits have to be a 1, 2 pair, and these have to be a 1, 2, 3 triple. That's the only way this is going to work. And so when you have arrows that cross boxes, this is a pretty common combination, is that you'll have an arrow that crosses a box, but 3 of the cells on that arrow are already in one box. Then you sort of know the things that dangle out of the box. In that case, these have to be very small. In this case, they have to be, in fact, exactly a 1, 2 pair. I want to mark that the same thing happens here. And then I want to notice that that's put a lot of pressure on these cells. Because now, if I look at these cells closely, this one's at least a 4, and this one's at least a 3. So actually, this arrow can only sum to 7 or 8. And it has no 1s or 2s on it. And so, what is this arrow going to be? Well, the key thing is it can't have a 1 or 2 on it at all. So it's at least 3 plus 4. And so it can only be 3 plus 4 or 3 plus 5. Those are the only ways I'm getting to 7 or 8. And in particular, there's always a 3 on it. And so this digit is not a 3, which gets us a 1, 2 pair in the column as well. And we get to do the same trick, or a very similar trick anyway, in this row, because the 1, 2 pair look at this arrow. And if the 1, 2 pair... Sorry, I just noticed something. This is a 1, 2, 3 triple looking at this cell. So that's the one that's the 4 or the 5, not the 3. This is the one that is the 3. So we get an actual digit. I'll look at this arrow in a second, but now this arrow is even better than it was a second ago. Because now this arrow has 2 cells on it that each can't be 3 or 1 or 2, because there's now a 1, 2, 3 triple looking at both of these. So these are each at least 4 or 5. But the only way it works out for this cell, because this cell can't be 9, if I add 2 digits that are each at least 4 or 5, the minimum I get is an 8, and the only way I get an 8 is if both of these are 4. And so I actually get 2 4s here. That 4 comes over here, tells me that's a 5 and that's an 8. So that's gorgeous. And so we've got good things going on here. And so again, we have here repeat digits on arrows. Those are perfectly allowed and in fact often encouraged. And I'm seeing that now this digit and this digit are in the same position. Namely, they can't be 1, 2, 3. This one can't be 4 either. So this one's at least 4, this one's at least 5. So this can only be 9 with a 5 and a 4 in that direction. So we've got that going on down there. And we might as well fill in, what are these? These are a 6, 7, 8. And that one's not an 8, it's a 6 or a 7. These digits are a 3 or 5, 6, 7, just for posterity. These digits are, let's see, we've got 1, 2, 3, 4, 5. These are 6, 7, and 9. Okay. Let's go back now and consider this digit, or these digits. They're a minimum of 3 and 4. So this is a minimum of 7. So this is 7, 8, or 9. This one, let's see, this cell, oh, actually, yeah, both of these are big. Okay, this arrow is also restricted, because neither of these, this cell, this is very clever, this cell sees that 1, 2, 3 triple, this cell sees that 1, 2, 3 triple. So these are, in fact, a minimum of 4, 5, but they're also a maximum of 4, 5. So that's a 9 as well, which is cool. So this isn't a 9 anymore. So this is a 7 or an 8, which means that this arrow is from, as before, 3, 4, 5. If I try and put any digits bigger than 5 on this, I'm immediately going to bust, and I need to put a 3 here, which then, in fact, gives me this 3, 4, 5 triple in the row. So we've got 1, 2, 3, 4, 5. We need 6, 7, 8 for the row. However, there's a 6, 7, 9 triple in this box already, so this is not 6 or 7. It is, in fact, 8. So these two are not 8. They are 6, 7. Let's see. What are the... Oh, sorry, no. What are the... Oh, I guess I don't quite know yet exactly how this resolves. Okay, but I suppose I should probably be continuing to look at where these remaining digits are going. Okay, so what's left in this column that can possibly go here? Let's see. 1, 2, 3 we don't have yet. We've got 4, 5. I can't put... Actually, maybe I could put a 6 or a 7 on here. Maybe, possibly. Oh, I have to have a 6 or a 7. Okay, got it. Okay, so... and this is not 8 or 9. Okay. So let's do the thing that people were very excited about last time. Where are the 6s and 7s in this column? Well, let's just start by highlighting only the cells that can be 6 or 7. It's these. Well, can these both be 6, 7? Well, no. Because then this arrow would sum to at least 13. I'd need several negative numbers on it. So this cell can't be 3. That's the first consequence of this. One of these is a 6 or a 7. And so if I'm putting a 6 or a 7 on this arrow, that means this cell can only be an 8 or a 9. And this is at least 7 in total. Because it's at least a 6 plus a 1. And so this digit can only be a 1 or a 2 in order to make this an 8 or a 9. Oh, spoiler, by the way, it's not an 8, actually. It is a 9, unfortunately, but it is what it is. But you can do a similar trick over here. What are these? Well, these are at least 3 and 4. So this digit can only be a 1 or a 2, except these digits being at least 3, 4, plus 1 means this digit's at least an 8, and it can't be a 9, so it is an 8. And that's a 1, and these are 3, 4. And so this is a 2. And so I need these to add to 7, so they're not 2 or 3 or 7. They are 1 and 6. And so that's going to Sudoku lots of things. 1, 6 makes a 7 down there, makes a 2 there, a 3 there. No 3 there. That 2 makes this a 1 and a 2 and a 1. These aren't 7 anymore. That 1 makes this a 6 and a 1. That 3, 4 makes this a 1, 2 pair. Let's see. We've probably got more Sudoku if I look closely. One of these is an 8. This is a 9 because of where 9 goes in this box. Can only go there. Let's see. What is left up here? We've got a 5, 6, 7, 8 is what's left to go in this box. These aren't 8. These aren't 6. These aren't 5 because of the 4, 5 pair in the column. That's suspiciously close to useful, actually. I don't think it's quite there, but it's getting there. let's see. Okay, let's pencil mark the rest of this box. That'll probably be useful. 1, 2, 3, 4, 5, 6, 7. These aren't 3. That does do something immediately, which is to put 3 in one of these 2 cells, which looks at this cell, which means that this is the 3 for here. I did not pencil mark that goodly. Someone is pointing out. Let's see. These are 3, 4, 5, 3, 6. 3, 6 is probably better. Yes. And so, that's the 3 and that's the 6. These aren't 6. That's the 6. That's much better. These 2 cells are a 4 and a something. 4 and a 9, so it goes that way. 9, 4. The 4 looks over, goes 3 and 4. This 3 now is placed there, so this isn't a 3 anymore, or in the corner for that matter. This is a 5 or a 7, can't be an 8. Let's see, what's left in this box? We need a 2, and a 5 and a 7, I'm guessing? Yeah, 2, 5, 7. Sounds fair. This one's not the 2 either, though, because there's a 1-2 pair looking at it. Which means that this digit is a 2. Let's see. We've got our 5, 6, 7 looking like that. Here's another observation. The 6 in this row is here in one of these 2 cells. So this isn't a 6. Amusingly, I think this was listed as a 3-star puzzle and Playmakers was listed as a 2-star puzzle. But I agree that to my sensibilities, this seems much easier. But what are you going to do? Maybe you're just that much better at arrow puzzles now, having listened to the beginning of the stream. So this is a 6 or a 7. Let's see. These digits, 2, 3, 4, 5, 6, 7, 8. This is not 4 or 8. This is not 8. That was probably not the smart thing to fill in. Let's see. Let's see. I'm being told that this cell is a naked single, which is gorgeous. Okay. So this is not a 1, 2, 3, 4, or 5, or 6, 7, or 9. So this cell actually can only be an 8. That's gorgeous. Great spot to the chatter who spotted that. This is the other 4 or 5 for the box. That 8 looks up and gives me a 7 and a 6, and a 5 and an 8. That 7 comes down here and gives me a 5 and a 7 over there, gives me a 7 there. It tells me that those are 5 or 6. Let's see. So let's fill in these cells. So I need a 1 and a 2. Got a 3. I need a 4 and a 5. Then I've got a 6, 7, 8, 9. This is not 2 or 4. This might be able to be anything. This one's not 1, though. I admit that's disappointing. Let's see. That's where the other 4, 5 is. Yeah, where does 4 go? Okay, so here's a good question. Where does 4 go in this box? 4 in this box is ruled out of these cells, and 4 also can't go in this cell, because that would make this a 4-5 pair. Or sorry, that would make this arrow a 4-5 arrow, and it can't be. So 4 is in one of these 2 cells. Similarly, 5 is actually, I guess, pushed into... can't be there. 5 is also pushed into 2 places. It's not as useful as I was hoping. Never mind. I thought that was going to be really sweet. Did not end up quite that way. But there's a much easier way, which is that this 5 looks and sees that 4, and that 5, and that 4. So that's not a 4, but now that's a 5 by our previous work. That's a 4. 3 plus 4, and so this is, I will say, this is like the thing I most often miss in arrow puzzles is that I've now filled in this complete arrow, so I should remember that this is a 7. So it's a 6 and a 7. Let's see. So this arrow can't be 1 8. It can't be 2 7. It can't be 1 8 because there's 2 8s looking at it. It can't be 2 7 because there's 2 7s looking at it. It can't be 4 5 because there's a 4 5 looking at this cell, and a 4 and a 5 in the box. So this can only be 3 6, and we know the order. 3 and 6. So now that cell's not a 3, which gives us a 3 there. Means this is a 1 or a 2. This is a 1 or a 2 for the column. This is whatever's left over. 1, 2, 3, 4, 5, 6, 7. This is an 8. Which means that's a 7 and an 8. These aren't 7 anymore. Let's see. Yeah, this is a gorgeous puzzle. I really like this one. We got 1, 2, 3, 4, 5, 6, 7, 8, or 9. I think I did that right. This isn't a 2 or a 4. This isn't a 1. These are 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 1, 7. It's not a 3 either. These aren't 4 while I'm at it. Let's see. Does that do something? This isn't 4 either. There we go. This isn't 4 either. So where does 4 go in this box? Only there. There's a 5, 6 pair in this column. So this isn't a 5 or a 4, so it's a 2. So this is not a 2 or a 3, it's a 7. So that's just a 5, 6 pair. This isn't a 7. There's a 1, 2 pair here, which means that's the 3. We've got a 1, 2, 9 triple. This isn't a 4 anymore, I can point out. Let's see. This 7 looks up and says that's not a 7. The 5, 6 pair also looks at this and makes that a 9. Means this isn't a 9. This is a 6 or a 7. There's a 5, 6 pair in this box, which makes this an 8. Is that the last 8? That is the last 8. That 7 looks down and makes that a 6, and a 7, and a 5, and a 6, and a 5, and a 6. We will, by the way, to those of you joking about how we could color stuff, which I am always happy to color stuff. I will eventually do a tutorial on things like simple coloring. So if you want to do a more abstract intro puzzle for me to use at a later point, something like an intro coloring puzzle or a simple coloring puzzle would be very welcome. Alrighty, and that is this puzzle. So I think that gives you a bunch of the cool things that show up in arrows. Now, as sort of a concluding remark, I want to note that there are tons and tons of tricks that come up in arrows. Coloring comes up in arrows. Often arrows mean you end up doing a system of equations of some sort. Actually, if you want to look, just last stream I did a cool Navarro arrow puzzle that involved a system of equations. There's a lot of variety in arrow puzzles. And so I'm going to end the tutorial here, but we are going to do a lot more arrow puzzles today. So there'll be a link in the description if you want to go back and look at some more arrow puzzles that we've done, because really it is a very rich genre. All right, I'm going to take a short break, and then we'll come back. We will bring back Zach to do some digit dancing, and we're going to start with this arrow puzzle, which is, I think, a 5-star rated arrow puzzle by Playmaker that was voted on by the people. The element in chat asks if I've done Slitherlink. I have done Slitherlink. I'm pretty sure I've done a couple Slitherlinks on the channel. I've not done a ton on the channel. I do like Slitherlinks. Alrighty. Oh, Eric in chat is pointing out that yes, there are there are arrows that sum to double-digit numbers, which I hate, but they do exist. I would not really even call those arrows, but they're like an arrow variant, so to speak. Alrighty. So now I get to chat with you all and have a delightful penguin accompanying me. I will be back very shortly, and then we'll resume with things as usual. Be right back. Oh, and I guess I can hide my list of length 3 arrows now. Be right back. Welcome back. We have Zach back, all prepared to dance and be excited. We also have chat asking about Tristan and I's journey into the Outer Wilds, which we'll be continuing next week on Monday, with a house guest this week. So we've not done any subsequent streams of that this week, but we'll do more. Also, the mention of Slitherlink actually makes me think that it would be a good idea to include in the puzzle tutorial series some pencil puzzle genres like Slitherlink and whatnot as well. So I'll probably look to do that as I go through hitting all of the various sorts of variants. I will look for those as well. Again, I'll mention to all of you in chat and whatnot that if you find a puzzle that you think does a particularly good job of highlighting some of the deductions, some of the standard deductions in variants, I would recommend, or I would ask that you send it to me, and then I'm more likely to do it. So it always helps. Okay. So we now have this puzzle by Playmaker. So we are going to look at this, and we're going to begin by asking about 9s. Because I am noting immediately I cannot put a 9 anywhere in these cells. So the 9 in this box is going to be in one of these places. Now, what about this box? Well, now I can't put a 9 in any of these cells, so now I get to chase the 9 down here. Now, in this box, now the 9 is going to go in one of these 2 cells. And now here, it looks like maybe the 9s are a little bit more free to roam about the country. Yeah, the 9 can't go there, or there. But there's lots of options. That ran out. Apparently, this is only a 4-star puzzle, Kenny. So maybe we'll be able to do this. Now, this constellation is super interesting immediately to me. Because we have some sort of like equation we could write down here. I don't know if I'm quite prepared to reach to paper and pencil yet. But we have some sort of equation with the fact that these digits all sum to 45. So like the difference between these is even or something like that. Yeah, the JLib in chat is asking, and this is a good question, which is like, what's the minimum sum of these? The minimum sum is 21, but it's very easy to make these sum to 21. Directionary is suggesting odd-even stuff, which is what I was sort of inclined to do. This one poking out of the box and the one in the box is a little weird. But here's another property of arrows. The sum of the digits on an arrow, if you include the circle, is always even. So this in total has an even sum. So these need to have an odd sum, which means that these 2 need to have an odd sum, which means that these 2 are opposite parities. One of these is odd and one of them is even. I don't know that I want to write that down. I can go ahead and do my this is 6, 7, 8, 9 business. Oh, bet cell. Do you have a suggestion of a bet cell, Playmaker? Oh yes, the 1 dot unique Kropke puzzle is amazing. I should show that off later. Row 8, column 8 is being proposed by the setter as a bet cell. So you can place your bets now. If you've been itching to bet all day, this is your chance to bet for the value of this cell. We do have several 1-cell arrows here. Should I be looking at these 1-cell arrows? They seem in really ugly places. Let's see. This is, of course, because there's 4 of these, this is at least 5. I don't know that this one is at least 5. Now, an interesting thing about this digit is that this digit shows up on one of these arrows. Yes, row 6, column 1 is not a 9, Nicholas points out. Good paying attention to the only thing I have written in the grid at all. Much better than mine. Okay, so these all go in this box somewhere. Somewhere. But yeah, one of these, wherever green goes in this box, it's making one of these arrows. I know green doesn't go in its own arrow. Wherever green goes in this box, it's making one of these arrows effectively a sum of 3 digits, because it's the sum of these 2 plus the other digit. arrows in box 4 sum to at least 21. Ah, right, okay. Sorry, I should take these together. Okay, good point. So the sum of all of these cells is at least 21. But that's also double this cell plus this cell. So if this was a 5, then I would need this cell to be at least 11. Well, that's not going to happen. So this can't be 5. So yeah, I was not noticing that all of these together took up so much real estate here. Here's another observation, actually. 8 can't go up here. If 8 was anywhere up here, I'd need to put a 9 in one of these two circles, and neither of them can be a 9. So actually the 8 is down here too, while we're at it. This can't be a 6 either, because then I'd need this cell to be a 9, but it can't be. Oops. So this is a 7 or an 8, and we know the 8 and the 9 are actually down here. Let's see. If this is a 7, then this is a 7, 8, 9 triple. 7 times 2... It can't be 7 either, actually. Because if this is a 7, this is a 7, 8, 9 triple, and then this is at most a 6. Double 7 plus 6 is not 21. So, in fact, this is an 8. And we get our digit dance from our digit dancing penguin. We'll do our professional digit dance. Now, there are those who may say that the 8 dance looks like the 3 dance. However, 8 and 3 also look very similar. So there is a certain logic to the digit dances looking similar between the 8 dance and the 3 dance. And if you look very closely, or consult Tallcat's book on the subject, you will find careful choreography that will demonstrate to you the clear differences between the 8 dance and the 3 dance. Thank you, Zach. We appreciate you for your 8 dance. Thank you. Okay. It is true. 8 is 2 times 3 in a geometric sense. Alrighty. So one of these are 9. So one of these is 9, and now we ask, okay, so now what's the minimum this digit can be? Okay, these aren't 8. I should also pencil mark that. These aren't 8. So these are, this is 16, so I need to get to at least 21. So this is 5, 6, or 7. I guess those are the only options for that cell. Okay. So here's another observation. I don't necessarily claim any great insight here. I can't put a 4 on here. Because then it would need a second 4. So the 4 in this box is sort of lopped into one of these places. Yeah, there's 3 possible 8 arrows. We don't know which combinations it can be yet. Let's see. People are saying this can't be 6. Let's unpack this. Right. The point is, if this is 6, what is this? And so if this is 6, then now 6 is on an 8 arrow, and so one of the 8 arrows is 2, 6. So this is 1, 5. Except now I can't use 1, 5, or I can't use 1, 7, or 3, 5. So actually, yeah, you're right. If you examine it closely, this can't be a 6, which is interesting. Oh, thank you for the donation, David. David says, for Tallcat and ICHTUES, 2 magnificent puzzles that Simon did recently in the past days, 7 and 6 letters respectively in their names. Thank you, David, so much. I really enjoyed the Tallcat puzzle. I haven't gotten to watch the Kajito one yet, but the Tallcat puzzle was quite nice. Okay. So if this is 7, then one of these would have to be 1, 7. And so then I'd ask, okay, how am I making 7? I would be making 7 as... okay, let's just write this in. So if this is 7, then one of these is 1, 7. And so 7 is not going to be 1, 6. It could be 2, 5, except that breaks 2, 6 and 3, 5, so that doesn't work. Or it could be 3, 4, in which case this is now 2, 6. And this doesn't work because reasons. I disbelieve Tallcat's claim that this can't be a 7. So I'm intrigued by the fact that neither of these circles can be 8. That's also interesting. Okay, so there's an interesting point. Okay, so if this is a 5, what happens? Let's think about this world. If this is a 5, well, then one of these arrows is a 3, 5, which means the 5 itself is a 1, 4, which means the 8 is a 2, 6. The other 8 is a 2, 6. So either way, I'm going to either way I end up with a 2, 6, right? So I guess here's the easier way. If I use the two ways that only involve odd numbers, which is if I use 1, 7 and 3, 5, then I can't make 5 and I can't make 7. So one of these is always a 2, 6. And so, and I think it's always going to be the case that we're going to need a 4. If I try and make 5 without a 4, then I use 2 and 3, and I can't use 2 and 3, because 2 and 3 breaks 2, 6. So 5 would use a 4. If I make this 7, well, then that doesn't work either. I can't use 1, 6 or 2, 5, so I have to use 3, 4. So the point is, one of these is always a 4. So there's always a 4 up here. I guess we can think about what the sum of these cells is. The sum of these cells is either 21 exactly, in which case this is 1, 2, 3, 4, 5, 6. Or the sum is 2 more than that, which is 23. So the sum here is either 21 or 23. Both of those always involve a 1, a 2, a 3, and a 4. So that's a separate way of arguing that the 4 always ends up here. And then there's always going to be a 1 and a 3 in here somewhere. Although I don't think we really know where. Okay, and so if this is a 5, then these are 7, 9. If this is a 7, then we've got a little bit of wiggle room on what these can be. By the way, someone in chat, I think it was Kenny, asks, is there sort of a sense of when something is bifurcation? There's not like an official law of when something is bifurcation. I think it's I think it's more a you know it when you see it kind of thing, but I think different people put it in different places. For me, I tend to think of a lot of what other people think of as not bifurcation as being pretty bifurcaty. But quite often, if you look at an argument that is phrased as being bifurcation, if you actually squint at it, you can actually see a way to see it that's not bifurcation. So I think the this is a long chain, but what's the point of this chain? Often you can say, the point of this chain is really that there's something about the parity of these two digits or something about the sum of these digits or whatever. And so often I sort of dig for the option. Okay, Chad is pointing out, by the way, that actually there's not there's not actually any wiggle room. These are either, let's put them in here, they're either exactly 1, 2, 3, 4, 5, 6 if this is a 5, or they're 1, 2, 3, 4, 7, and then whatever else they need to add to 23. And so whatever else they need to add to 23 is, let's see, that's 17, so that'd be a 6. So actually, because of the fact that this digit needs to appear in orange, actually, it's forced that there's only 2 possibilities for orange. Either orange is exactly 1, 2, 3, 4, 5, 6, or orange is exactly 1, 2, 3, 4, 6, 7. And so there's always a 9 down here. And then these are from 9, 5, and 7, of course, is the point, I guess. That's what I should have really said this, is these 3 points are a 5, 7, 9 triple. Right? Did I do that right? Yeah, so if this is a 5, there's a 7 down here. If this is a 7, there's a 5 down here. So this is a 5, 7, 9 triple, is the upshot of all of that. But yeah, and I will say a lot of it is about how much I trust the setter. So if I see an argument and I go, that's gross, but it works, and I don't know the setter, I might take it. But if I see an argument and I go, oh, that's gross, but I really trust the setter, often that will motivate me to go back and try a different way of finding the deduction that I'm looking for. Because a setter I trust won't do something like, even if an argument works, I'm only cheating myself by taking the ugly argument when there's a prettier one that I could be finding. Okay, so now people are asking about this cell. So now this cell is a sum of 2 things, so it's at least a 3, but it's actually much bigger than that. And so I'm going to argue for you at once, this can't be a 3 or a 4. So 3 and 4 have something in common, and the thing they have in common is that there's only one way to make them. So if this was 3, these cells would all be 1, 2. And why is that bad? It's bad because it would put 1 and 2 down here in this box, where they are not. And with 4, exactly the same thing would happen, but with 1 and 3. 1 and 3 are not down here. So this digit is not 3 or 4. It's at least 5. But the only digit that's at least 5 that's available is 6. So this digit, in fact, is a 6. And these are a 1, 2, 4, 5. That we have down here. And of course, these are different, is another point. So these cells are a 1, 2, 4, 5 quadruple, for whatever that's worth. Minimal, as far as what I'm able to determine at the moment. Is there some cell I'm not seeing that sees all of these? I don't see it yet. But again, I know that these are different because they don't end up down here. And they would end up down there if they were the same. So I guess I can fill in these cells are 1, 2, 3, 4. For whatever that's worth. I'm thinking about writing in candidates for this, but it seems untoward to me. I don't yet see how this is working. Let's see. I'm now looking at Sudoku on 8s to see if there's anything fancy there. I don't see it yet. Can we go back to row 1, column 4, and row 1, column 5, summing to at least 15? I'm not sure what you mean. Oh, row 1. Row 1. Got it. These two cells. So yeah. So yeah, we know these two sum to an even number. We proved that earlier. So what do we know about the sum of these two? That is a good question. So one of these has the green cell on it. And one of these is I guess one of these is a 9. I guess that doesn't quite get me there. But one of these has the green cell on it. Right, okay. One of these has the green cell on it. And so let's just imagine that's where the green cell is. And so the sum of these I could write as that. And so the point that Chad is making is that the sum of these 5 cells is always at least 15. And so no matter how I do it, the sum of these is at least 15. So these are from 6, 7, 8, 9. That's a very cool way to see that, by the way, to Chris, who was the one who was persistent about it. Okay, we know these two add to an even number. Does that tell me anything about what these two add to? I don't think so, unfortunately. Unless I do some mod 4 business. That sounds like a bit much. Let's see. Tallcat thinks these add to an even number as well. I don't see that argument yet. Is it from the row? Oh, I see. It's because these add to an even... Okay, I see. These two cells add to an even number. We proved that earlier. It was ugly. So these two also... Sorry, so these cells also add to an even number. Wait. No. Sorry, I said this wrong. These two cells added to an odd number. Sorry, these two add to an odd number. That's what we proved. So these cells also add to an odd number because it's the same number. But these are always adding to an even number. It doesn't matter because they're arrows. Oh, row 1. Row 1. Okay, sorry. Row 1. Okay, so Tallcat's argument is as follows. Row 1 sums to an odd number. Arrows always sum to an even number, so that sums to an even number. Arrows always sum to an even number, so if I look at box 1, these sum to an even number, so that also sums to an odd number. And so that is... So these two, once they're done, they need to sum to an even number. That's at least 15. And the only even number that's at least 15 that's available is 16. And so these have to be a 7-9 pair. That is a gorgeous argument from Tallcat. Very nice setting, too. And so now this is an arrow that's a length 3 arrow that's not a 9, so it needs a 1. So we've got this. Very cool, very cool. Okay, so the 7 in this box is on an arrow. So the 7 in this box is on an arrow, and it's not an arrow that sums to 8. So it's an arrow that sums to 9. So the 2 and the 7 in this box are over here. So one of these arrows, so the 9 arrow is a 2, 7, 9 arrow. I don't know which of these it is, but one of these is a 2, 7, 9 arrow. Which means the 2 in row 1 is over here. So these are from 1 to 5 or 1 to 3. 1, 2, 3, 5 are the only options available over here. Okay. So what... Oh, 7 could be in a circle. You're right. Sorry. Never mind. I think you're right. I think I was wrong. 7 could go in a circle. I was thinking 7 couldn't go on an arrow that sums to 8, but right, 7 could be over here. Okay. So these two sum to an odd number. So this number is odd. So it is 1, 3, 5, 7, or 9. It's not 7 or 9. Also, spoiler, it's not 1. So this is 3 or 5. Yes, let's just do the math. Okay, so these cells sum to 32. So these cells need to sum to 13. And so this could never be a 3. In fact, it has to be a 5 and an 8. Okay, so thinking about the parity of this was a complete red herring. Because these needed to sum to 13, and the only way it was going to happen was with this being a 5. I mean, it's not even 5 or 7, it's just 5, right? Because these sum to 32, and so this is 6 or 8. I need these to sum to 13. 6 would require a 7, that's not going to happen. So this is just an 8 and a 5. So yeah, I think we beat ourselves up thinking about parity when we could have just immediately stopped thinking about parity and just thought about the rule of 45 once we had that. So green is 5. One of these has a 5 on it. This 8 now, we know what it is, because it's now not 1, 2, 5, so it's 1, 3, 4. So these digits are a 2 and a 6. So that tells us that this is not the 2, 6, 8 arrow, because it would look at that. So, oops. So this is the 2, 6, 8 arrow, which is great. So the 8 in this box needs to go on a 9 arrow, and then the 7 needs to go here. So this is a 7-9 pair. With an 8 and a 1 on the 9 arrow. I guess I can just do this in the center. An 8 and a 1 on the 9 arrow, and a 3 and a 4 on the 7 arrow. That does interestingly put a 4 over here. Oops. Okay, so... So one of these could be 5, 2, or 4, 5, because I need a 5 over here somewhere, is my point. Yeah, the 8... the other 8 arrow, I see. Okay, this 5 looks down here, that's not a 5. Right, what is this 8 arrow? Wow, we did lots of look ahead over here that we did not need to do. Is the point. Lots of look ahead that we did not need to do. Because now what is this? It's not 2, 6. So, and it's not 1, 7. So it just is 3, 5. So that's not a 5. And so that is a 5, which means this is a 1 and a 4. So we've got that. Let's see. Can we do anything more for free with that? Maybe not immediately. This is a really slick puzzle. Right. This 5 sees that this is now the 2-4 version. This is not the 2-4 version, so it's the 1-5 version. So these aren't 2-4. These aren't 1-3. Everything cleaning up nicely. Let's write in candidates for this cell. It's not 1, 2, 3, 4, 5, or 6, so it's 7, 8, or 9. For whatever it's worth. Can't quite do the same down here yet. Let's see. Yeah, we're sort of in the zone of thinking about where 7, 8, and 9 are going to live in this row, because they're running out of places to live. But they're not quite out of places to live yet, I don't think. Well, I can fill in that these are 6, 7, 8, 9, I suppose. And these are 3, 7, 8, 9. That one's not an 8. Good point from Tallcat that the 1 is over here. So these sum to at least 5, so this number is at least 6. Let's see. It's either 1, 4 or 2, 3. Oh, haha, it can't be 6. Great point from Doug. Because 6 is either 1, 5 or 2, 4, and it can't be either. So this is, in fact, a 7, 8, 9. Which gives us a 6, 7, 8, 9 quad, where the 6 is here. So this isn't a 6, and that's not a 6. Great. So this is only 7 or 9. And these are either 2 or 6. But yeah, we can pencil mark the 1, 2, 3, 4 for the column, which means that this cell is a 2 or a 3, because it's not a 1 or a 4. Which means that this is a 2 or a 3, which means that this 5 can't be 2, 3, it's 1, 4. So that's not 1, 4, it's 2 or 3. Good Lord, amazing. Okay. That was quite a way to show off there. Amazing. Yes, just stunning setting. So now this arrow really wants to have a 1 on it, because if it doesn't have a 1 on it, then it is a 4, 5, 9 arrow, but could theoretically be. Maybe, possibly. This 7, 8, 9 in the box can only go in one of those two cells. That is to say, this cell can only go in one of those two cells. Let's see. Okay. Yeah, I know the 1's over here. So let's see. If this were 7, what would it be? Oh, Niv finished the Totally Normal Cat puzzle? Wow, that was that puzzle looked like quite a puzzle. Okay, what's the 7? The 7 in this box, the 7 arrow, is not a 1, 6, and it's not a 3, 4. So it's a 2, 5. So the arrow here that's a 7 is a 2, 5. And so then the arrow that's a 9... I guess I can just center mark this. The arrow that's a 9 has got to be a 3, 6. So one of these is a 3, 6. I'm looking for, does 3, 6, 7, or 2, 5, 9 break, but neither seems to break that I can see so far. Quite possibly breaks with greater amounts of instinct. This cell can't be a 6, I'm noticing, because 1, 5, and 2, 4 are going in the column. Could there be a 6 on here? Unfortunately, I think there can be. There's a 2-3 up here. This can't be the 3 or the 2. One of these is a 2-3. Oh, we have a 2-6 pair in column 2. I had not noticed that. Thank you, Judith. Would let us, I suppose, start coloring those and see if it does anything. So those are the same digit, because that 2-6 is not that 2-6, so it must be that 2-6. Those two are the same digit. But I don't know if this is going to help. Well, interestingly, yellow and blue are both down here. Oh, no, this does something. This does something, right? No. Never mind. Sorry. I was going to get excited, but no, I'm not allowed to get excited about this. One of these is a 2, and it pairs off with that 2, but that's okay. Yellow in box 7. Yeah, I guess yellow in box 7 does tell us that these are from 1, 4, 2, 6. Well, here's a probably useless deduction. This cell isn't a 2, because one of these is a 2, and this cell sees both of them. So that's not a 2. I, again, think that the odds of that being useful are essentially 0, but we're going to use it anyway, and be happy about it. Okay, let's just fill in the possibilities for this, just in case it's somehow more restricted than it looks like. It's not 2 or 3, because it sees this 2-3 pair. It's not 6, because it sees this 6. It's not 8, because it sees that 8. See. Carl thinks row 8, column 3 has to be the other 2, 3. Yeah, this one also can't be 2 or 3. Right, okay. So is it possible that this arrow does not have a 2 or 3 on it? And the answer is no, because it doesn't have a 1 or a 4 on it. And so if it also doesn't have a 2 or a 3 on it, then it's at least 5 plus 6. It sums to at least 11. 11 is too many. So there needs to be a 2 or a 3 on here, but because of the point I just made, this sees both 2 and 3. So this is the cell that is 2 or 3. It's blue. That's yellow. No, it's blue. Sorry. Never mind the blue-yellow part. This is the cell that's 2 or 3. That's a 2-3 pair. That makes this a 6 and that a 2, and that a 6 and that a 2. And so we can get rid of this coloring, but it means that these aren't 3. If those aren't 3, then these aren't 4. We can look at what the possible values are here. So if this is a 7, it would have to be a 2 plus 5. If this was an 8, it could be, well, it would have to be a 3 plus 5. If this were a 9, it would have to be a 2 plus 7. It would have to be a 2 plus 7. So this cell is a 5 or a 7. Those are the only options for this cell. Which is interesting. So yeah, so one of these is a 3. And one of these is a 4. Oh, right. One of these is a 3, one of these is a 4. The fact that one of these is a 4 tells me what this is. It tells me that's a 1, And that's a 4. I could have pencil marked this and made this more direct and done it that way. That would certainly have made life nicer, but I did not. So we move on slowly from the sins of our past. So this is a 7 or a 9. Oh, and now that this is a 1, actually, that does more damage, because this is a 1, so those aren't 1, and so those aren't 8. I did that right? I think I may have screwed this up a little bit, but whatever. That's where we get. I believe, unless I screwed this up terribly, in which case I apologize in advance. So 1, 3 here, and so what are these digits? We've got 1, 2, 3, 4. We need a 5. We've got a 6. We need 7 and 9. What did I miss? 1, 2, 3, 4. We need a 5. We got a 6. Oh, and we need an 8 as well. There's an 8 down here. That's the thing I missed. Yeah, this 1, 4, if I want to, instead of going down, if I want to go over, it's way better, because that 4 gives me a 2 and a 4, and the 1 gives me a 5 and a 1. So this 2 tells me these aren't 2. Where did the 2 go in this box? The 7 arrow was a 2, 5. So this is the 3, 6 arrow that adds to 9. This is the 2, 5 arrow that adds to 7. We'll remember this time to fill in that the arrow adds to 7 and 9, even though I usually don't remember that. These aren't 9. That's not 9. This isn't a 7. So we've got that. Okay, this is a 6, 7, 8. Oh, there's a 6 in this row already, so that's not a 6. So that is in fact a 6. Giving us a 7, 8 pair in the column. Doesn't do anything, but it's a 7, 8 pair. We've got our chocolate teapot triple of our 7, 8, 9s doing nothing, basically. Let's see. Seven in box 5 looks right. Right. One of these is the 7 in box 5. Thank you, Woofer. So this is not a 7, so that's not a 7. It's an 8 or a 9. Interestingly, there's... Oh, that does it. Okay. That's huge. This is an 8 or a 9, which means that this can't be the 9, 8, 1 arrow, because the 9, 8, 1 arrow, spoiler, has both an 8 and a 9 on it. So therefore, this is a 7, and that's a 9. This is a 1 and an 8. That's a 3 and a 4. And so that's a 1 and a 4. That's a 6 and a 3. That's a 1 and a 3. I could have had that a while ago if I was paying better attention. Let's see. Did I do any damage down here? It doesn't look like I did quite yet. Let's see. So there's an 8 or a 9 in one of these cells. I don't know if that tells me anything just yet. There's a 3, 7, 8, 9 quad here. In fact, really, let's just look at it this way. There's a 7, 8, 9 triple in this row now, so this is a 3. So this isn't a 3, and that's not a 3. That 3 makes that a 5 and a 3. Oh, that 5 also made that a 3. If I had looked at it that way, that probably would have been even more elegantier. This arrow actually now sees a 1. So this is at least a 5. I don't know how much I care about that yet, but I'm going to note it anyway. there is some discussion of this cell, but I don't see what people see about this cell yet. Yeah, what about row 7, column 2? Oh, how did that happen? Oh, years ago. Okay, I see what happened. This 9 removed 9 as a candidate from this cell. And as soon as that happened, this couldn't be 7 anymore. Because 7 plus 2 was 9. That's the only reason this could be a 7. So this is actually a 5. Got it. Okay. Yeah, that was going to take me a while to see. Okay. So those aren't 5. So this is actually a 6, 7, 8, or 9. Yeah, the 9 really did not make much of an impact on my life, I'm afraid to say. So I did not notice when the 9 went away. Let's see. 2, 3. Okay. So this cell's at least 4. If this cell is at least 4, then this cell has to be at most 5. So this cell is from 2, 3, 4, 5. This isn't a 5 either, because that's not a 5. And that's how one-cell arrows work. These digits, let's just fill in. They are from 1, 4, 7, 9. This one's certainly not a 9. Let's see, if this were a 7, this can't be a 7 either, because if this were a 7, this would need to be a 1 or a 2, and it can be neither. Actually, what can this cell be? Actually, let's fill that in. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this could be an 8, if that's a 1. Cell certainly can't be a 9, in any event. Uh-oh, there's a 4 in the column. There's a 4 in the column. So these aren't 4, I should notice. And then these are from some other set of digits that are not the digits I tried to write. 1, 2, 3, 4, 5, 6. 6, 7, 8, 9. Okay, there's 1, 6, 7, 9. This cannot be 7 or 9, or 6, actually. 6, 7, and 9 would all have required this to be 1, 2, or 3, or 0, and it can be neither 1, nor 2, nor 3, nor 0. And so this is always a 1, is the point. So those aren't 1. These digits are not 1, 2, 3. We've got 4, 5. We've got a 6 and a 7, and we need an 8 and a 9. This is certainly not a 9. It's not a 5 either, because there's a 5 in the row. So this is a 4 or an 8, meaning that this is a 5 or a 9. There's a 7, 9 pair in this column, Kuraban points out, meaning that this is a 6. Gorgeous. So, got some 6y stuff going on over here, I suppose. This isn't a 6 anymore. This isn't a 1 anymore. Let's see. One of these is a 5. Does that do me any good? I don't think so. Yeah, I did enjoy the puzzle that Simon did today, Moons of Saturn or something. Let's see, the 7, 9 pair looks over here. It means this isn't a 7 or a 9. This is a 6 or an 8. So if this is a 6, it's a 2 with a 4. It can't be. Okay, this can't be 6 because it can't be 1 and 5 in either direction because there's a 1 there. And it can't be 2, 4 either because there's a 2, 4 there. So this actually is 8, which means this isn't a 4. Means that this is either 2, 6, 3, 5, or 5, 3. Those are my options. That 8 sees up and makes this a 9 and a 9. And that's going to do a lot, because that makes that a 7 and an 8 and a 9. I mean, maybe it's going to do absolutely nothing. Let's see. That 8 makes that a 4, which makes that a 5. That's good. That 5 with that 5, places a 5 there, makes that a 2 and a 5. Makes these a 2 and an 8. 2 and 8. Don't know the order. So we've got 1, 2, 3, 4, 5, 6, 7. 6, 7 is what these are, and I know the order of that. That's a 7, that's a 6. That 7 looks down, makes that an 8 and a 7. That 8 looks up, makes that a 2 and an 8. That 7 looks down, makes that a 9 and a 9 and a 7. And a 9 and a 7. There's a 1 and a 4 missing in this column. That one can only be the 1. That one's the 4. So that's the 3 and that's the 1 in that column. Okay, so now we've just got so much Sudoku to do. This isn't a 1 or a 4, so it's a 6. So this is a 1 or a 4, but it's not a 1, so it's a 4. And this is the 1. This 7 means, of course, these aren't 7. This one's not 7 or 9, so it's an 8. So that one's a 9. That 9, I don't think does anything. Let's see. This isn't a 5 anymore. Neither of these is a 5, which means neither of them is a 3, which means it's a 6 and a 2. The 2 looks over and makes this a 3 and a 3, which makes that a 2 and a 2. The arrow now adds to 7. I'm doing much better than usual at remembering to add things. 9. I was glad at least someone in chat said that they also struggle to actually fill in arrows. There was boy oh boy, like one of the puzzles in the Arrow Sudoku app I was doing, and I think I spent an hour like trying to solve it after having, like, literally the only thing I needed was to fill in that an arrow was the sum of the 2 digits, and I did not find it. It was very bad. Let's see. That 2 looks up and gives me a 4 and a 2. Let's see. This looks like it's a 3. This looks like it's a 4. And it looks like the bet cell is a 7. Woohoo! Yes, welcome, Angelo. And the usually at the beginning of a puzzle, I will pick a cell, or the setter will pick a cell, and then everyone in chat guesses what it's going to be. And then if they guess correctly, then they are very excited. So congratulations to 57 Thorns, who do you just alternate between guessing 5 and 7 when you're guessing? Would make sense. Gorgeous puzzle. That one was amazing. I was very, very into that one. That was an excellent arrow showcase. Alrighty. I'm going to take a short break, and then we're going to continue our journey. And you have to balance it out, Jaleb, by occasionally picking a digit that is not at all possible to be in the puzzle. But anyway, we're going to I'm going to take a short break, and then we're going to return to arrows with a puzzle by Clover, even though it says unknown. This puzzle is by Clover. So we're going to come back, and we're going to do an arrow Clover puzzle. So look forward to that. I will see you all in just a moment. Welcome back, everyone. We are back with an Untitled arrow puzzle by Clover, despite it being listed as unknown. This is a Clover puzzle. Clover puzzles are always a delight. And I believe I was told that this puzzle would make me feel things, so I am looking forward to it. But I always enjoy when I get to do Clover puzzles around here. So first things first that I see. Yes, that would be fun, actually. Just have setters set puzzles and then see if people can guess. I have previously tried to get people to set puzzles where they try and mislead or try and set a puzzle that's not like them. So we get to do a trick that we've done before. Oh, we need a bet cell. I don't know that Clover is here. And this puzzle might be old enough that I'm not sure she would remember, but we're going to guess that this is the bet cell. Definitely if I were to submit a puzzle that no one would guess was by me unless it was labeled as by me, it would definitely be 2D wave particles. I think that is the least Zeta puzzle I've ever set. So the minimum sum of these digits is 15, which means that this digit needs to be an 8 or a 9, and this digit needs to be an 8 or a 9. Because of the fact of these things. Now, the fact that also these 5 sum to at least 15 and these 5 sum to at least 15 makes me suspect that actually these are both going to need to be 9, but I don't think so. Oh yeah, that would be fun. Chat gets to come up with a title. Let's see. Well, this is a length 3 arrow, so I should follow my own advice and fill 6, 7, 8, 9 in it. So while I think we do this. Okay, that's very smart. Okay. That's gorgeous. Okay. So where does this 8, 9 go in this box? And the answer is it certainly doesn't go in its own arrow. It certainly can't go over here. So the 8, 9 actually goes in one of these cells. But the same is true of this 8, 9. It has to go in one of these. And so actually they really are different. They are not... They are an 8, 9 pair. Which means that one of these sums to 16 and one of them sums to 18. So that's super cool. Okay. I am on board for this. Okay. By the way, of course, these aren't the ones. I don't know why I highlighted those. Red is in one of these 2 cells, blue is in one of these 2 cells, and those are an 8, 9 pair. Okay. So in total, these sum to 17 and these sum to 17. That's the way to look at this. So if these sum to 17, that means they always have a 1, a 2, and a 3. Because 17 and 5 is either 1, 2, 3, 4, 7 or 1, 2, 3, 5, 6. So there's always a 1, a 2, and a 3 in here. There's always a 1, a 2, and a 3 in here. And so one of these boxes is going to be a 1, 2, 3, 5, 6. And one of them is going to be a 1, 2, 3, 4, 5. They can't be the same, right? If they were the same... Oh, I mean, if they were the same... If they were the same, all of those digits would go here. Oh, yeah, that's the point. That's exactly the point. We're going to resolve everything. Because now where do 1, 2, and 3 go in column 5? Well, we know they don't go in any of these places. So 1, 2, and 3 go here, which means that this is a 6. It's not red. This is an 8 or a 9. So this is not red. This is red. And now these need to sum to 17 without using a 6. So I know what they are. There are 1, 2, 3, 4, 7. Now, these had better not be 1, 2, 3, 4, 7. So these are 1, 2, 3, 5, 6. Now, spoiler, the 7 is not on this side. Because that would make this way too big. Likewise, the 6 is not on this side. So one of these is a 7. And one of these is a 6. Let's see. And so, wait, I did that backwards. Sorry. No, I did that backwards. Sorry. I was right, one of these is a 7, but then I mirrored it wrong. These can't... Oh, no, these could be 6, actually. Sorry, that was a lie. But one of these is a 7, because I cannot put a 7 over here. So this is a 7 with a 1 or a 2. So the 3 and the 4 are over here. So there's no 3 over here. So there is a 3 over here. Oh, Josh Johnson has become a windmill. Welcome to the windmills, Josh Johnson. Thank you for your support. We greatly appreciate that. I should mention, by the way, if you're enjoying the stream, please subscribe if you haven't. And if you're interested in supporting the stream beyond subscribing, you can join on YouTube by clicking join down below. Or you can go to Patreon and go to patreon.com/zetamath, and then you can become a patron there. Either way lets you support us, and you get some cool perks. Like, for example, we always do the most voted on puzzle every stream. I did not actually say this like I should have previously, but the puzzle we just did, this puzzle by Playmaker that was awesome. This was the supporter voted on puzzle that we did for this week, and it was awesome. The supporters always pick something awesome. So anyway, if you want that kind of sway around here, I greatly encourage you to do that. All right. So this is this a naked single? This is probably a naked single, right? It's not 1, 2, 3, 4. It's not 6. It's not 7. It's not 8, and it's not 9. Yeah, this is a naked single. It's a 5. I don't know if that does us any good, but it's true. This can't be 1, 2, 6, because if this is 1, 2, 6, this would be 7, 7, and 7 plus 7 is too big. So this can't have a 6 anymore. The 6 really is over on this side. So if there's a 6 on this side, there's not a 5. Fun fact, not a 5. And 1 plus 6 isn't big enough. So 1 plus 6 was only 7, and this needs to be at least 8. So this is 2 plus 6. Okay, so we're and so blue is 8. Red is 9. We've got some dancing to do, because we missed our opportunity to dance before. So we'll now do the plethora of digits dance. Penguin. Thank you, Zach. Much appreciated. So that does some more stuff. So now this just is 1, 3, 4. This is 2, 7. These are 1, 3, 5. You can verify that 1, 3, 5 does in fact add to 9. And I want to fill out the rest of these columns, because I bet some cool stuff happens. So we've got 1, 2, 3, 4. We need a 5, a 6, a 7. Not a 6. We've got a 6. An 8 and a 9. This one's not an 8, of course. This column needs a 4, a 6, an 8, and a 9. That one's not a 9, of course. Or a 4. This one's not a 5, by the way, either, because there's a 5 in the box. In fact, actually, I know what these digits are. I should have done that first. These digits are exactly 4, 7, 8. So this is not a 7, it's a 9. This isn't an 8. It is a 4 or a 7. So these are not 9. One of these is 9. It's not that one. Because this circle is at most 8, this can't be 8, because I need to make these things add up. In fact, actually, this is now forced. This is gorgeous. What's the minimum that this arrow can sum to? It's if this is a 1 and a 2 and a 5, and that makes 8. So this has to be 8. These are a 1 and a 2. This is a 3 now. This is a 3 because of that. These aren't 3. This is a 5. This is now N7. N7. Yes, good, good. These aren't 8. So now this is 8 because of the 4, 6, 9 triple, or 8 in the column, or whatever universe you would like to exist in. All right, so this is a 4, 6, or 9. It cannot be a 4 because this is at least 4. So this isn't a 4. This is not a 4. What's the minimum these cells can sum to? It's 4, right? Yes, the minimum these cells can sum to is 4, because they can't sum to 3 because of this 1, 2. So that's at least 4 plus 4. This needs to sum to at least 8, so it has to sum to 9. This digit's at least 4. So this digit is 4, 5, 6, or 8. And so this digit is 5, 4. Well, it's not 5, so this isn't 4. 3 or 1, just for the record. If this was a 6, this would need to be a 1, 2. That's not going to work, so that's not a 4. Sorry, so this isn't a 4, to be clear. So that's not a 4, that's not a 5. These need to sum to 5. So they are either 1, 4, or 2, 3. I don't think I know which they are yet. This isn't a 4 or a 9, so this is a 6. We should probably figure that out. This 8, we know what it is. It's got to be a 3, 5, because it can't be 1, 7, and it can't be 2, 6, owing to this. So this is a 3, 5, and we know the order even. That 3 looks over, actually, and gives me a 1 and an 8. And now this isn't a 1, 4 arrow, it's a 2, 3 arrow. That 1 looks over and gives me a 2 and a 1. Let's see. Let's fill in this row, see what happens. We've got 1, 2, 3 already. We need a 4 and a 5 and a 6, and then we've got the 7, 8, 9. Okay. I know this one isn't a 5, for whatever it's worth. I don't think I know anything over here. These digits are a 6, 7, 8, 9. These aren't 8. These digits are... Let's see, we've got a 1, 2, 3. We need a 4. We got a 5, 6. We need a 7. We've got an 8. And we need a 9. There are 4, 7, 9. This isn't an 8. So this is either... This 8 is looking at a 5. So this is either 1, 7 or it's 2, 6. I'm going to fill in. This has got to be at least 5, of course. So this is 5, 6, 7, or 8. This also has to be at least 5. So this is... Oh, this is at least 6, actually, because this one can't be 1. So this is at least 6. So this is 6, 7, or 8. Let's see. Now, where do I look? Let's see. The 8 in this box is pushed up into this corner. It's not... Ah, here we go. this 9 does not go there. So the 9 in this box goes over here. So the 9 in this box goes here. Does it go here or here? Well, it doesn't go here, so it goes there. So that's the 9. Great, okay. So now these two need to add to 9. One of these is a 9. It's certainly not that one. Okay, so now this is at most a 7. But it's at least a 5. So this is 5, 6, or 7. I think 5 is still possible if this is 1, 4. Oh, that's a slick spot. So a couple of people in chat are noticing that 9 in column 2 is actually cleverly ruled out of everywhere but here, which places a 9 here as well. That is a very good spot to all of you who saw that. Not 9. Not 9. Not 9. And now we learn the value of the bet cell, which is that the bet cell is an 8. So congratulations if you bet 8. Now 8 goes in one of these two cells in this box, but 8 can't go here. So 8 has to go here. And so this is now either 8 with a 4 and a 4, or 8 with a 2 and 6. So this is 2 or 4 only now. Hey, if you got the parity of the bet cell right, you still have something to celebrate. Let's see. I know that the 8 over here is in one of these two cells. Ah, right. This isn't an 8, and this isn't an 8 either. Right. The 8 over here is here, because the 8s just push it over into this row, but it can't be there, and it can't be there because this would sum to 6 or 7. Can't be there. This can't be a 6 anymore, because this needs to be at least as big as 2. In fact, this is now at most 3. Which gives us a 2-3 pair in the column, actually, interestingly enough. Let's see. Pair in the column. Okay, 8 is up. Oh, 8's placed here. Okay, let's do this the easy way. 8 is placed here, just literally by Sudoku. It might be the last 8 in the grid, in fact. It is not quite the last 8 in the grid, but that's the last 8 in the grid. So this cell is not blue, and this cell is blue. Oops. This cell is blue. So 8 goes with a 1. 1 is the answer to the question, what goes with 8 to make 9? So that's not a 1. Let's see. So now one of these two is a 1. I don't love that. I'm going to be honest. Let's see. We're like making our way to a 1, 2, 6, 7 quad in this row, funnily enough. I guess we're making our way to a 1, 2, 3, 4 quad in this row. Also seems fun. Let's see. Oh, let's see. Someone has figured out that this has to be a 2. If this was a 4 and a 4, what goes wrong? Let's see. If row 1, column 2 is a 5, where do 6 and 7 go in column 2? That's a good question. Yes, if this is a 5, I have now put too many low digits in the column. So this can't be a 5. Has to be a 6 or a 7. And I guess this could be a 7 with a 1 and a 6, maybe? Possibly? Ah, there we go. Okay, yes. So this can't be a 2 for a fancy reason that Sayori points out, which is if this is a 2, then these are a 1, 2, 3, and these are at least 4, 5, but they don't add up to 9. So this actually can't be 2, which makes that a 4 and a 4, and a 7 and a 6. Gorgeous spot there, as always, from Sayori. So 1, 7 there. It's 2 and 1. Isn't that the same thing I said, Derek? I guess to me those are equivalent, but I know that like how you see Sudoku deductions is a very personal thing, so I would not want to judge anyone for seeing them differently. Let's see. Well, this can't be 6 anymore, because it can't be 2, 4, or 1, 5, which are the only ways to make 6, so this has got to be 7. And it can't be 1, 6, can't be 3, 4, so it's 2, 5. So now this column, 1, 2, 3, 4, 5, 6 has to go here. Which does something, maybe, possibly. Someday it might. 4 is up here somewhere in this box. Oh, hey, FK, how are you? Let's see. 8 is up here somewhere. Oh, no, 8 is not up here somewhere. Never mind. I have all the 8s. I should not try and place any more 8s. If I try and place more 8s, stop me. Let's see. 4, 8, 7. Oh, row 8, I am being told I can do more work in, which seems to be true. This is a 7 and a 4 and a 5 and a 6, and therefore that's a 7. That needs to be a 2, making that a 7 and a 2 for multiple reasons. That 7 makes that a 1 and a 7. The 2 goes up here from those two 2s. Let's see. This row needs a 1, a 3, and a 4 to finish. That one's not a 1 or a 4, so it's a 3. This one's not a 1, so it's a 4. That one is a 1. That's a 3 and a 4. So we've got all of that hoovly-woo. 1 in this box now has to go here. That 2 looks down and sees the 2 and the 3. This column has a 1, 2, 3, 4. It's missing a 5, making that a 3. That 5 looks over and makes that a 2 and a 5. That 5 looks over and makes that a 1 and a 5. These two cells are 5 and a 6. So it's a 6 and a 5 in that order. This cell now sees everything except a 3. So these are a 5 and a 9 in that order, I believe. These cells are a 4 and a 3, I believe. And I think somehow inexplicably that's not resolved. These cells are a 1, which has to go up here. 2, 3, 4, 5. A 6 and a 9. So they go in like that. So this cell is a 4 or a 7 for the row, and it's not a 7, so it's a 4, and a 7 and a 4, and a 3 and a 4. These two cells are a 2 and a 7, I believe. 2 and 7? Did I do that right? Yes, 2 and 7. So the 2 goes there, the 7 goes there. That 2 looks over and makes that a 6 and a 2. I need a 3 that needs to go there. And a 6. And there we go. gorgeous little puzzle from Clover, to the absolute surprise of no one who's ever done a Clover puzzle. That was amazing. Very nice, and yeah, very smooth, very good showcase of the sorts of logic that can come up. And I think this is doing a great job of sort of showing off all of the very wide variety of deductions that you can show off in Arrow Sudoku. Like, Arrow Sudoku puzzles really come in a lot of different flavors. And, well, we're going to keep doing more flavors. Because next up, we are going to do this arrow puzzle by the world's tallest cat. So let's look at this Tallcat arrow puzzle next. So let's first look at our length 3 arrows and write in that they're at least 6, 7, 8, 9. And this one also has to be at least 6, because these two are at least 3, and these two are at least 3, so this is 6, 7, 8, 9 as well. Yeah, when I looked in my this one is super old. Yes, this is I think Tallcat said his first LMD post. Yeah, when I looked at the bucket had a lot of arrow puzzles. So it seemed like it would be a fun thing to go through and work through some of the arrow puzzles. It turns out I think at some point I started liking arrow puzzles. Whereas, like, for a long time I was sort of, like, very sick of arrow puzzles. Let's see. Okay, this box, actually, this is interesting. Because these sum to at least 15 before you even add in these two. So actually, these two sum to, at a minimum, 15 plus 3 is 18. So these sum to a minimum of 18. So these both have to be 9. These are 1, 2, and these are 1, 2, 3, 4, 5. Okay, so we get to do the 9 dance, as we do. Whoop, 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 whoop. The 9 dance. Whoop, 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 whoop. Boop, boop, thank you, Zach. Much appreciated. Tall kitten puzzle. I love it. Yes. So let's update our pencil marks just a smidge. There can't be a 3 here because these two need to add to 6. So there is a 3 on this arrow. So this is either 1, 3, 5 or 2, 3, 4. Let's just go fill in that these are 6, 7, 8, 9. Let's see. 9 in this box is pinched to going into one of these two cells. These two cells are now at least 3 and 4. So this is at least 6. Sorry, at least 7. And there's always a 3 on this arrow, and it's from 3, 4, 5. We've gotten to do that step a number of times. This is not a 9, which means there's always a 1 on this arrow at the very least. This isn't a 9, so there's always a 1 on this arrow, at least. This could still be a 9, right? I think it could. Good point. The 1, 2 pair is looking at this cell. So one of these two is a 1, which means none of these are 1, which means now this needs to sum to 6, so it's 2, 4. Means these are a 1, 3, 5 flavor of this. So now no digit on this arrow is a 2, so it can't possibly be a 6 or a 7, so it's an 8, because a 1, 2 pair looks at this, and a 2, 4 pair looks at this. So this is now an 8 arrow. So it is a 1, 3, 4, 8 arrow. The 4 has to go here. This is a 1, 3 pair. So that 1, 3 pair looks there, making that a 5. These aren't 5. This column... Oh, that's not a 1 either, while we're talking about things that aren't 1. This column... Oh, interesting. This column has a 1, 2, and a 4 looking at this cell. So this can't be a 7 arrow anymore. It can only be a 6 or an 8 arrow, while I fill these in. 3, 4, 5, 6, 7 is what's left. This is not a 3 or a 5. It is a 6 or a 7 only. You can't put a 6 or a 7 on an arrow that adds to 6 or 8. So this is 3 or 5. We've got that. 8 is gone from these cells. So one of these two is an 8. So one of this myriad of cells is an 8. In fact, actually, I can fill in these cells. We've got 1, 2, 3, 4, 5. These are just 6, 7, 8, 9. So this cell being at least a 6, it's never a 9 because it's on an arrow. This cell being at least a 6 means actually this digit's at least a 7. This digit's never very big. It can only be a 1, 2, or a 3. Because of that. Let's see. 7 not possible on row 3, column 9, arrow. Ah, right. If this were a 7, this would need to be 1, 2, 4, but it looks at a 1, 2, so this is not a 7. Thank you, Ranksk. That is an excellent point. This is... I guess I don't technically know, I don't think, that this is at least anything. I mean, I guess I know it's at least 4, but that's not super exciting. Oh, that's right. We need a bet cell. We'll make that the emergency bet cell. We have added an emergency bet cell. Let's see. If this is an 8, it's 1, 3, 4. So this would be the 4. Yeah, I guess the point is, what is this digit? This digit shows up on this arrow. So by virtue of showing up on a length 3 arrow, this digit is from 1, 2, 3, 4, 5, 6. Except it's not 1 or 3 or 5. So this digit can only be 2, 4, or 6. It can't actually be 6, because the only way it would be 6 is if this was a 1, 2 pair, and it can't be. So this digit's only 2 or 4 out of all the things in the universe. Which is fascinating. So if this is an 8, then this is a 4. Because if this is an 8, this has to be 1, 3, 4. It can't have both a 1 and a 2 in it. If this is a 9, then does that mean this is a 2, 3, 4 in the instance that this is a 9? Yeah, because it can't be 1, 2, 6. So it's got to be 2, 3, 4. Okay, so this digit's always a 4, is the point. Oh no, sorry, it's not always a 4. Sorry, it could be 2, 3, 4, but the 4 could be over here. Never mind. I was not correct. Let's see. Ah, there's always a 3. That's a good point. There's always a 3 in one of these two cells. Yeah, and that is a virtual 1, 2, 3, 4 quad. So the concise way that some people in chat have said it's a useful thing to remember is that if you're making a 3-cell arrow, it always needs at least 2 of 1, 2, 3. Because if it doesn't have at least 2 of 1, 2, 3, then it adds to at least 1 plus 4, 5, which is 10, which is too many. So So I have one 1, 2, 3 here. And I have, these are all at most, 4. I guess I should have written in, actually. I know that these are at most 4, right? It's not even a virtual 1, 2, 3, 4. It just literally is a 1, 2, 3, 4 thing. Because the only thing this can be as a 9 is 2, 3, 4. And the only thing it can be as 8 is 1, 3, 4. So this isn't even a virtual 1, 2, 3, 4 triple. This is just a straight up 1, 2, 3, 4 triple. So these are from 5, 6, 7, 8, 9. That one's not a 9. Well, this one's certainly not a 9. Or an 8. Because this is... So, that's actually very interesting, because now that tells me that this digit has to be at least as big as 6. And it can't be a 9. So this is from 6, 7, 8. I guess the sum of these needs to be at least 10, but that's not exciting. One of these two is a 9. But that's not super exciting. These is a 9, but that's not super exciting either. Let's see. If this is a 6, this is a 1-2 pair. If this is an 8, this could be a 1-2 pair, or it could be a 1-4 pair. So these are always from 1, 2, 4. I can fill in, I guess. Row 9, column 6. Let's see. So at absolute most, this can be a 6? Can it really be a 6? No, it can't be a 6, right. This can't be a 6. Got it, okay. So this can't be a 6, because that would make this a 1 and a 2, which would make this a 9. Can't be a 9. So this can't be a 6, it can't be a 5. So this is at most 4, but it's not 1 or 3. So this is only 2 or 4. Which miraculously gives us a 2-4 pair in the column. That was a fantastic spot, by the way. To Carl there, I believe. No, to J40 there, sorry. So we've got 1, 2, 3, 4, 5. These are from 6, 7, 8, 9 only. No, not 9. 6, 7, 8 only. We already have the 9. Okay. What did that do? Again, the traditional Tallcat puzzle will sort of lull you into a false sense of security and then pounce once you have relaxed. Is definitely the Tallcat MO. Let's see, there's a 4 down here somewhere. I don't think that's where I'm going to find my joy. I should fill in this digit. This digit can only be 1, 2, or 3. That is worth noting, I think. Today is the arrow special. That is correct. We did sort of opened with an arrow tutorial where I went over what I consider the sort of like the intro arrow stuff, and now we're just doing random harder arrow puzzles. I mean, not random, harder arrow puzzles from the bucket. But last time, one of the pieces of feedback I got from last time sort of tutorial was, I wished we'd done more Kropke puzzles after we did the Kropke tutorial. So we're going to do more arrow puzzles after we did the arrow tutorial today. So you can apply what you have learned. Can we avoid using a 1? That's a good question. So if I don't use a 1, this would be at least 2, 3, would be 5 plus 2, would be 7. Oh, your arrow puzzle is still very much going to get done today, Kuraban. Don't worry. I'm definitely not going to punish you for saying your arrow puzzle probably wasn't good for the tutorial. I'm definitely going to do your arrow puzzle today. Let's see. Okay, so if this is a 4... Okay, so here's the argument from Gary. And if this is a 4, this now requires a 1, which makes this a 1-8. Which means that this is a 4 adding only to 7. So this becomes a 4 with a 1-2. I don't quite see far enough ahead to see it yet. Oh, right. Sorry, I missed one of the effects. There we go. Okay. So if this is a 4, then that means these have a 1 on them. Together with that 1, that puts a 1 here. That 1 is accompanied by an 8. Here's the thing I didn't see. That makes that a 6 and that a 7, which means that both of these arrows need to have a 1-2 on them. And so, in this, remember, in this hypothesis, this is a 4. And so the 1 and the 2 go on the 9 arrow, and 1 plus 2 is not 9. Very nice. Okay, so that's a 2. That's a 4. This is not a 2. These are not 2. Sorry. These are not 4. Oh, interestingly, I seem to know that one of these is a 3. But the, that was tricky, but it was very, very, very cute. Yeah, I have no idea if it was intended, but it was a very natural thing to look at. Like, I was kind of squinting at it, I just wasn't squinting for far enough, ahead. So, I don't know if this is Tallcat's first puzzle. I think this is Tallcat's first puzzle published on LMD. I'm not sure if it was actually Tallcat's first or not. Okay, so now the fact that there's a 2 there tells me that the 7 in this box is down here. I would really like to get a deduction about 7 in row 9, but 7 in row 7, but I don't have it yet. Okay, so what if there's not a 1 here? If there's not a 1 here, or do I want to do if there is a 1 here? Oh, if there is a 1 here, it just doesn't work. If I put a 1 on this arrow, it joins the 1 on that arrow, so this is going to be a little complicated. If I put a 1 in either of these spots, it joins this one, which makes this a 1-8, which makes this a 6. Except this can't be a 6 anymore, because in this universe, this now has to be a 1-3 with a 2. If that's a 1-3 with a 2, I guess that means the 1 was there. Sorry, maybe I didn't actually break it. I thought that broke it, but that does not quite break in that many steps. It just puts a 2 here and a 2 in one of these cells. Can this possibly be a 5? Is that what I'm supposed to ask? If this is a 5, then this is a 1, then this is a 2 and a 1 specifically in that order. And that's an 8. Let's see. Either way, row 7, column 8 is at least 7. Okay, let's look at that. So if there's no 1 here, then this would be at least 2 plus 3, which would be 7. If there is a 1 here, then through the method of madness that we looked at, this is a 1-8, so this is a 1-3, that's a 2, so this is at least a 4 and a 1, so yeah, so this is always a 7 or an 8. I agree with that assessment. So these need to sum to at most 6. So I suppose I can fill in that these are from 1, 2, 3, 4, 5. That one's not a 2, of course. One of these is a 2. H does not work in row 7, column 8. Okay, if this was an 8, what would go wrong? If this was an 8, this would be either 1, 5 or 2, 4. That's right. To make an 8, you can't use a 1. That's true. Okay, so if this wants to be an 8, because of the fact that as soon as I use a 1 here, it makes an 8 appear here, I need to make an 8, which means I'd need to put 4 here and 2 here. So the 4 here would make that a 1, that a 2, oh, but that can't be a 2, because that's a 2. Right, okay. So, this is actually not that complicated. I was making this way more complicated. Here's the point. If this is an 8, I can't use a 1, so this is a 2, 4. But that's both 2s for these rows. So there can't be a 2 on this. So it can't sum to 6. So it also sums to 8. And that does not work. So this is a 7. Meaning that's not a 7. Okay, so these need to sum to 5, so they don't include a 5. And since this can't be 2, this can't be 3. can't be 2 plus 3. So if there's a 2 here, it does rule 2 off of all of this. So this now has to sum to 8 as 1, 3, 4. So, okay, so let's look at this. So it makes this 1, 3, 4. Oh, but I don't have a place to put the 3. Right, okay. So if I try to make this 2 plus 3, it rules 2 off of this, making it not able to be a 6. It's an 8. But it's an 8 without a 2, so it's 1, 3, 4. But where does the 3 go? Just look at our pencil marks. That can't be a 3, that can't be a 3, so that's a 3, except we've started this whole proposition by putting a 3 there. So that's not a 3, that's not a 2. There is a 1 on this, which means this is a 1, 8 arrow, which means that this is a 6. It means that's a 3. That's a 1, that's a 2, that's a 4 and a 1. That 1 sees up that that's a 3 and a 1. This isn't a 1 anymore. That's not a 1 anymore. Yeah, that was cool. Let's see. Probably lots more Sudoku stuff. What's this digit? This digit is, well, there's a 2 in one of these two slots. Okay, let's fill in the rest of this row. We need a 2, a 3, a 4, and a 5, and then we've got 6, 7, 8, and 9. But this is not 2 or 3. This is only 4 or 5. These aren't 4. So this is 2, 3, or 5 only. I can clean up this column a bit. That's a good point. Yes, that's great. So the 5 in this column is down here. So this is not a 5. It's a 4. Good spot to Garion, as always. So that 4 looks up and tells me that's not a 4. Let's fill in the rest of this box. We've got 1, 2, 3, 4. We need a 5. We've got a 6. We need a 7, 8, 9. Sure. I don't know that that helped me as much as I would have hoped. Actually, interestingly, this digit can't be 1, 2, 3, or 4. So this digit is 5, 6, or 7. Meaning this digit's the smaller one. So this digit is 3 or 4. 3 would go with 6, 4 would go with 5, 7 would go with something that doesn't work. So this is only 3 or 4. This is 5 or 6. I am told I already have a 6 in box 7. Oh, hey, how about that? That 6 makes that a 5. Means these aren't 5. Means these aren't 5. Row 8, column 3. Yes, row 8, column 3 sees that 6. So now this is a 7. Good, good. So these aren't 7. That, by my pencil marks, places the 7 down here. Good, good. This isn't an 8, by the way, because there's an 8 in the box. So this is a 6, speaking of things that I should have figured out. Which makes that a 5 and that a 4. Makes this 1, 2, 3, 4, 5, 6, 7, 8, 9. What did I miss? 1, 2... Oh, I said 3, but there wasn't actually a 3 to see. So these digits are a... Let's see, no. We've got a 1, 2, 3, 4. We need a 5. We've got a 6, 7, and we need an 8 or a 9. So this could be 5, 8, or 9. This 7 gave me a 6 up here. That 6 rules 6 off of all of these. Now the minimum these two things can add up to is 9. Thank you, Sayori. So that's a 7 and a 2. These aren't 7. That 9 looks down and says, this isn't a 9. These two things need to add to 5, and this one's a 3. So that one's a 2. So that's a 3 and a 2. Good. These aren't 9. So that's the 9 over there. So these aren't 9. These aren't 7, by the way, while we're cleaning up. That 2 looks over and makes that a 1 and a 2. That 3 looks up and makes that a 5 and a 3 and an 8. Meaning these aren't 8 either. That one's not 5 either, so one of these two is 5. Let's see, if this were 6, it would have to be 1, 5, and it can't be, right? So this can't be 6 anymore, because it can't be 1, 5, or 2, 4 here. 5 there, 2 there. If this were 7, this would need to be 1, 6. It's the only way that works. If this were 8, this can't be 8 either. Because if this were 8, this can't be 2, 6, and it can't be 3, 5, so it'd have to be 1, 7, but it can't be, because 1 and 7 look at that cell. So this is a 7. And this is 1, 6, and we know the order. I don't know if it did anything, but it's true. So now the 1 in this box goes here exactly. So that's a 3 and a 1. That was sweet. Okay, so now these digits are a 4, a 5, a 7, and an 8. These aren't 7. So that's not 7, and those aren't 7. Actually, probably I should figure out what this is, huh? So this isn't a 1, by the way. So this can only be 2 or 3. 2 plus 5. No, it can't be 3. What am I talking about? This can only be 2 plus 5. Oops. Uh-oh, I broke it. What did I do? One moment. Wait, no, it is a 1. What am I talking about? It is a 1. It's 1 plus 6. How did I rule out 1? I don't know. 1 plus 6 is the only way that works. I did some amount of nonsense there that we should not talk about. So that's an 8, meaning that's a 5 and a 3. Now we've got to write in this cell 1, 2, 3, 4, 5. This is a 6. 1, 2, 3. That's a 4. That 8 gives us a 9 and an 8. Means that's not an 8. That 5 gives us a 4 up there. So that's not a 4 or a 7, so it's a 5. That is a 7. Let's see, these two digits. Oh, let's do the Sudoku first. That's a 2 and a 4. That 6 means that's a 7 and an 8. So these are a 6, 9 pair. Let's see. These two digits are a 2 and a 3. 2 goes there, 3 goes there. These digits, I need a 2, and it goes there. I need a 5, and it goes in one of these two places. I need a 7, and it goes in one of these two places. So this is a 5, 7 pair. Oh, no. The 7 actually goes there exactly. The 5 goes there exactly. 2, 3, 4, 5, 6, 7, 8, 9 goes there. That resolves the 6 and the 9. The 1 resolves the 8 and the 1. This column... let's see. Let's do the row first. That gives us a 9 and an 8 and a 9. We've got to fill out this box. 1, 2, 3, 4. That's a 5. These are 1, 2, 3, 4, and 6. 6 goes there. 4 goes there. 1, 2, 3, 4, 5. 6 goes there. And we've got 1, 2, 3, 4, 5, 6, 7, and an 8 goes in the bet cell. Bet cell was an 8. Sweet puzzle. I enjoyed that a lot. This bit was tricky with the ones and figuring this out. I wonder if there was some slick way to figure out that these both needed a 1, but it was very very well telegraphed. And yes, this is how Tallcats are born. What a puzzle. Very cool. I enjoyed that a lot. Very nice. All right. Yeah, there's just so much cool stuff. Yeah, this is a very neat puzzle. All right. Should do a stream exclusively looking at Sutter's first puzzles. I mean, I've done my first puzzle on stream before. My first puzzle was kind of difficult, as you might anticipate. Alrighty, let's do kurabans next. So this is still just an arrow puzzle, but we have arrows that are running into each other's circles. So we've got which was your first puzzle, Naverio, that I did? I don't recall this, but was Dynamic Duos your first puzzle? Do you have a suggested bet cell, Kuraban? Oh, wow. A Very Odd Killer was a great puzzle. That is an amazing first puzzle. I would be very proud to have that as a first puzzle. I mean, honestly, I don't think it's that much less insane to have a Very Odd Killer be your first puzzle instead of Dynamic Duos. Row 9, column 1. That is our bet cell. Place your bets. I see now we have the feature that I can make my lines in a variety of colors. Like I could make a blue line now instead of just a green line. That's awesome. But place your bets. This is our bet cell. As we try to work out what is going on in this insanity. So we've got a bunch of inequalities here to start with. So first of all, I want to note, I know that 9 in this box is up here because it can't go on an arrow, and every other cell up here is on a blue arrow. But also, we've got all these sort of complicated things. So, like, blue is bigger than green, which is bigger than other blue, which is bigger than purple, which is bigger than orange. So we've got that going on. Wait. Oh, no, this arrow does this sort of who's-y what's. Okay, so 2 of these hang out of the box. So if I calculate the sum of the blue cells, these sum to at least 21, 22, and then this is at least 3, 25. So the blue cells sum to at least 25. 25 divided by 3 is a smidge more than 8. So actually, just by doing the math, this is a 9. Which means we get to do the 9 dance. Doo-doo-doo, doo-ba-doo, 9 dance, doo-doo-doo, doo-ba-doo, 9 dance, doo-doo-doo, doo-doo-doo, 9 dance, doo-doo-doo, doo-doo-doo, ah! 9 dance, doo-doo-doo, doo-doo-doo, doo-doo-doo. Thank you, Zach. What a champ. Fell down, but still finished the dance routine. Oh no, aren't there 4 arrows? Oh no. Do we need to rewind? We might need to rewind. Sorry, Zach. One number is counted twice. Okay, so let's hope that we can still the middle arrow branches. So these two are the same as these two. So maybe this wasn't correct. Was this correct? Let's see. Okay, so okay, I'm now confused. Okay, so the branching is the problem. So we actually, in order to calculate this, we really need to sum 4 arrows, which is these plus this cell twice. So this cell twice would mean this box is at least 22. This is at least 2, 24, 25. So this is at least 25. 25 divided by 4 is more than 6. Okay, so maybe we should start trying to put these things in order. So I'm going to just, across the bottom, try and write these things in order. Oops. So orange is the smallest of all the colors. So we've got orange is less than purple, because orange is on purple's arrow. Purple is less than blue, because blue is on purple's arrow. Blue is less than green, because of that. Green is then less than red. Red is then less than cyan. I don't really have a cyan. I'll just make it this other blue. And so what that means is if I go 9, 8, 7, 6, 5, 4, this digit is at most 4. This is at most 5. And we've got some extras hanging off. Like this green is actually bigger than both of these, but this number could be one of these numbers down here. 9, 8, 7, 6, 5, 4. So let's look at this carefully. So 9, 8, 7, 6, 5, 4. So this is certainly at most 4, but it's at least 2. So this is 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8, 7, 8, 9. And I bet we can improve these if we look closely. Note, by the way, these cells, this is not marking for the cells. This is just marking for the bulbs of the colors. Okay, but if this was 4... Some people in chat were saying if this is 4, it causes a problem. So if orange is 2, it makes both of these 1. And if both of those are 1, then green is at least 2 more than red. I can see that coming up. Oh, if both of these are 1, okay, so here's an easier deduction. If orange is 2, purple still can't be 3. Because if orange is 2, these are both 1, and now this is at least 2. And so in that instance, purple is still at least 4. So what I can do is I can strip the smallest out of all of these. So I think this could be 2, at least as far as I can tell. But I do that. So this is only 8 or 9, is the punchline of all of this. If orange is 2, then cyan is at least 4 more than green. Okay, so if orange is 2, I mean, ruling out orange is 2 at this point isn't really going to do much for us, but let's have a look. So if orange is 2, then that cell's not a 1, so green to red goes up by at least 2. But then blue to red goes up by at least 2, and so both of these cells become at least 2. But then that bumps up our maximum by too much. It bumps up our maximum by to 10. So that doesn't work. So I agree. This can't be 2. This is only 3 or 4. Just select all the cells on the arrows, not circles, through the chain min is 9. But these two cells could be the same. But there are tons of cells I can mark that can only be 1 or 2 now. So for example, red is 7 or 8, green is 6 or 7. This cell can only be 1 or 2. Likewise, green and blue. We've already proven the difference between them is at most 2. So this is 1 or 2. Cyan and red, their difference is 1 or 2. Blue and purple, their difference is 1 or 2. Purple and orange, their difference is 1 or 2. And so we've got all these 1, 2, 3s, or sorry, we've got all of these 1, 2s floating around. Column 3 and 4. So, if orange is 3, this is a 1, 2 pair. Okay, I think I think what Kuraban wants me to do is to say purple is equal to this cell plus this cell plus this cell. It doesn't look enticing. I mean, this is at least 4, but we know purple's at least 4. I am noticing that like these cells really want to be 1s or 2s. I guess is the question, can both of these be 1? maybe that's the question. No, we already resolved that. They can't both be 1. So you want me to say purple is this sum. So blue is this sum. Green is this sum. Red is this sum. And cyan is this sum. And then, so cyan is, through some sort of messy combination, this sum. And so these each sum to at least 3 in the columns. And then 3 and 6, 7, 8, 9. And so that does give you that cyan is 9. Yeah, that works. I'll buy that. Don't think it tells me anything. It tells me cyan is 9. I mean, I know these things have to be 1 or 2, but they're already marked as being 1 or 2. So, in particular, this cell is 1 or 2, and this cell is actually 1 or 2. Well, Zach was right. Zach is very happy about that. Oh, I guess, yeah, so it does mean these all have to be 1s. So it does do more than I originally thought. It does mean all of those are 1s. Right. And that being a 1 means that's a 2. So this is a 1. So that's a 2. And that's a 1. Okay. So let's fill this in from the bottom then. So orange is 3. So this is 4. So this is 5. So this is 6. So this is 8. Okay. And then we can get rid of this. What? No? Oops. So the whole point, as I understand it, is that the sum of the highlighted cells is 9. And because the sum of the highlighted cells is 9, these 3 cells have to be 1. Because they can't sum to more than 9, and these cells sum to 6 at minimum, because they're all 1 or 2. So these are all 1. That's the point. Well, this cell had to be a 1 or a 2. If this cell has to be a 1 or a 2, and it's not a 1, it has to be a 2. So that's a 1. Oh, your point is, okay, I see. So your point is, this is a 1 or a 2, but I don't actually know how the 1 and the 2 go yet. Okay, I guess I believe that. I guess, okay. But this is still a 9. So this is still an 8. And so this is a 6 or 7, going down to a 5 or 6, going down to a 4 or 5, going down to a 3 or 4. Okay. So these are at least 5. And so this needs to be sum to at most 4. It can't be a 1 or a 2. So this digit is a 3 or a 4. I can't not put a 2 in here. There has to be a 2 in these cells. So these are from 2, 3, 4. Because these need to sum to 5 or 6. That does give me a 2, 3, 4 triple in the column, for whatever that's worth. Oh, but this digit can't be a 4 because of the bent arrow. So this is only a 2 or a 3. One of these is a 2. So this is either a 3, 6. In which case, this is a 2, 4... whatever. So this is 3, 6, or 4, 5. I don't think I know which one yet. I know there's an 8 up here. I suppose I should look at this 5, 6 arrow that's actually quite large. So this is at least 3 plus 2. This is already at least 5. And so I only get 1 degree of freedom over that. So this could be a 1, but if it's not a 1, so this could be a 1, this could be a 2, and this could be a 2. That's the minimum. So this could be a 3 as well. This could be a 3 as well. But this can't be a 3, because if this were a 3, that would increase the minimum by 2. So I agree with, I think it was Carl who earlier said this always had to be a 1. I agree that this is a 1. So one of these is a 1. Right. Okay, that's the point. So I said this is either 3, 6, or 4, 5. But as the Cogito points out, it can't be 3, 6. Because one of these two numbers is a 6, and they both see this. That's gorgeous. So this is 4, 5. I like that. So that's a 4. That makes this a 4. It means orange is a 4. So that's a 2 and a 1. Oops, and a 1 and a 7, which makes that a 2 and a 3. That's a 6, and that's a 5. This is really a 2-3 pair now. Let's see. So these are an 8 and a 6. Oh, and I know where the 6 is. That's a 6, that's an 8. Yeah, so this has got to be a 7, because it can't be an 8. So this now can't be 3, 5, or 1, 7, so it has to be 2, 6. Oh, no, it could be 4, 4. No, it can't be 4, 4 either. This can only be 2, 6. I don't know the order yet, though. This arrow can't be 1, 6. So it's either 2, 5 or 3, 4. If it's 2, 5, this can't be the 2, so it would have to be 2, 5 in that direction. If it's 3, 4, it's 3, 4 in that direction. But that cell can't be a 2 either. Actually, neither of these cells can be a 2, because that one sees the 2, 6 pair, and this one sees the actual 2. So this is a 3 and a 5. So this 3, 5 can it be 2, 3, or 1, 4? This cell can't be 2. This cell can't be 2. So it's not 2, 3. It is 1, 4. And so it is 4 and 1 in that order. 3 plus 5 is not 7. 3 plus 4. There we go. Okay, 3 and 4. So that actually makes this much easier, I think. Because this is certainly not 2 and 2, so it's got to be 1 and 3, and we know the order. So actually, this universe is much easier than the puzzle that I was previously solving. That 3 looks over there and makes that a 2, now makes that a 3 in order to make this add to 6. Let's see. Let's just fill this in, because probably that's going to make this collapse too. 1, 2, 3, 4, 5, 6, 7, 8, 9. This isn't a 9 because it's on an arrow. This isn't a 2 either, because if it was a 2, this would need to be a 3. So that's a 7 and an 8. This is not a 2 or a 7, so it is a 9. So that's the 2. These digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. These aren't the 7, so that's the 7. These two digits are a 5, a 5, and a 6 in some order. These two digits are a 3 and an 8 in some order. Oh, I know the order actually for this one, 8 and 3. So we want to look at this cell now. Oh, this 5 actually sees that 9 and 5. We want to look at this cell now. So this row is missing a 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is missing a... That's not a 2. This cell can't be a 2 because that would have to be a 1. This can't be a 4 because that would have to be a 3. So if this is a 6, that's a 5. And if this is a 7, that's a 6, which gives us a 5, 6 pair in this row. This 2 looks over here. It gives us a 6 and a 2. This row, 1, 2, we need a 3 and a... Sorry, we don't need a 3. We need a 4. We've got a 5 and a 6. We need a 7 and a 9 to finish this off for this row. Don't think I know how that's going to work yet. Let's see. This number has to be bigger than... Actually, it has to be at least 8, because this number is at least 2. So 6 plus 2 would already be 8. So this is an 8 or a 9 up here. Let's see. These aren't 4. So that's 4. That's a 6, 7 pair, makes that a 2. We've got almost all the 2s, I suppose, but we still have a 2 in one of these. 2's probably there, right? This could be a 3, I guess, is the other option. This is a 2 or a 3. Oh, actually, as is being pointed out, that 6 is there. So that's a 7 and a 6. So that's a 5 and a 6 and a 5. This isn't a 4. It's a 7 or a 9. So this is a 2 or a 3. Sorry, a 2 or a 3. Let's fill in the right digits. Puzzle goes better if you fill in the right digits. That's another pro tip. 1, 2 in this box definitely go up here. Because we have 1, 2 pushing them there by Sudoku. So that's the 2 and the 1. The 2 gives me the 3 and the 9. And now everything should collapse. 2, 3, 4. We need a 5. 6, 7, 8 is what we need. That's not a 7. These aren't 5, so that is 5. This is not 7, so it's a... Oops. So that's a 7. Making that a 9. These aren't 9. That one's not 7 either, so it's a 4 and a 7. What can I say, Kodek? I'm a natural educator. This digit is a 2. These in the row are an 8 and a 9, going in that order. In the row, we need a 3, which goes there. We need a 4, which goes there. And we need a 5, which goes there. In this column, we need a 6, which goes there. In this box, we need a 6, which goes there. We need a 7, which goes there. We need a 9 that goes there. Let's see. 1, 2, 3. We need a 4 over here. I don't know where that one goes yet. We've got a 5. We need a 6 over here. I don't know where that one goes yet. 7. We need an 8 over here, and I don't know where that one goes yet. But I know that one's not a 4. I know that one's not an 8. I know that one's not a 6. These digits. 1, 2. I need a 3 over here. 4, 5, 6, 7, 8, 9. 3, 5, and 9. This one's not 5 or 9, so it's a 3. This one's not 3 or 9, so it's a 5. So that one's a 9. Let's see. This box, we have left a 3, 4, 6, 7, 8. These are not 3. That one's not 3. So that one is 3. That one's not 7 or 6 either. It's 4 or 8, meaning that this is not 4 or 8, and it's also not 6. So that's a 7. These are not 7. That one's not a 4 either. This one's not an 8 either. So I've got another 4, 6, 8 cluster floating around. So we're going to have to go into the last dangerous box, where we have to be very careful. 1, 2, 3, 4, 5. We need... Oh, we know where the 5 goes. It goes there. 6... Oh, this 4 actually does it. Never mind. This 4 looks over there and does that whole thing. 8, 4, 6, 8, 6, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. And then the bet puzzle is a 1. Sorry, the bet cell is a 1. My brain works. Who says I'm not? Thank you for that, kuraban. That was very cute. I enjoyed that. The beginning of sort of like thinking of expressing this in terms of all the other cells together was very cute. It took a while for me to wrap my brain around it, but it was a very, very cute break-in. And then the puzzle basically collapses in a cute way. Very nice. I liked it. Alrighty. Let's take a look at next up. We have an arrow puzzle by ICHTUES, whose name I never remember how to pronounce. I'm sorry. Tristan sometimes tells me, and then I forget. So, horrible apologies. But this time, we do get to fill in a bunch of digits right away. So, first of all, what is the minimum for this circle? It's if this is 1, 2, 3, and this is 1, 2. And those digits add to 9, so this has to be right, which means this has to be the 3. Which means we get to do our digit dance. We get to do the 3 dance. Whoop, 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 whoop. ICHTUES, is that what you're saying, Codec? ICHTUES? Whoop, 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 whoop. Thank you, Zach. Thank you. Bet cell. Let's see. Let's choose that cell as a bet cell. Actually, what color would we like the bet cell to be? I feel like we've had too many green bet cells. Let's make this an orange bet cell. We'll make the bet cell orange today. All right, so these are not 3. This is a 9. We should again do our minimize this game. So these sum to a minimum of 16 if you count this twice. So this digit is always an 8 or a 9. This digit is a 6, 7, 8, or 9. Because of this length 3 arrow. do I need to minimize these two together? I kind of think I have to minimize these two together. Okay, so let's look at the sum of these two arrows, which is going to be the sum of these cells, and this cell. So these in the middle row sum to at least 10, plus these up here sum to at least 3, so that's at least 13, 14, 15. So these sum to at least 15. So that tells me that they're from 6, 7, 8, 9. I don't yet know much that I can do with that, but sure, it's true. Okay, so 15 is the minimum, but 17 is the maximum. And so if this cell was a 2, we would be at 17. If this cell is a 3, we would be at 19. So this cell, in fact, is always a 1 or a 2. Aha! Which means that this cell has to be at least 3. But it's certainly also at most 3. Because if this is 1, 2, 3, 4, and a 9... Sorry. 1, 2, 4, 5, and a 9, then the sum of all of these is 15 plus 3 is 18. Double that is 9. So we have to have a 3 there. So this is not a 9. So we get a 1 over here. That is some very fun geometry. These are 6, 7, 8. Let's see. Okay, so there's no more 1, 2s in this column for what it's worth. Oh, good point, good point. When I summed these, and I did the minimum, what did I do? I did 10 for the middle 4, 12 for this one, plus 3 for these two, which is 15. However, this cell actually can't be 1, 2, or 3. So actually, the minimum of these two cells is actually not 3. The minimum for these cells is actually 5. And so actually, if I do 5 plus 10 plus 2, that's 17. So great spot. Hey, ICHTUES, welcome. We have the setter in the house. Always a pleasure. So we have to minimize this in order for this to work, which involves making that a 4 and that a 1. That a 1. So that's a 2 and a 1 while we're at it. And these cells have to be a 1, 2, 3, 4. Well, these aren't the ones that are the 1, so that's the one that's the 1. So this is not a... Oh, sorry, I was going to say, so that's not a 4, but that's not how numbers work. So if I look at this one, currently it's summing to at least 7... No, at least 8. Well, I know it's going to sum to at least 8, so this is not super surprising. This is already actually pretty restricted, because it can't be 1, 2, 3, 4. It could be 5, 6, 7, but it can't be 8, 9 either. So this is only from 5, 6, 7. Okay. Right. This cell is at least 5. So this cell has to be less than 5, because I can't add two numbers that are at least 5 together and get a single-digit number. So this is at least 5. And so this digit has to be less than 5, so it's from 2, 3, 4. But this digit can't be a 9, actually, so this can't be a 7. This can never be a 4. So this is 2 or 3 and 5 or 6, which means that this cell's always a 7 or an 8. One of these, therefore, is the 4 for the box, so this is not the 4. There we go. This is not a 1, 2, 3, or 4. So this digit's at least a 5, and so actually I have to minimize it. This has to be a 5 with a 1, 2. That's the only way this works. And so the absolute minimum for this arrow actually makes it an 8. So not an 8, not an 8. By the way, this 1 looks up here and has for some time and has made this a 2, 4 and this a 1, 5 because these need to add to 6 and these need to add to 6, but without a 1, that needs to be 2, 4. So that's a 3, that's a 2, that's a 4, that's a 2. And now I can just do math to get 1 plus 4 plus 3 plus 1 is 9. So hopefully 1 plus 4 plus 1 plus 2 is 8, and it is. Okay. Gorgeous opening. So this is indeed 5 or 6 to make 7 or 8. Okay, so 9 in this box is in one of... Oh, no, 9 in this box is placed. 9 in this box is here. So now 9 in this box is here. 9 in this box, I guess, is in one of 2 places. 9 in this box is in one of these 2 cells, which then places the 9 up here. So 9 over in this box can't go here because that would mirror it into a box that already has a 9. So that's a 9. So now I can look at 9 in this box. Why did I think I knew it wasn't here or something? I don't know. One of the... Oh, no, I know it's not there. This is the 9 in this box. So that's the last 9. I did not cover myself in glory with that sequence of deductions, but we're going to go with it. Incidentally, let's fill this in. It's not 1, 2, 3. It could be 4. No, it can't be 4 because there's a 4 in the row. Also, I don't want to highlight that one. There's a 4 in this row. It's not 5. It could be 6 or 7, but it's not 8 or 9. So this is a 6 or a 7, which means that these are from 1. Oh, and I know where the 1 goes. The 1 has to go over here. 2, 3, and the 4 goes over here for this row. The 1 is placed on this arrow. So these add to 8 without being 1, 7. So they are 2, 6, or 3, 5. So this is the 2 or the 3. This is the 5 or the 6. Gives us a 5, 6 pair in the column. For whatever that's worth. So 1 comes over here, sorts out the 5 and the 1. Is that my last 1? Almost. I have one more 1 over here, coming from that 2 and that 1. Buttery smooth is an excellent description of this puzzle. 6 or the 7, interestingly, is going in one of these 2 cells. That 6 or 7 is going in one of these 2 cells. Where is 2 in box 4? 2 in box 4 goes here. How close are we to 2s? We are most, but not quite all of the way to 2s. Unfortunately, we don't know which of these is a 2 just yet. Let's fill in this column. That might help. We've got 1, 2. We need a 3. We've got a 4 and a 5. We need a 6 and a 7 and an 8. That one's certainly not a 3. It is a 6, 7, or 8. Let's see. Speaking of this box, 5, 6, 7, 8 is what's left. That one's not an 8. This box needs a 3, and the 3... I guess the 3 has 2 places, doesn't it? No, it doesn't. 3 in box 4. 3 really does go here. I thought it had 2 places, but it turned out it does not. Okay, and so now where's the 8 in this row? The 8 in this row is definitely in one of these two cells because it can't go there, so that's not an 8. These digits are, let's see, we've got a 1, 2, 3, 4. We need a 5, 6, 7, 8. One of these is the 8. This, I guess, is also a 5, 6, 7. Okay, well, that's interesting because that gives me a 5, 6, 7 triple in the row. So these two are a 3, 4 pair, is the upshot of this. And this is a 5, 6, or a 7. Let's see. Row 4, column 6. Sorry, I'm reading Very Smart. Row 4, column 6 sees row 3, column 6. Ah, right, okay. So these two are a 6, 7 pair, and this cell sees both of them. That is really clever. So this is an 8. I love that. So this is not an 8. So these aren't 8. So I do need to get an 8 into this column. It's going to have to go in one of these two cells. 5 looks down the column. Which column is 5 looking down? Oh, this is a 5, 6, 7 triple now. So this is an 8. And this is something else. This is a 4. 5, 6, 7 triple did sort that out. So that 8 means that's a 6, which means that's a 7 and a 7. Meaning that that's a 7, actually, because I need to put a 7 in here, and that's the only place it can go. These aren't 7 anymore. That 6 means these aren't 6 anymore. That 7 means these aren't 7 anymore. Okay, one of these two is the 6 for this box. So this isn't a 6. So that is a 6 and a 5. Oh, I really could have done that in a way simpler way, but it's too late now. There's no going back. That 6 means this is a 5 and a 3. This is not a 3. So that is the 3 for the column. Let's see. That 6 looks up and makes that a 7 and a 6 and a 5 and a 7. That's not a 7. These aren't 5 either. 7 in box 8 is placed because it's not in any of those places, so that's a 7. Or alternatively, the column, take your pick. These digits, we need a 5. And we need a 6 in this box, I guess. So these are a 5 and a 6. So that makes this digit, 1, 2, 3, that makes this digit a 4. Let's fill in this box. We need a 3, we've got a 4, 5. We need a 6, 7, 8. Oh, this 5 looks down here and sees that this is a 6 and a 5 and a 5 and a 6 and a 5. My scanning today has been particularly bad, like even worse than normal. This isn't a 7 either. This 3 makes this a 4 and a 3. These two digits are a 2 and a something. 2 and an 8. I don't know the order yet. I don't think. These digits are a 4, 6, 7, 8. These aren't 7. Let's see. 3 in box 1. That's not a 3. Oh, these aren't 3 either. So that's a 3. Places the 3 over here because it can't go there. So that's a 3. These are a triple. Let's go ahead and fill in that triple. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are from 4, 5, 6. These aren't 5, so that is 5. So these are a 4, 6 pair. Oh, row 8 already has a 4. That's helpful. What if it had 2 more of them? Would that help? I somehow suspect it would not help. There are neither 6 nor 8. That 4 looks down now and sees that 7 and that 4. That 7 looks up and sees the 8 and the 7. The 8 looks down and sees the 6 and the 8. And the 6 and the 7 and the 8. And the 2 and the 8. And the 4 and the 2. And the 6 and the 4. And let's see, this is 1, 2, 3, 4, 5, 6, 7. This is an 8. 1, 2, 3, 4, 5, 6. And a 2 for the bet cell. Congratulations if you bet 2. If you bet 2, you are the big winner. You have won the first ever orange bet cell. That is a very lovely puzzle. That is very nice. Congratulations, Ambrose. You have won the coveted orange bet cell. It's very exciting. Zach congratulates you, Ambrose, as well as all other bet cell winners. Yes, super smooth solve. Yeah, and believe it or not, I only have one more vanilla arrow. So I'm going to do one more vanilla arrow, and then we're going to do this less vanilla arrow. Sven added colored circles. So let's see. We're going to have a red bet cell this time on this Joseph Nehme puzzle. Joseph Nehme puzzles are always wonderful, by the way. If you're looking for someone to stalk on LMD, Joseph Nehme is an excellent follow. So let's dive in to this one. So we got a bunch of stuff to look at right away. So this cell is already at least a 7, because it's 1, 2, 3 plus whatever this is. So this digit's always 1, 2, 3. And this is 7, 8, or 9. Now these 3 actually can't be 1, 2, 3 anymore. So this is actually 7, 8, or 9. This cute little compass orientation here is actually giving us 2 sets that sum to a minimum of 15, but that's double the arrow. So double the arrow is at least 15, which means the arrow can only be an 8 or a 9. But now I want to look at what happens if I take this whole mess together. So this is double this arrow plus this arrow is minimum 21. So double 8, I guess would still only mean that this is at least a 5. Well, this is at least a 5. We'll take it. 5, 6, 7, 8, 9. I will accept this offer, I suppose, if I must. There's definitely a 1 in these 4 cells, for whatever that is worth. Oh, double 8 isn't even the good case. You're right. Double 8 is the bad case, and the bad case is bad. Okay. This is 6, 7, 8, 9 as well. I don't know why I've sort of missed this one for so long, but we're going to go ahead and mark that 6, 7, 8, 9 and that 6, 7, 8, 9. Okay. I think two of each of these arrows have to be... Oh, I was going to say something... No, I was going to say something nonsensical. I think. It's good to think about the duplicate, right? So it's not possible that this is 1, 2, 3, 4. So it has a duplicate, as SPQ points out. And so what that means is these two cells are the same, because these are the only two cells that could be the same. So this is a 1, 2, or 3. And now, cleverly, that tells me this isn't a 6, because one of 1, 2, or 3 is ruled entirely off of that arrow. I love that. So this is a 7, 8, or 9. Cody, arrow rules are this digit in the circle is the sum of the digits on here. So if this was a 1, 2, 4, Cody, this would be a 7, because 1 plus 2 plus 4 is 7. But the order doesn't matter on arrows, aside from the fact that the circle is the one that's the sum. And if you're interested, I actually started today by going over a lot of the strategies for arrow puzzles in depth. So if you are, if you would like to see that, you can. So I think the thing for me to look at here is these cells. So these sum to a maximum of 18, which means that no matter what I do, I need to use a 1 and a 2 in them. Maybe this isn't as good as I hoped, because I could avoid a 3, right? 1 plus 2 plus 4, 5, 6. Yeah, that annoyingly does not work. I was hoping to say that these had to include a 1, 2, 3, so I would know this was the one of these that wasn't 1, 2, 3, and these were 1, 2, 3, but sadly that does not work. Let's see, the circle in box 6 is 3 or 5. Use both directions. Let's see. What is using both directions getting me? Imagine the circle was an 8 using both directions. Okay, so if this is an 8, then this would be 1, 5, and 2, 4. Oh, right, okay, so if this is 8, okay, so I get what people are saying now. If this is 8, then these 5 cells sum to 16. Well, how do I sum to 16 in 5 cells? I do it as 1, 2, 3, 4, 6. It's the only way to make 16 in 5 cells, because 16 is 1 above the maximum. But, and this is gorgeous, and I did not get this. The 2-cell one now doesn't have a 5, because 5 had to be omitted in order to make this work. So the only way to make 8 and 2 with these digits is 2, 6, but that would mean both of these were 2, 6. That does not work. That's very cool. So that's a 9. And so we get to do our 9 dance. It's a pretty bouncy dance. 9 dance. We've done a lot of 9 dance. I guess it's because it's Arrow Day. We've done a lot of 9 dances today. 9 dance. 9 dance. Boo, boo, boo. Boo, 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 boo. Woo. Boo. Ta-da! Thank you, Zach. I'm glad you recovered after your fall earlier. Okay, so that does cool stuff, because now this can't be a 9 and this can't be a 9. And so now this arrow definitely has a 1 on it. But also, this cell can't be a 3, because then this would need to be 3 plus 1, 2, 3. That does not work. So this is neither a 1 nor a 3, which means it's a 2, and that's a 2. Now, as soon as this is a 2, this can't be 7 anymore, because this is at least 1, 3. So this is an 8, and this is 1, 3, is the only way that this works. This can't be 7, because you can't make 7 and 3 without a 2, per our handy-dandy arrow guide from earlier. 7 and 3 is always 1, 2, 4. So this is an 8, and it's 1, 3, 4. So this cell actually, interestingly, is at least 5. So this circle, if you think about it, this is at least 5, and these two together at least sum to 3, meaning this is always an 8 or a 9. Fascinating. Okay. So this can't be 7 anymore because it can't have a 2 on it. If you look at it, the 2 is ruled off completely, so this is not a 7. This is either an 8 as 1, 3, 4, or a 9 as either 1, 3, 5. Oh, yeah, it would have to be a 9 as 1, 3, 5. Okay, so this is either an 8 as 1, 3, 4, or a 9 as 1, 3, 5, which means these are always a 1, 3 pair, and this is a 4 or a 5. And so now I get the 1, 3 pair up here that I thought I was going to get earlier when I started looking at this, because just by Sudoku, 1 and 3 get pushed up into here. Apologies if you bet 1 or 3 for the bet cell. Okay. So so what is the sum of these two digits is the next question. So these cells sum to 27, plus 8 is 36? No, is 35? Right. So these two sum to 10 is the point. And so these two sum to 10, and so the only way they can sum to 10 is 4 and 6. I love that. Like, very, very cool setting there. So this is only 4 or 6. So these digits are 1, 2, 3, 4. They are 5, 6, 7, 9 is what is left in here. Smart point from JLib. Now ask about 7 in row 6. And so the only place the 7 can hide is here. So this is a 2, 7. Which means this is a 1, 3, 5. Unfortunately, that's quite consistent with this being a 4. Let's see. Is it possible that if this is a 6, it breaks somehow? I don't think so. Good point. Now we can ask about 7 in column 4, because 7 in column 4 now can't go here. It would need to be with a 2. You can't put a 7 on a 3-cell arrow, so the 7 has to go there. Very good spot. Which makes me wonder about 7 in this box. We don't quite know yet, but we know this digit is pretty big. Okay, so if this is a 4, then this is a 1, 3. If this is a 6, then it's a 1, 5. So actually, these digits are always from 1, 3, 5, and they always contain a 1. That's because the 2 is down here. So these are always from 1, 3, 5, and they definitely contain a 1. Which means the 8 in this is over here. Now, if this is 1, 5, then what is this? This is 1, 5, then this can't be 1, 8. It can't be 2, 7. It would have to be 3, 6 in that instance. Okay, yeah, it would be 3, 6 if that were the case. And I see what chat is telling me. Chat wants me to think ahead and think, okay, what happens if this is 3, 6? If this is 3, 6, then I can't make this. But smarter, paper, scissors says to use math. And we can use math, because these sum to 27, plus 15. 27 plus 15 is 42. And so ergo, this cell is a 3, in order to make the rule of 45 work out. And so that tells me that I can't put the 3 here. So this can't be 3, 6. And so by our work, if this is a 6, this would be 3, 6. That's not going to work. So this is 4. This is 1, 3. That's 6. Now, what is this? Now I can't use 1, 2, or 3, so I have to use 4, 5. And so now this is 1, 2, 6, living over here. These digits are, let's see, we need a 2, 3, 4, 5, 6, and 9 up here. There is a 2 amongst these cells. Aha! There's a 1, 3 pair in this row. So the 1, 3 pair in this row tells me this digit's not a 1 or a 3. So this digit is a 2. Because if this digit's not a 2, it's at least a 4. This digit's at least a 5. 4 plus 5 already totals 9 before I even add this digit. So this digit's always a 2. So I don't think I can do the same thing with this digit. The biggest this digit, the least this digit can be is 5, and the most it can be is 6. So I might as well fill in that this is a 5 or a 6. Oh, right. So that does actually mean that this has to be a 1, right? Because now if this is not a 1, it's now a 3, and that's way too big. So this is a 1. It's a 3 and a 1. This is a 5 or a 6. Okay, that was actually much less messy than I thought it was going to be when I sort of started looking at it. So now, this digit is at least a 5 or a 6, plus a digit that's at least a 2. So 5 plus 2 is the absolute minimum of this. 5 plus 2 is 7, so this digit's a 7, 8, or 9. The 1 and 2 look down at these cells, so this can't be a 6 or a 7 anymore. Because if this was a 6 or a 7, it would need both a 1 and a 2, and it could not have both. So now we've got an 8, 9 pair in this row. And in fact, actually, if we look at it, what's the minimum these sum to? 7, because it's 3 and 4. And so this digit here now can be at most 2. So this is a 1 or a 2. This isn't a 1 while we are filling things in. The absolute biggest digit that could possibly be here is a 5. In fact, actually, this always needs to have a 3 on it. Because if it doesn't have a 3 on it, then what happens? If there's not a 3 here, then this sums to at least 9 on its own before I even get there. So there's always a 3. So that does resolve that that's a 5. These aren't 5. Those are a 1, 3 pair. Oh, but once that's a 5, that tells me that this is 3, 4. This becomes redundant. This is a 1 or a 2. That's an 8 or a 9. Let's see. Can this line get by without a 2? Because this can't be a 1 or a 2, and this is at least 5. So if this isn't a 2, right, this cell's at least 5. If this cell is not a 2, Oh no, it's at least 4. Darn it. Stream's going well so far. We have done many arrow puzzles, and it has been a good testament to how much variety there is in arrow puzzles. I should fill in these digits. Is there an 8 and 2, 3, 4, 5, and a 6? Is there a 6 and an 8? This 4 looks down. Gives me a 5. These add to 9, so that's an 8. So that's a 1 and a 3 and a 1. Good spot to Nicholas there. Let's see, that being an 8 means this isn't an 8. Which means this digit that's at least 5... Let's see, can this be 7? Only if this is a 2. Let's see. I feel like if I think about it a little bit with parity or something, I can get what this digit has to be. Not quite there yet in my brain, though. I know the 3... the 3 is just placed here. 3s look up into this box. 3s look over into this box, so that's a 3. I don't think it does anything, but it's nice. It's kind of amazing, actually, how we're able to place a 3 with Sudoku, and we have no idea where any of the other 3s are. Row 4 has a 5, 7, 9 triple. That is very well spotted to Eric. So this can't be a 5. So that's a 4 and a 5. So this isn't a 5. So actually, this is a right-in now. We've got 1, 2, 3, 4, 5. Oh, no, sorry. This is a 6 or an 8. And then we've got this 5, 7, 9. Yeah, so this is a 6 or an 8. I don't know which of 6 and 8 it is. So yeah, we can go ahead and pencil mark that this is 5, 6, 7. So this is 2, 4. Actually, once we realize that this is 2, 4, this can't be as big as 6 or it'll overflow. This can never be 6. Because these need to add to an odd number, so it's an even and an odd. That's always the even. I was trying to do that in my head before to see if it worked, and in my head I concluded it did not, but then when I wrote it out, it did. So thank you to chat, as usual. Let's see. 7 over here is in one of these places. Can I place 7 in this column? I don't think so. This 1, this 1 gives me a 3 and a 1. So neither of these is 1. So that is 1. Thank you, Sayori. These aren't 9, by the way. Sorry, aren't 9. The highlighting tells you why they're not 9, if you don't believe me. This column, we've used 1, 2, 3, 4, 5. So this is just 6, 7, 8, 9 left. That's not an 8. Admittedly disappointing. Let's see. This row, sadly, has not done a whole terrible lot for us, if I am honest. Actually, if I look at this box, I don't know if this is going to be at all helpful, but 8 in this box actually goes in one of those 2 cells. So that cell, at least, is not an 8. It's not a 7 either, because there's a 7 that looks straight at it. So yeah, so the 8 in this box is in one of these 2 cells, for whatever that's worth. Yeah, and the 8 in this box... Okay, so the 8 in this box is now in one of these 2 cells. And so where is the 8 in this box? It's in one of these two cells. Doesn't really do anything for me, though, I'm afraid. Look where row 4, column 2, goes in box 1 if it's a 7. Oh, that's gorgeous. Okay. So Garion observes that this digit has to find a home somewhere in this box. If it's a 9, there are lots of options. But if it's a 7, actually, there are no options. So this actually can't ever be a 7. So orange is actually 9. Very cool spot, Garion. So that's a 9. Okay, and so this being a 9, does that tell me anything about, like, what this arrow is? Sadly not. At least not immediately. Makes an 8-9 pair in box 1? Right. I guess that's always been there, hasn't it? Because the 8 and the 9 in this box have always been restricted to these two cells. So actually, this is an 8 or a 9. Good spot. So that means these digits are 1, 2, 3, 4, 5. These are a 6, 7 pair. The 8 in this box, yeah, goes in one of those two cells. I suppose I knew that already. This row, maybe I should write in the row. I've got 1, 2, 3. I need a 4. I've got a 5. I need a 6, 7, and 8, and then I don't need a 9. This I know isn't an 8. That doesn't quite work. Let's see. 9 in box 9 is already pencil marked. Oh, but I see it's pencil marked, but I haven't used the pencil mark. Oh, no, 9 is not, sorry, 9 is not pencil marked. But 9 could be pencil marked. Right, okay, sorry. Great spot. 9 is also here in this box. So these are not 6, 7. These are 8, 9, which does 6 and 7 up here for us. Great spot, Nicholas. It is not a 6 anymore. And so now 7 needs to go somewhere in box 1. The only place it can go is there, with a 7 and a 2. These aren't 2 anymore. 6 needs to find its way into this box. It can only find its way into one of these two cells. So 6 needs to find its way into this box. It can only find its way here, making that a 9, and that an 8, and that an 8. This is now a write-in. 1, 2, 3, 4. This is a 5, so that's a 7 and a 5. Let's see. These digits, 3, 4, are a 4 and a 5, it looks like. So that's not a 4 or a 6. So that's a 7 and a 6 and an 8. This is not 6, 7, or 8, so it's a 4. 6 makes that an 8 and a 6. Makes that a 5, and a 4 and a 5, and a 2, and a 9. This is not a 5 or 9, so it's a 6. I bet I can figure out what this is if I work really hard. I think it's a 2, and a 6 and a 2. I think these are a 5, 6, and 9, so that's the 6. These are a 5, 9 pair. I don't know the order yet, but I do know now that's a 7. How could you know if you've won the bet cell or not? I haven't written it in yet. These digits are 2, 3, 4, 5, 6, 7, 8, 9. This is not a 2. This is not a 6. This is not a 6, actually, so that is the 6. These are a 2, 4. I now know what this is. 1, 2, 3, 4, 5, 6. This is a 7. So this is a 2, 3, 4. There may be some sort of chain to see what the bet cell is. It is possible. Let's see, what is left in this box? We got 1, 2. We need a 3, 4, 5, 6, 7, 8. These aren't 5. I really thought that was going to do more. Am I missing something? What am I missing? I feel like I'm probably missing Sudoku somewhere. How are these 1, 3 ever getting sorted out? Oh, I see. Okay. I have a sort of X-wing on 4s, where I know the 4s in both of these boxes are in rows 8 and 9, so none of these can be 4. That does something for me. Let's see. So that turns this into a perfectly useless triple. There is a 2 in box 8. There is a 2 already in box 8. That is a genius observation. So that 2 actually means that that's a 3, which makes that a 1 and a 3, makes that a 4 and a 1. Means none of these are 3 anymore. That one's not 4 anymore. So in fact, that one is the one that's 4. Now, this column has a 2, so that's a 7 and a 2. That 7 looks down and gives us an 8 and a 9 and an 8. That 9 gives us a 5 and a 9. That 5 and 8 look together to this with teamwork and make that a 7 and a 5. 2 looks over there at 4 and the 2. The 4 looks back, 3 and a 4. The 1 looks over, 3 and a 1. 1, 2, 3, that's a 4. And now we can reveal dramatically that if I count 1, 2, 3, 4, 5, 6, 7, 8, the bet cell is a 9. Congratulations if you bet 9 as the bet cell. You have won the coveted red bet cell prize. I'm going to finish the puzzle. Excellent. We have made much progress on arrow puzzles today. That was a super cool puzzle. I always love Joseph Nehme's puzzles. They're always super cool. And usually fairly approachable by comparison to, I'll say, most setters with name recognition. Alrighty. I'm going to take a short break. Fear not if you have tired of vanilla arrow puzzles. We are going to come back and we're going to do an arrow puzzle that is a chaos construction. So when we are back, the chaos will begin. But for now, I'm going to take a short break and get a drink. And then I will see you all very shortly. Alrighty, welcome back. I suppose I can probably get rid of the arrow cheat card. Okay. I'm still waiting to get another Wen Chang feature. I'm hoping someday I do. One of the very first puzzles I saw that Wen Chang did was Frack, which was awesome to see. Wen Chang, by the way, is a Sudoku streamer who streams in Chinese and posts videos. I do not speak Chinese, but it is still very cool to see someone across the world doing various puzzles that either I have made or done or whatever. It's very cool. Bye, Playmaker. Enjoy. All right, so let's read the rules to this. It has been a fun stream. I was a little concerned if I just kept doing arrow puzzles that I would get bored, but actually it turned out, at least for me, I can't speak to any of you, but at least for me, I found doing a bunch of arrow puzzles in a row quite stimulating, and I also think getting 10 puzzles done in 5 hours is quite a thrill. I don't think we've done that very often on the stream. Tristan informs me that 12 is the most puzzles we've ever done on stream. We're currently at 10. We'll see if I can spend 3 hours on this and not quite break it. All right, so let's read the rules. So we need to place the numbers 1 through 9 in every row, column, and region. So instead of having little 3x3 boxes, like we're used to, this puzzle has regions that are probably not box-shaped. So they might look something like that, for example. But in addition to the fact that the regions are not box-shaped, they're also not given. So this is usually called a chaos construction, which is why this is called chaotic archery, and also why I referred to this as a chaos construction. So those are just puzzles where you have to build the regions yourself. But all the regions consist of 9 orthogonally connected cells. So by orthogonally connected, it's telling us the region does not end up looking like this. Like that cannot be a region because it's not orthogonally connected. This is only diagonally connected. And the region definitely can't look like that, because that is just a monstrosity. We won't even talk about it. Those are the rules so far. Every arrow in the grid corresponds to an arrow total in a bulb. Both the arrow and the corresponding bulb have to be in the same region. The direction of the arrow is of no importance for determining the regions or the corresponding bulb. Okay, let me read that again. Every arrow in the grid corresponds to an arrow total in a bulb. Both the arrow and the corresponding bulb have to be in the same region. The direction of the arrow is of no importance for determining the regions or the corresponding bulb. Okay, so what we're saying here is I have to draw an arrow here for the 9. I have to draw an arrow for the 4, and wherever the 4 connects, so say the 4 connects like that, I'm not going to do it that way. I'm going to use the gray. Say the 4 connects like this, then this will be a 1-3 pair to make the sum of 4, and then this will all be in the same region. But it looks to me like I'm allowed to add both my own circles and my own arrows. I originally thought, no, that's wrong. No? What did I miss? Connect to a bulb. The arrow and the corresponding bulb. These are given. I'm trying to parse this in a way. Fortunately, so one of the short arrows. Okay. So, sorry, we're not drawing arrows into the grid. Okay, sorry. We're matching arrows. Got it. Okay, sorry. In my brain, I was convinced I was adding bulbs and arrows to this grid. But what's actually happening is that I'm picking an arrow, say this one, and saying that this arrow and this thing match and are in the same region, and so then I have to make these 3 cells sum to 4, which I can't do. And I have to also connect them, which I can't do. So the 4 I have to connect either to this one or this one. I can't even get over here. Okay. All right. 9 circles, 9 arrows. But we don't know that the arrows don't repeat within regions, I don't think. Okay, so yeah, sorry, I did not, I probably should have looked at the sample puzzle that was on LMD. Okay. So, yes, okay. So I've got to connect this 4 to one of these. This 5 has to connect to one of these. Let's see. So I have 2, let's see, I have 4 9s, 2 8s, a 5, and a 4. And then I have 1, 2, 3, 4, 5. I have 5 that have to be 6 or greater, but I have 1, 2, 3, 4, 5, 6. I have 7 that can be. Now, I guess the first observation is that these two are never in the same region. The reason why these two can't be in the same region is that if they were, then the sum of those arrows would be at least 21, which I can't do. So I at least get a little region borderline here. I don't think I'm going to do yellow. Yellow's a little bit too subtle. Let's do orange for the region border. So there are separate regions over here. Now, if this is part of the same region as this, I only have 4 cells to grab my arrow, and that's just not going to work because I can't get to 2 circles in 4 cells. In fact, I could only get to 1 at all. So in fact, this is also in a separate region. And whatever this is, it's going to continue out. So this region is going to keep continuing out like this. This region is pinched, so it's going to have to continue out like that. So this region also continues out like this. And now I have to look at 1, 2, 3, 4, 5. It needs to connect to a number in 4. The only number that this can connect to in 4 is this 9. So I think this region is forced to do that. Do we agree with that assessment, that that is completely forced? I think I agree with that assessment. No? Not quite? Oh, it's because it could wiggle like that, right? It could do that, right? Right. It's not, these are connected. I don't have to use the color. I mean, the borders have always been colored before, but I can use black now, actually, if we prefer black. Black is a new option. So these are connected, but I don't know quite how. So let's make that the red region. Those are going to connect. But yeah, this could do something like that, I suppose. But now this region has to connect to something. And the only thing it's going to be able to connect to, I think, is this 5 now, because it can't possibly get to the 8, right? Oh, no, it can, can't it? That's obnoxious. This can get to the 8. Oh, it has to get to the 8. No, it has to get to the 8 because it's a 3-cell arrow. A 3-cell arrow can't be a 5. So I think this one might actually be forced in terms of its exact shape. Yeah, it can get to the 8. I don't see anywhere else it could possibly get. But the shape is again not exactly forced, because it could also do something like that. But again, this has to be green. And so what that means is these are connected. And so whatever happens, this needs to come up over here. Because this green is going to cut off purple however it goes, whether it does that or whatever. There are various sort of combinations, but purple, because it needs to get to 9 cells, is going to need to grow up over here. But actually, purple now has to be 9. So we now know more about the world. It is true that there's more green cells I can see. If green doesn't take this, now green has to get, like, around that, and that's way too many cells. So this is green. Likewise, this is green. Otherwise, God knows what happens. And then this is green. But then we don't know which of these two is the last green cell. But these are borders. Yeah, one of these two is the last green cell. I can definitely attest, as SPQ says, the 5 is definitely not green. I'm looking at this arrow and the 8. I think this arrow has to go with the 8. So let's just look at this arrow. I'm going to call it yellow for a second. The only other thing it could plausibly go with is the 9. But this creates a huge problem, because now the 8 is off to itself and does not work. So in fact, actually, all of these have to be connected. It is true there are a few more borders I can draw in. I can draw in that as well. Can draw in that as well. The 9 can't possibly be in the region with the 8. I agree with that as well. The green arrow has a 1. That's true. And so that means that this arrow has a 1 over down here. The borders are now available in colors, and so I have chosen the color of black instead of the color of green, which actually looks pretty sexy, I've got to admit. Oh, wow, Sayori with a badass spot. Where does 9 go in column 1? Can't go on an arrow, can't go on an arrow, can't be in purple, can't go there, is not equal to 4. That's a 9. And so we get that. That is sick. Let's see. I know that yellow could take this cell, but can't take anything on either of these. But it doesn't quite get me there. It tells me yellow spills out over here, but who knows? Oh, that's right. That's a digit dance. Boop-a-doop, boop-a-doop. Bring out Zach for the 9 dance again. Boop-a-doop, boop-a-doop. 9 dance, boop-a-doop, boop-a-doop. 9 dance, boop-a-doop, boop-a-doop. 9 dance, boop-a-doop, boop-a-doop, boop-a-doop. Boop, 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 boop. Boo, 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 boo. 9 dance. Thank you, Zach. Much appreciated. We've had many 9 dances today. So if this were to take this, that would already be 1, 2, 3, 4, 5, 6, 7, 8, 9. That would already be 9 cells. I don't have a circle for it. So purple can't take that. And if purple can't take that, then you count and see how many cells does purple have. 1, 2, 3, 4, 5, 6, 7. Purple could take that. That could be 8. This cell's always purple. So whatever this region is, it's going to go up that way. Good spot. Okay, so 9 in row 9 is also placed, thanks to Medi, because 9 is already in red. 9 can't be on this arrow. 9 can't go in the column with a 9, so this is a 9. I'm trying to decide if I believe there's any chance that this is not yellow. Oh, and now we can do 9 in row 8, I am being told. 9 not on the arrow. 9 not there, 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 there. Yep, 9 in row 8 is here. Let's see, do we have all the 9s now? Not quite. We still need a 9 in this row, right? And a 9 in this row. I think those are the only rows without 9s, so... none of those are 9s. That's not a 9. That's not a 9. That's not a 9. One of these two is a 9. And likewise down here. Likewise down here, one of these two is a 9, but I know which one. It's not the one that's on an arrow. So that's a 9. And then our very last 9 is up here. Green already has a 9. So that's not green, which means that green had to connect this way. Hopefully that's the right number of cells. That is the right number of cells. So now, if I ask myself where yellow is possibly getting a 9, I don't even really have to complain about the fact that yellow's obviously getting its 9 here and not from anywhere else. So this is definitely yellow. Purple still can't take this arrow, but purple's not done. Purple's only got 3, 6, 7, 8. Purple needs another cell, so this cell's purple. Okay. And now this region has suddenly become large. This region's already at 5 cells. And remember, it needs to grab one of these length 2 arrows. It needs to grab either this one or this one. I don't know which yet. I don't think it deserves a color till it finds an arrow. At least as far as I see it, hard to argue with that. Let's see. If it found this, I see this 9 becoming a potential issue, but maybe not. Maybe it would be okay. Let's see. This is summing to 9. This is summing to 9. Yeah, I agree, Kuraban, but I don't see, and so anything. Yeah, we know that yellow doesn't take the arrow above it, but I don't think that lets us shade any cells. Yeah, the remaining 9s are all different colors, I agree. It does something to red. Right. So, your point is red can't take this cell? Red definitely can't take this cell. Okay, let's start with this one. Red can't take this cell. If red took this cell, now yellow is trapped into well, red could finish, say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 would be how red would have to finish, and now yellow couldn't. So this cell is not red, is Carl's point, which is a very good point. So this cell is red. Now, even this cell being red actually presents a problem, because if this cell's red, red finishes like this, and yellow's still capped at 7 cells, so that's not possible. So red takes that cell. Now, and now yellow. Oh, yellow has 10 total cells that yellow can take. But either way, I can't fit a new region in here, so these cells all have to be yellow. Because again, this is a 10-cell sort of isolated patch of stuff. I can't fit a new region in here, so these are yellow. And of course, I could draw in a border here. Row 8, column 7. Column 7. Okay, let's go back. So what cells can yellow possibly take? Yellow can possibly take these. That's 10 cells. If yellow doesn't take row 8, column 7... Oh, I guess that is a perfectly valid shape. So yeah, never mind. You're right. This could absolutely be not yellow. I was missing this shape. So yeah, I think these are the only ones that have to be yellow. One of these is a 1-3. It's either that one or that one. I don't know which. Let's see. I fear now we're suddenly going to have to do something smart. I'm just using Sudoku pad, Nordy. If you use the Sudoku pad, you should have options for these things. I mean, 8 in purple is in one of 2 places. I can mark that. Those are the only places that 8 can go in purple. Whereas 8 in row 9. 8 in row 9 is in one of these 3 cells, I suppose. That feels like reaching. Whereas 8 in row 7, not any of those places. So the 8 in row 7 is in one of these 2 cells. Oh, I see. So the point is, so is this all a really elaborate thing to get me to say that the one coloring shape can't actually be possible? Because that seems like a lot of work to get to. Yeah, the 8's not yellow. One of these 2 is an 8. So the shape before that we drew that was that is not possible. But Literally, that's the only thing we get, is that this cell is yellow out of all of that. Because we don't know which of these is the 8. Who knows? Quite interesting. But we do get that this can't be yellow. I agree. Row 8, column 6 plus row 8, column 7 is now a 6-7 pair. Do I have the right cells highlighted? Oh, right. That's okay. That's very clever. Okay. So these are 2 8 arrows and they're different. So one is 1 2 5 and one is 1 3 4. So these can't be 1 2 3 4 5 and they can't be 8 9 either. That is a beautiful spot, Gary. And so these are 6 7 and we know the order because there's a 7 up there. So that's a 6 and that's a 7. That is a ridiculous spot. But is true. And so now, no, I was going to say something about now 6 7 down here, but that doesn't do anything. Yeah, two numbers into the grid out of nowhere is always an exciting accomplishment. Yeah, so whichever of the digits we're putting here is on the other 8 arrow. Yeah, we know that this is... I saw that. I was hesitant to mark that, but if I have encouragement / enabling from chat, I'll pencil mark that that's 2 3 4 5. So I think this 9... I think this 9 can still take this, can't it? And then let's say this 7 come down here and take this. Like the 7 is sort of primed to do, I guess not quite that, primed to do that, or something like that. There might be some like some sort of like multiple of 9 math that you can't do. But even this 9 might be able to take it. 2, 3, 4, 5, 6, 7, 8. No, it can't quite. This 9 might have to take this arrow, although I think if you have to see that, I think it's ugly. Let's see. The 7, so if the 7 wants to take this, it has to get down, and it has to sort of swivel in some direction or the other. So this really does take all 7 cells. And the 7, if the 7 does take this arrow, it really does block off a chunk of cells over here. And the chunk of cells it blocks off includes 2 9s, no matter what. So I do think I buy the 7 can't actually take this. Yeah, I'm not in love with it, but I think I buy it. So if the 7 can't take this, the 9 can't take this. I think this 9 does have to take it, I think is the point. I think is that we get a little inappropriately shaped region over here. It does not say that 2 arrows cannot be in the same region. 5 can't take the arrow because the arrow is 3 cells long, Jim, and 3 cells sum to at least 6. Let's see. SPQ is looking at row 7, column 6. This is yellow or 8. Right. One of these 2 cells is the 8 for the row. Because we need an 8 in the row, and the other is yellow. And since red can't accommodate a second 8, this cell can't be red. That is an insane spot. So red's shape is determined. This is blue or yellow. This is blue or yellow. So the examination of where this 7 gets a 9 from, I can't put a 7... Oh, I could put a 7 in a region with a 9 if the 7 arrow takes a size 2 arrow. Annoyingly. Maybe I should look at this 3-cell arrow. Let's see. There has to be a 1 in one of the 2 cells next to 9 in red. Ah, yeah, one of these two is a 1 by LOL. Or, I mean, really, just by Sudoku. 1's not here in this region, so this region needs a 1. So those are 1. So one of those is a 1. And of course, the most likely outcome is that this also has a 1, placing a 1 there, but we don't know because this is a 9 arrow currently. I see people arguing the 7 and the 9 have to be connected, but I can't quite see it. It is worth thinking about 6, 7, 8s, because the 6, 7, 8s are not in red anymore. I know one of these two, I suppose. I know one of them is an 8. Yeah, where are 6 and 7 in row 7, as Tallcat says is worthwhile, but 6 could easily hide on this arrow, I believe. There's no reason this can't be a 1, 2, 6 that I can see. Why can't they be on the arrow, Tallcat? Why can't this be a 1, 2, 6, 9 arrow? I'd love to know which of these is 1, 3. I feel like that would be very helpful. Unfortunately, the 5 doing something like that is still plausible. Not that exactly, but... Does the green arrow go in the yellow region? It is a good question, actually. We know the 1 goes down there. Ah, yeah. The 1 goes down there, and then the other 2 digits go in this row and here. It's true. Yeah, the blanks are an 8 yellow pair. This can't be a 7. That's not a 7. This can't be a 7 because the 7 is going in red. You can't put a 7 on this arrow. Okay. I agree that in row 7, the 7 is forced here. I agree with that. The 6 is more the thing that I don't believe I know that the 6 can't go here. The 6 has to be on the arrow. That's the point. Okay, so where does 6 go in this row is now the question. Okay, so this is an 8 yellow pair, so the 6 can't go there. The 6 can't go there, the 6 can't go there. So the 6 is either here with a 1, 2, or here with a 1, 2. Do I know which? Ah, yes, it's not here because there's a 6 right below it. Okay, so this is a 1, 2, 6 arrow. Okay, I buy that. So this is not a 1. So this is a 1. So this is not 1, 2, 6. It's either 2, 3, 4 or 1, 3, 5. I'm going to go ahead and pencil mark this as 1, 2, 3, 4, 5, just for sanity. For certain definitions of sanity. Okay. I don't understand, Josh. So if I'm going to put a 7 and a 9 together in the same region, I want one of them to be 2 cells, don't I? I can't put a 5 and a 9 together in a region. I agree with that. Row 9, column 6. is the same as row 7, column 5. Why is this not 2, 3, 4, 5? Or wait, is this 2, 3, 4, 5? This is one of the numbers on the green arrow. So this is from 1, 2, 3, 4, 5. But it's not 1. But why isn't not that one? Oh, because that one is on this arrow. Okay, that's complicated. Okay, so all of 1, 2, 3, 4, 5 show up on these two arrows. This one doesn't show up on that arrow. So this one shows up over here. So the question is, where does this cell show up in the red region? And the answer is it shows up there. So Carl's point is these two are the same cell, or the same number. And that number is from 3, 4, 5. It can't be 5. Where is 2 in yellow if those are 5s? Ah, right. 2 in yellow is already actually, so this is the smart point. 2 in yellow is already forced onto the arrow. So because yellow's last cell is up here, and it's not a 2. So 2 in yellow is in one of these places. It's definitely not here. So this is a 1, 2, 5. That's the point. That's not the 1. So this isn't a 5. That's not a 5. And this is a 1, 3, 4. This isn't a 3 or a 4 either. This is a 2 or a 5. This isn't a 4. While we're at it, we can get rid of the 1 pencil marks. Get rid of those 1 pencil marks. Well, the other 3, 4 in yellow. Aha, yes, the other 3, 4 in yellow is up here. And so the 3, 4 that isn't black is in one of these two cells, both of which see this. So this is a 5. And if this is a 5, these aren't 5, and they're not 4 either. Because this is summing... and now this arrow could never sum to 7, because it's got a 5 on it. So this arrow now is summing to 9. And so this is a 1, 3, and we know the order. And that actually places this 1 down here. And so now... Oh, we already knew this arrow is summing to 9. Never mind. That we actually argued a long time ago. But anyway, this is a 1, 3, 5 arrow, is the point. So we should fill in this triple, that is worth saying. 2, 5, 6. Oops. I had too many cells highlighted. Let's highlight the correct number of cells. These are 2, 5, 6. Just to finish off green, that's not a 5. So these cells for the row, not 1, 2, 3, 4, not 5, 6, 7, 8, not 9. This isn't an 8, so it's a 4 or a 7. This could be an 8, for all I know. So this arrow now has to be a 2, 3, 4. Because this is a 3-cell arrow, it has to be 2, 3, 4. Because it doesn't have a 1 on it. And so that's a 7. This isn't a 7. This isn't a 7. This arrow sums to 9. So this arrow is connecting to this cell. We can give them a color. Orange. The 9 is not part of that. Because the 9 is part of this. So that's already done. So these digits are a 5, which has to go here, and a 6, which goes here. This is not a 4. It's being pointed out. Let's see. Let's fill in these cells. We've got 1, 2, 3. We need a 4. We've got a 5. We need a 6, 7, 8. This isn't a 6. Well, it's not a 7 either, because we know that these two cells are an 8 and a 3 or a 4. So let's just fill in 3, 4, 8, just so that I know that these are a 3, 4, 8 in yellow and an 8 in blue. Yeah, the 8 has to be blue. So these are from 3, 4, 8. Don't think I know much about that yet. What about these cells? These are from 2, 3, 4, not 5 or 6, 7, not 8 or 9. I know this is not a 2. Because there's a 2 in the region already. So this is a 3 or a 4 or a 7. This isn't a 7, because there's a 7 in the column with it. This 4, the invisible 4, actually gives us, that's an 8, and that's a 4. So this isn't a 4. Yeah, the 7 has been this arrow for some amount of time. As soon as these are paired, the 7 is going there, but I don't want to think about that until I've done the sort of Sudoku stuff first. But I agree, the 7 is being now... These oranges have to connect in some way, shape, or form, meaning the 7's only connecting to this. And the 7 can't join the 4, because that would be way too many cells. So these... But anyway, the point is these are in the same region. That people would like me to highlight. Let's make that yellow. Can make it a second yellow region. Go ahead and do that. Yellow can't leave the border. Because if yellow leaves the border and returns to it, that means I have to fit an entire region in there, and I certainly can't do that. Now, though, that finally resolves the mystery about the 4. And so the 4 finally gets to grow up and get a color. So the 4 region, the 4 region is going to inherit this arrow. So that is all going to be, let's do red again. Dagnammit. It's going to be red again. I know that the 9 is not part of the red region. I know the arrow is a 1, 3. So that makes this a 4. Makes this a 1, 3. This is currently... There's one more cell in here that has to be red. I don't know which yet. But now, certainly, this 9 is definitely yellow. I don't even have to really think about that anymore, because now there's... Otherwise, I'd have to fit a whole region here somehow. That's not going to work. Okay, so this is a 7 that is not 3, 4. So it's either 1, 6 or 2, 5. This isn't a 1, so that's not a 6. That's not a 5, so that's not a 2. unknown what I meant to do with this. This circle is certainly not in an existing region, so these are going to connect. And I guess that's going to connect to the last arrow, and it's not going to join anything else. So yeah, so we could give this a color. Man, we really need more colors. I guess it's going to have to be gray. No, gray is terrible. It's going to have to be even worse than that. It's going to have to be black. Because gray makes this disappear, so it's going to have to be a black region. So this is either 2-3 or 2-3 or 1-4. That's not a 4, so that's not a 1. Still true that one of these is the yellow 8. Blue and orange both need 7s. Row 4, column 1 is a naked single if I fill it in. Let's just fill it in. Okay. So we need a 3, 4, 5. We've got a 6. We need a 7. We've got an 8, and we need a 9. No, we don't need a 9. This is 3, just 3, 4, 7. Okay. So these aren't 4. That one's not 5 either. So that's a 3, 7 pair. So these aren't 3, 7. These are a 4, 5 pair. That's not a 5. Let's see. And so how am I resolving my 3, 7 pair? Well, that's a 1 and a 3. That's not a 1. Let's just fill in the rest of the column, I guess. 2, 3, 4, 5, 6, 7, 8, 9. 2, 5, 6. If this is a 2, this would be a 7. Looks okay. If this is a 5, this would be a 4. That's not going to work because I've got a 4, 5 pair up here. If this is a 6, this would be a 3. That's not going to work either. So in fact, this is a 2 with a 7. That's the only way it works. So that's a 6. These are not 6. That 2 looks up there with a 6 and makes that a 5, and a 4 and a 5. See, yeah, this is a 1, 2, or 6. To finish off the column. This 4C's over here makes that a 2, 3 pair, makes that a 4. So these aren't 4. The point is, okay, so this was the point about how this was a naked single, was that there's a 1, 3 virtual pair in these cells, because there's always a 1 or 3 in two numbers that sum to 5. So together with that 1 or 3 makes that a 7. So that was the quote-unquote naked single that was referred to previously. So these are not 2 or 3, therefore 7. That one's not 7, so it's a 4. So it's a 4, and that's a 7. Very good spot. Naked single is a bit of an exaggeration, perhaps. Not 4. Now this one's 2 or 3, so this one's 2 or 3 as well. So this is a 1 and a 3. This 2 looks up, makes that a 3 and a 2. This is not a 7 anymore. 4, 6, or 8, it looks like, for this row. 4, 6, 8. fill that in. Okay, this column needs a 1 and an 8 to be finished. Let's see, what else can we do? Assuredly, there's something else smart we can do. This 4 gives me this 3, which makes this an 8, and that a 4, and that a 3. So that means that yellow finishes here. So that is yellow all done. This cell now had better be blue, so that cell's blue. That cell better be blue as well. So now blue has 1, 3, 4, 5. It needs a 6. It's got a 7, an 8, and a 9. So in fact, it only needs a 2 and a 6. Well, if it doesn't take this 2, we're going to have a horrible problem. Because if it doesn't take this 2 is trapped under black, but black already has a 2. So I'd have to fit an entire 9-cell region under black and above blue and red, and that's not going to happen. So this is definitely blue. And so now one of these 2 is the 6. I don't know which yet. That's not a 4. Well, this definitely isn't blue, because blue already has a 4. And so therefore it's black by the exact argument that I just made, which is that otherwise this is some other region which now has to fit under black, and that's not going to work. So this is black, and for the same reason, this is black. Again, otherwise I'd need to fit some ridiculous region under it, and that's just not going to happen. Yeah, so one of these 2 is the 6. I don't know which one yet. One of these 2 is a 4, but interestingly, the 4 is not black. It is being claimed I already have 9 colors, which is useful if true. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do. Okay, so every cell left belongs to something. Is worth noting. So what takes this 5, I guess, is the natural next question. And so the answer to that question has to be that orange takes it. Blue can't take it, black can't take it, and if yellow takes it, yellow does that. And yellow can't do that because that would involve yellow taking a second 7. So this is orange. Okay, this column I should fill in. We need a 1. We've got a 2, 3, 4. We need a 5 and a 6. Then we've got the 7, 8, 9. So this is from 1, 5, 6. Those aren't 5, though. So that is 5, which makes that a 6 and a 1. Which makes that a 2, and a 1 and a 6, and a 2 and a 5. And a 2. And that a 3, and that a 2. If there was a bet cell, I forgot what it was. I thought there was a bet cell, but apparently there wasn't. I think I got confused because when I first read the rules, I completely misunderstood what was going on. And I explained my understanding of the rules, and then I think we lost a bet cell in the process of chat trying to explain to me what the rules actually were. 1, 2, 3, 4, 5, 6, 7 is what's left in the column. This is not a 7, so it's a 6, and that's a 7. what's left in this box. Oh, well, that's a 5. Let's do that, because there's a 2 in the region already. So these are an 8 and something else. Oops. Did I mark 8 anywhere I wasn't supposed to? I don't think so. These are an 8 and something. 1, 2, 3. An 8 and a 4 is what they are. That 2 looks over there and makes that a 5 and a 2. Okay, so what does red need? Red needs 4 or 5. Red needs a 6. Unfortunately, I think any of these could be a 6. Let's fill in this column. We've got 1, 2. We need a 3. Oh, we need a 3 in this column. The 3 is definitely there. And is not red. Let's keep filling in the column. We need a 4, but it's not here. We've got a 5. We need a 6. We've got a 7. We need an 8. So this is only 6 or 8. Which means we have a 1, 6, 8 triple in the row. Which means this is not 6 or 8. It's a 7. So that's not a 7. Some color has to take this 7. And the only colors available are yellow, black, and orange, except yellow and black already accommodate a 7. So only orange can accommodate a 7. So that's a 7. This is 4, 6, or 8, but it's not a 4. So this is actually 6. Uh-oh. No, it's not 6 or 8. Sorry. I did not do that correctly. That is not 6, because there's a 6 up there. So what is this? This is a naked single. It is not, it's a 2. Let's just fill in, it's a 2. Okay. Before I break the puzzle. Okay, one of these 2 is a 4, and the 4 is definitely yellow. This can't be yellow, because yellow has a 1 and a 6. So that's not yellow. Let's see. One of these 2 I know is the red 6, and then red is done. Oh, let's see. Black, orange, and red have a 3, so this is automatically yellow. Sure. I buy that. Let's see. The same is true of 2s. So this 2 has to be yellow. Good spot to Carl. Let's see. How many cells is that? 1, 2, 3, 4, 5, 6, 7. So yellow gets 2 more cells. But this cell's never yellow. So the only way that yellow can connect here in 2 or fewer cells is to go through there. But now as soon as yellow takes this cell's an 8. This cell's a 6. This cell is the last cell of red. We get to do a bunch of Sudokuing. Let me do some coloring first. This is orange. Now let's do in the Sudokuing. That 8 means that's a 1 and a 6, and an 8 and a 1 and a 6 and an 8 and a 4 and an 8 and a 4. It believes we are done, but we are not done. We must continue to make the thing happen. So 4 is gone in black and orange, and that's all I have to check now. So this is now yellow. And so now that is the appropriate number of cells. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 cells. Okay. So these 2 8s, one of them has to go to black. Oh, actually, sorry. Let's finish blue first. I abandoned blue long ago. Blue still needs a 6, so that is a blue. I mean, it just shouldn't pop up that you finished a chaos construction when you haven't actually finished the chaos construction part of the chaos construction. That is a bug in Sven's software, not a bug in Zeta. This 1 can't be orange, so it's black. This 6 can't possibly be black, so it's orange. So this 6 is black. And so if this 8 was black, it would separate... we can unblack the flashes. Yes, we can unblack the flashes, absolutely. If this 8 was black, it would separate black, so this 8 is the black one. We can zip in the thing there, and then we can put an orange there. And that's when it should pop up and say you've solved it, except it should then complain about the fact that you haven't done the borders on the outside. But now I think I have all my borders, and I really like the new black borders. So, so we have completed the puzzle. 11 of 12. Yeah, we've got to. Let's go. We've got to get our 2 more puzzles, or I don't know what will happen. Alrighty. I'm gonna go dig us up another puzzle, and I'll be back shortly. Be back in just a moment. Alrighty. Continuing, now we're going to combine the 2 tutorial series thus far. We have here a puzzle that involves both arrow and crop key. Oh, bye, Nell! I hope you have a good day/night. So we have our arrows, our friends for today, that sum to the digits along here. White dots indicate that these 2 cells are consecutive. Black dots indicate that these 2 cells have a ratio of 2 to 1. Not all dots are necessarily given. And this is by Glum Hippo, who is a regular around here, although I suspect is sleeping. Wait, no. I think Glum Hippo might or might not be sleeping. I think now that I think about it. Okay. So I've got to think about this shape. Because apparently this shape is going to come up a whole lot in this puzzle. And so if one of these numbers is 4 or less, let's just try and imagine, what if this is a 4? Then these would be... Got it, can't be. Okay. This one can't be a 4. And it can't be a 4 for a rather silly reason, which is that if this is a 4, if this is a 4, what happens? These are 1, 3. Oh, never mind, my argument was wrong. Nope, I retract my claim that this can't be 4. I know from Renbon stuff that one of these is a 5. I would like this to be 5, 6, 7, 8, 9 in some order, of course. I know certainly the 1 in this column is in one of these cells. The 1 can't go in a circle. 2 can't go in a circle. 3 can't go... Oh, sorry, maybe 3 could go in a circle. The 1 and the 2 are down in these 4 cells. For the column. Okay. Oh, bet cell. We should have a bet cell. Let's make a golden bet cell right here. The all-coveted golden bet cell. While I slowly break my brain thinking about this. Okay, what if one of these was a 3? If this was a 3, then these would have to be 1, 2. And now this would have to be a 4. And now there's a problem, which is that neither of these cells can be 1, and one of them has to be. In fact, neither of these could be 1 or 3. Okay. So at the very least, I can prove this can't be 3. Does the same argument apply here? Is it true that this can't be 3? Yes, it is true that this can't be 3. If this is a 3, then this would be a 4, and I, again, couldn't put a 3 in either of these. So this is not a 3. And I can't put 3 anywhere in the middle, because I can never put a 2 on the arrow. So, so the outside is either, so the lowest digit in these circles is either a 4 or a 5. I think it's a 5, but I'm still trying to see why it can't be a 4. Let's see, again, if this is a 4, with these being 1, 3... Ah! No, that doesn't work. That's gorgeous. Okay. If this is a 4, then of course this is a 5. But now what's going on in this box is that now I need these two digits to both be from 1, 2, 3, 4, 5, except they can't be 1, 2, sorry, from 1, 2, 3, 4, except they can't be 1, 2, 3, or 4. So at least that one can't be a 4. Okay, can this one be a 4? Come on, go gadget, look ahead, don't fail me now. If this is a 4, this would have to be a 5. And the same thing happens. These can't be two things from 1, 2, 3, 4. So they can't be, so these can't be 4. So one of these two is 5. One of these two is 6. One of this one is 7. Oh, why can't the 4 be a double 2? Darn it. Maybe it can be. Okay, let's try this. Okay, so 4, 5. Right, because these can be doubled. Darn it. Yeah, you're completely right. One of the 4s could absolutely be doubled because these two cells don't see each other. Okay, let's see. Garion has a different way to think about it, which is if this is a 4, then these cells are not 7, 8, 9. Those cells are not 7, 8, 9. And there are just not enough spots in the box that could possibly be 7, 8, 9. So Garion has a good way to see that that's not a 4. It could still be a 5. But it's not a 4. But if this is a 5, 6, 7... you can still hide 8 and 9 up there. Okay, what about this one? Is there a way we can rule out this being a 4 with that being a 5? These can't be 7, 8, 9. Those can't be 7, 8, 9. Those can't be 7, 8, 9. And so, in fact, actually, in this universe, where this is a 4, we still have the problem, because we need to put 6, 7, 8, and 9 into this box, and we can't. Because 6, 7, 8, 9 could only go in these 3 cells. Okay, so normality is restored. One of these two is a 5. So this is a 1, 2, 3, 4. One of these two is a 5. One of these two is a 6. One of these one is a 7. One of these two is an 8. And one of these two is a 9. That's really cool. I really like that. And so... we actually get a digit. This digit is always a 7. And so we get to do the 7 dance. Boop doop, boop doop, boop, 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 Bow. Ba-da. Bow. Ba-da. Ba. Ba-da. Ba. Ba-da. 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 Ba. 7 dents. Thank you, Zach. Okay, so Tallcat has gotten us a whole bunch more digits. Namely by asking, how am I ever going to put 9 in one of these cells? And the only cell I could possibly put 9 in, since I can't put 9 on an arrow, is here. Because now that this is 1, 2, 3, 4. So this actually goes like that. So these are on a 5 arrow, and so they're from 1, 2, 3, 4. These are on a 6 arrow, and so they're from 1, 2, 3, 4, 5. Except these two aren't 5, so that actually gets us our 1, 2, 3, 4 triple. These are 8, 9. So this is 7, 8, or 9. Let's see. The fact that these aren't 5 means that neither of these is a 1. This is on a black dot, so it's not a 5. So this isn't a 1 either. So this is a 2, 3, 4. Okay, so the 5s are actually the same. These are the same, and the reason why they're the same is this digit sees all of them. So if this is a 2, it actually makes both of these 1, 4. If this is a 4, it makes both of these 2, 3. So I'm actually going to change my coloring here, and I'm going to note that these cells are the same. I don't know which yet, but those are the same. And so we could ask where this orange goes up here, I suppose, but that's not, unfortunately, it could go there, maybe. Eep. Well, none of these cells are 1, 2, 3, 4. Okay, so here's how to think about this. Let's look at this box. I need to put 4 1, 2, 3, 4s in this box. None of them go there. So I need to put 3 in these cells. One of them, therefore, has to go on the dot. So, in fact, there are 2 1, 2, 3, 4s on this dot, because I can't use a 5. That's how to think about this. And now, I guess that doesn't tell me that orange is on the dot. It just tells me that some of these this orange could be up there, for example, as far as I'm aware presently. But still, it feels like progress. Well, I had this highlighted in blue before, and it's not blue now, so, you know, it was a significant change. So this is 1, 2, 3, 4. So this is 1, 2, 3, 4, 5. These cells are 5, 6, 7, 8, 9. That's not a 9. Could well be a 9. This digit's at least a 6. This digit's at least a 4. Oh no, this digit's also a 5, 6, 7, 8, 9. Because it's the same as that digit, you see. Let's see. How did we rule 6, 7 out from the white dot in row 1? The way we ruled 6, 7 out from the white dot in row 1 was by asking, in this box, where do 1, 2, 3, and 4 go? They can't go there. They can't go there. So I need to put 3 of 1, 2, 3, 4 in this box, in this L pentamino, or sorry, in this L tetramino. And so if 3 of them are in here, one of them has to be on the white dot, and as soon as one of them is on the white dot, both of them are. That is how. Row 8, column 4 is not an 8. If this was an 8, that would be a 9, and then this would be an 8, and that's not going to work. Okay, so that's not an 8. I agree. This is only 5, 6, or 7. Orange isn't low. I can get rid of this, but the point is these are explicitly not a 1, 2, 3, 4 quadruple. These are both the same way to make 5. Row 7, column 3 is not 1. This is a 1, that would be a 2. I don't see that yet. This is not an 8 at the very least, but that doesn't tell me a whole lot. So you can't make the 9 arrow work. Oh, right. If this is a 1, then this is an 8. Got it. Okay, this is way less complicated than I thought. Okay. This can't be a 1, because if this was a 1, this would be an 8, and there's already an 8 in the box. All of these cells... Sorry, not all of these. All of these cells are from 1, 2, 3, 4, 5, 6. And all of these are from 1, 2, 3, 4, 5, 6, 7. I won't mark that these aren't 8 or 9, but it seems very relevant that these digits are sort of pressed to be low. Yeah, we could use I'll help. Let's actually just say these two cells are the same and these two cells are the same, because that's really what we're saying. Good point from Chris. Right. So these two numbers add to 5. So these two numbers need to add to 6. Is that right? That can't be right. No, because these two numbers add to these two numbers add to 5. So if these two add to 5, then what do these two add to? If these two add to 5, then these two add to 7. So these two cells I have highlighted now, they need to add to 7. So this can't be a 2, this can't be a 2, because the opposite side can't be a 5. So these are either a 3-4 pair or a 2-5 pair. Let's see, if these were a 3-4... these being a 3-4 doesn't work. Because if these are a 3-4 pair, then what are these? Then these are a... No, sorry, it does work. Never mind. Row 3, column 6 can't be a 4. Right, because this is a 3-4, 5, so this can't be a 4. And so this is either a 2-4 pair or it's double 3. So, interestingly, I know that yellow in this box is over here, and yellow in this box is down here. I don't know how exciting that is. 4 in box 2 is in one of 3 places, unfortunately. You can do more with the dots in box 8. The white dot in row 8 isn't 8, 9. Ah, right. If this was 8, 9, it would put an 8, 9 pair here, and that would not work. So neither of these can be a 9, which means that's not 9 either. That's a good spot. 8, 9 pair in column 4. Yeah, 9 in box 8 is now limited to one of these two cells. Right. Where does 8 go in this column is the point. Where does 8 go in column 4? 8 can't go in any of these. 8 also can't go here because this can't be 1. So actually, 8 and 9 in this column are actually forced to the same spots. So this is an 8 or a 9, and so this is a 7, 8, or a 9. Wow, that's classy. And so one of these two is an 8, so that's never 8. This can't be a 9 because we said the 9 in this box is down here. So, so this is not a 9. Seven and 1, 6 and 2. This is never a 4 anymore, then. Can still be a 1, 2, or a 3, I believe, at least as best I'm able to see it. This can't be 5, 4. This digit can't be a 5. That's tricky to see, but if this is a 5, then both of these are 4. So this is not a 5. Okay. Good spot from Garion. Where does this digit go in box 8? Not there, not along the arrow. It's not 1, 2, 3, or 4. And so it's either here or here, which really means it's on this dot. So this dot has a 7 or an 8 on it. And so in particular, this dot doesn't have a 5 on it. It is from 6, 7, or 8. Means that's not a 5 either. Means this dot definitely has a 7 on it, which means that digit's never a 7. 5 in the box is now in two very awkward places. Row 2, column 7 is the only place for 9 in the column. That's not 9, that's not 9. Yeah, that's a good thing. Chris's point, yeah, 9 in column 7 is placed, because 9 can't go here because there are pencil marks, and can't go on an arrow, so 9 goes here. So that's a 9, that's a 9, that's an 8, that's an 8. And so that's a 9, that's an 8. This is not 9. That is a good spot. So now I need to make 8. This can't be a 1 anymore. And so now if I look over here, in this box, where does 8 go? 8 goes on this dot, and so this is not a 6 either. This is a 7, 8. It means that's not a 7. It means it's a 5 or a 6. This dot is never 2, 3. So break that cell. And so now we ask where's 9 in this column. 9 in this column now has to go here, because there's 9s ruling 9 out of those places. So that's the 9. I can rule 7 off of this cell for whatever it's worth. 8 in column 7. Can't 8 be any of these? Row 7, column 4 can't be a 2. Ah, right, because if this were a 2, it would need to go with a 1 over here, but it can't, so that's not a 2, I agree. I have an 8 in row 9, got it, so one of these two is an 8. Do I know which one? Row 6, column 5 is a clone of this. Ah, yes, so this isn't a 2. Good point, good point. So, so one of these is a 2, although I guess that doesn't tell me anything. 8, 9 pair in row 3. Let's see. Ah, yes, right. Good spot to Ken. This is an 8, 9 pair. And so this is a 5, 6 pair to finish off the row. So in fact, these are 1, 2, 3, 4. So green is up here somewhere, but we don't know where yet, annoyingly yet. Don't forget 7 in box 3. Uh-oh. Let's try again. Ah, sorry. These are 5, 6. That part was right. But these are 1, 2, 3, 4, 7. That is the thing I did wrong. Row 7, column 7 can't be 8. If this was an 8, that would be a 1. These would be 7s. I don't see it yet. But welcome, Ralph. You're welcome to elaborate. I just don't see it yet. Row 7, column 3 is not a 3. Would make this a 6. Then row 8, column 4. So you're saying if I make this a 3 and this a 6, then now this is a 4 and that's a 4. You get a clashing 3 in row 7, column 5. Ah, because now this is a 2, and this is a 5, and 2 and 5 don't add to 8. Good lord. So this can't actually be a 3. I buy that. I don't love it, of course, but I'll accept it. But that's a hell of a chain. That's amazing. How on earth do you spot these things? I have nothing but admiration for that as a spot. It's let's see, it's 7 hours into the stream. My tolerance for look-aheadiness is always growing as the stream continues. I do know there's a 7 over here, actually. Let's do that. This is a 7. That's a good one. Okay, so where does 7 go in this box? Oh, wait, no, 7 could go here, right? Never mind, sorry. One of these two is a 7. But again, I don't know. So one of these two is a 7. So either this is a 2 or this is a 1. One of these is a 1 or a 2. Does that do anything for me? One of these is a 1 or a 2. Not strictly speaking, no. So there's definitely a 7 in this column, too, somewhere. Interesting. This digit can't be a 7 anymore. That's one consequence of this. Because one of these two is 7, this can't be 7. Because if this is 7, obviously this can't be 7. But if this is 7 also, it can't be 7 here, because 8 and 14 are different numbers. So this is not a 7. And so the 7 in this column is up here somewhere. I don't know that that's a deep and profound statement, but it's true. Let's see. 8 and 14 are purportedly different numbers. Purportedly. I think I really should examine how the two options for yellow and green affect these two. I think I'm not certain that I really want to, but I think I have to. So if yellow and green are 2, 3, then what happens? This is a 1 and a 5. And this is a 4 and a 2. So, again, if yellow and green are 2, 3, then actually we know the order. Because if yellow and green are 2, 3, then this is a 4 and that's a 2, which means that green is 3 and yellow is 2. So, in fact, actually, that does something for us. That at least gets us some pencil marks. So if yellow and green are 2, 3, then this is 4 and this is 2. So green is never 2. So yellow is never 3. If yellow and green are 1 and 4, then these are 2 and 3. And so these are 4 and 3. Does that do me any good? Can I deduce something like... I don't think I can get anything quite as good out of that, unfortunately. Now, here's an interesting remark, I suppose. These numbers are all low, so I only get 1, 1, 2, 3, 4 in this whole shebang. And if only one of these is 1, 2, 3, 4, I'm going to have a hard time making lots of these low. I guess this one's definitely big. This can only be 5 or 7. I suppose I can fill in. I guess phrased a different way. One of these is 5, 6, or 7. Let's see. Kuraban says row 7, column 7 is an 8. Then row 6, column 6 is a 1. These are an 8. That's a 1. by arrow. These are... Oh, no, it's this cell. If this cell is an 8, that's a 1. Then you can't put 7 in box 5 on the 8. Okay, so let me just write this in. I don't think this is something that is doable by me in my head. If this is an 8, then this is a 1. And so now the question is, where does 7 go in this box? And the answer is 7 only goes here, not here. Because if this was a 7, this would need to be a 1, and it can't be anymore. So this would be a 5 and a 4, but this would be a 3 and a 3. I feel like we've made it very far without me seeing what breaks. Let me look again and see carefully. Backwards? Okay, so let's see. If this is an 8, that's a 1. That's a 3 and a 3. This now has to be a 7, because I can't put a 7 there. So that's a 7 and a 2. And then that breaks this cell. There we go. Okay, so it's a bit of an adventure, but this is forced to be 2, 3 if this is an 8. So this isn't the 8, which means this is the 8, that's the 8, and that's the 7. Adventure. Row 6, column 5. And part of it is just like when someone spots something that is like super far look ahead. On the one hand, I'm sort of like, I don't want to use that. But on the other hand, it's like, well, I'm so impressed they saw that. It would feel wrong not to use it, because I'm nothing but impressed by the people who see these things. So then I end up using it more often than not. Try 2 in row 6, column 6. Let's see. Let me try Chris's point first. If row 6, column 5 is a 1, then you end up with no place to put 7 in box 5. So if those are 1 and 1, then this is a 2. Don't you literally place a 7 in box 5 if this is a 1? Oh, row 6, column 3? Wait, no, sorry, this is Chris's point. If this is a 1, it literally places a 7 in box 5 right there, I believe. Eight in row 5 is getting quite congested. Okay, row 6, column 3 can't be 2. If this is a 2, that's a 6. Makes that a 4 and a 3 and a 3. Right. And so as soon as this is a 2, it makes that a 4, which makes that a 5 and that a 6, and both of the 7s are gone. Got it. Okay, yeah, I see that now, yeah. If this is a 2, it makes both of the 7s go away, and I can't make both of the 7s go away. And so if that can't be a 2, this can't be a 6. I keep trying to make something out of the fact that either this is a 1 or this is a 2, but I can't. Okay, so there is some suggestion that I try to do math. So the total sum of these cells is 90. The total sum of these cells is 2 times 35. It's 70, right? 5, 6, 7, 8, 9 is 35. Times 2 is 70. So these sum to 70. I'm doing this wrong. Why am I doing this wrong? Oh, it's not doubled. It's not twice. Sorry. It's only once. The other arrows are over there. It's just 35. So 35 plus 8 plus 8 is 51. Plus 9 is 60. Plus 9 is 69. Plus 7 is 76. And so I think what we get is that these 3 cells that I don't have highlighted sum to 14. Unfortunately, that doesn't seem all that powerful. Is there a way I could do it on the other side and maybe it works better? I don't think it's going to work better, though, unfortunately. It's a very good idea. It would be a very cool thing to do. I just don't think it does anything. Okay, let's do it on the left side. So we'll take all of these cells. So these sum to 35. 35 plus 18 is 45 plus 8 is 53. No, I didn't do that right. Sorry. 35 plus 16 is 41. No, 35 plus 51. 60, 69. And so now these cells sum to 21. Is that right? I don't think I did that right. You got an ad? You shouldn't get an ad when I'm streaming. I deliberately don't play any ads when I'm streaming. So hopefully it should not do that. Okay, so these sum to 21. So the maximum that these can sum to is 7 plus 6 is 13, plus 6 is 19. So this can't be a 1. Very clever. Okay, so this can't be a 1 because then this would not be able to sum to 21. So so this is a 3, a 2, a 3, a 4. That's very cool. I am impressed by that. So these all aren't 4. These are not 2 or 3. They're 1 and 4. That being a 4 makes that a 5, which makes that a 7, which makes that a 1. So this isn't a 3 anymore. This isn't a 3 or a 5. That 5 makes this a 6 for lots of reasons. That's a 5. So this isn't a 6. So this isn't a 1. If this is 1, 2, or 4, this also can't be 2. This is 3, 5, or 6 only. Green is 3. So yellow is 2. So this is a 4 and a 1 and a 2 and a 5. This is not a 3, so this is a 5 or a 6. So this is a 1 or a 2, but it's not a 2, so it is a 1. It is a 1 and a 6. So these digits are not 1 or 3 or 5. That one's not 2 either. So this digit is only 1 or 3. So this digit is 2 or 4. This 2, 4, or 6 means this is also 2, 4, or 6. This digit is also 2, 4, or 6 to finish off the box. So this digit is either a 7 or a 5 or a 3. It's not a 3, so that's not a 6. So let's see. So these digits up here, 1, 2, 3, 4, they are a 5 and a 7, I believe, and I know the order. That's the 5, that's the 7. These aren't 2 or 3. So the 2 and 3 are up here. Oh, sorry, no, the 2 is not up there. Sorry. There's no 2 up here, so there can't be a 1 on the dot. So these have to be 3, 4. So that's not a 4, and that's not a 3 or a 4. These are a 1, 7. Whatever that means. The 4 over here is over here. Speaking of, this is a 4, because it's not a 1. And so now that's the 4. This is a 1 or a 7 for the row, but it's not a 7, so that's a 1, and that's a 7 and a 1. These two digits are a 2 and a something. 3, 4, 5. 2 and a 6. Looks like 2 and a 6. That 4 actually makes that a 6. Wow, my typing is suddenly not going great. Let's see. We've got 1, 2. We need a 3. We've got a 4, 5, 6. We need a 7. We've got an 8. And we need a 9. So this isn't a 7. Let's see. I know what I add to 6 to make 7. It's a 1. So that's a 2. So that's a 4, which makes that a 4 as well. Makes that a 2. That makes that a 7. I can only imagine that the arithmetic thing in columns 3 and 4 was the intended path to do, because I think it would have obviated a lot of what we did. 1, 2, 3, 4, 5, 6, 7, 8. 3, 5, and 8. This one's not a 5. These cells are 6, 7, 8, 9, actually. These aren't 6. That's not 7. This 4 looks up here. It gives me a 3 and a 4. It means I know what this digit is in theory. 4, 5. It is a 6. I don't know how to feel about that. Let's see. There's a 6 over here somewhere. Let's see. This is a 5. Okay, so this digit has to be next to a 7, 8, 9. So it's a 6, 7, 8, or 9, except it's not a 7 or an 8. So it's a 6 or a 9, which means this can't be an 8. So that's something. Wait, no, I did the wrong thing. Not 9. It can be 7 or 8, sorry. Not 9, yes, I did mean that it could not be 9, we'll say. There's a 9 in the box? This can't be 9. Right. If this is 9, it would make this 9, 8, which would make that an 8, which would make this nothing. So this is actually 6, 7. Good spot. So this is not a 7. That gives me an 8, 9 pair in the column, so this isn't an 8. This 7 means that's not a 7. This 6 actually tells me that that's a 2 and a 6. So these digits are 1, not 2, 3, 4, 5, not 6, 7, 8, and 9. That's not a 1, that's not a 1, so that's a 1. This one's not a 9, so that's a 5 and a 9, and a 3 and an 8. Better delete that real quick. Let's see. So we've got that this is not an 8. This isn't a 3. Sorry, it's not a 3. I hit the wrong thing. So what are these? 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9. These are 2, 3, 4, 5. These aren't 4. These aren't 3. Let's see. Row 4 can be finished, I am told. Aha! 9 and 7 and 8 and 9 and 8. So this is a 3 or 5. But that 5 looks up here. It gives me a 3 and a 5. Gives me down here. One of these is a 1, and one of them is a 3, which somehow I don't know how to do. Let's see, one of these is a 2, and one of them is a 7. Okay, so I can do that at least. That's a 2, and that's a 7. So these aren't 2. That's not 2. So that's a 3-5 pair. So that is a 4 and a 2. 4 looks over, gives me a 1 and a 4. The 1 looks over and gives me a 3 and a 1. 3 looks over, gives me a 5 and a 3. The 5 looks up and gives me a 6 and a 5. This 6 and 7 look down and give me a 9. And then we have the perfectly chosen vet cell that could not possibly have been determined until the very, very end, which is a 6. Ta-da! I mean, one of the nice things about streaming, Finish Guy, is that doesn't happen when you're streaming. You have 33 people yelling at you that that you're missing a basic thing. Although, what's funny to me is very, very often there is some very simple thing that chat doesn't see, but then chat sees some complicated thing instead. So chat doesn't always give you the simplest missing deduction. But chat will always point out if there's something that can be done. Yes, I liked that use of arithmetic. I really did not expect it. Like, I was expecting very much that it wasn't going to do much, which it didn't over here, but then over here it worked perfectly. Gorgeous, gorgeous puzzle. I enjoyed that a lot. Let me dig us up another puzzle, and I'm going to take a real quick break. And then I'll dig us up a puzzle number 13. So we will do lucky number 13 for the stream. I'll be right back. Welcome back, everyone. It seems only fitting to wrap up the stream with another weird arrow puzzle. And so first of all, I should make clear this is not a vanilla arrow puzzle, despite looking kind of like a vanilla arrow puzzle. Rather, instead, this is a play off of a puzzle I made called Distinction. So the puzzle I made was a Renbon puzzle where the rule was there are a bunch of Renbon in the puzzle and none of them could contain exactly the same digits. And so here we have normal arrow rules, but we also have that all arrows contain a distinct set of digits. So if this arrow is a 615 arrow, this arrow can't be a 615 arrow. It would have to be a 624 arrow, and then this would have to be a 633 arrow, and then we would panic about this one. So those are the rules here to Memeristor's puzzle. My most recent puzzle, Vignettes, actually was inspired by a Memeristor idea, so sort of like the inspiration bounces around in many directions. Okay, so what digit is this? I think it has to be an 8 or a 9, because I think only 8 and 9... Oh, it can't even be an 8. Sorry, I was thinking one of these could be 4-4, but none of these can be 4-4. So actually 8 you can only make in 3 different ways. So this has to be a 9, and we should make a bet cell. We'll make that the bet cell, not that. That the bet cell. Oh, sorry, it shouldn't be gold. We did a gold bet cell already. We should do pink. This will be the pink bet cell. Okay. And so just by the rules, this can't be a digit less than 9, so it's a 9. And so we can we can bring out the Mr. Zach. And so Zach will do the 9 dance again. He's adding more improvisation, you can tell, because he's done a lot of 9 dances today. Thank you, Zach. Thank you. So that makes these cells a 1, 2, 3, 4, 5, 6, 7, 8, 9 octuple. So we have that. All arrows contain a distinct set of digits. But I think that's meaning between arrows. I don't think it's meaning that this pair can't be the same. Like, I think this could be an 8 with a 4-4. I think that's okay. This is a fantastic opportunity to bring back my cheat sheet from earlier. This arrow can't actually be... Oh, I put 9s in there. Oops, sorry. None of these can be 9. Not even that one. This digit can't be a 6 or a 7, because there's only one way to make a 6 length 3 arrow and only one way to make a 7 length 3 arrow. So this has to be 8 or 9. But it can't be 9. That's gorgeous. Because if this was 9, assuredly, this would show up in one of these. I don't know which, but it would assuredly show up in one. So this is, in fact, an 8 arrow, which means that there's a 1 in each of these things. And one of these is 1, 2, 5, and one of them is 1, 3, 4. And so actually that means that this is a triple. As we learned earlier, this is a 6, 7, 9 triple. Because this sees both a 1, 2, 5 and a 1, 3, 4 arrow. Which is, as you know, sweet. How do I know this isn't a 9, 2, 3, 4 arrow? Do I know that this isn't a 9, 2, 3, 4 arrow? Oh, if this was a 9, 2, 3, 4 arrow, would it break every possible way of making this arrow? Okay, so if this was a 2, 3, 4, this couldn't be 3, 4. This would have to be 1, 2, 5. No, wait. If this was 2, 3, 4, this couldn't be 1, 3, 4. This would have to be 1, 2, 5. This would be a 2. This would be a 3, 4. That seems okay to me, unless this is more complicated even than that. But certainly one of these two is a 1. I certainly know that. I also will note, now that tells me these aren't 8, so these aren't 1. So that is reasonable. This cell also sees both of the entire arrows. So this cell can only be a 6 or a 7. It can't be a 9. And so this cell is a 1 or a 2. I don't know which. Sayori has it. If this is a 1, I need to put 6, 7, and 9 into this box, and I can't put it there. So I need to put 6, 7, and 9 in this set of 5 cells. And that's going to be a problem. Because I could put 2 of them down here in the circles, but then I'm putting 1 of them on the arrow, but I'm not using a 1. So I agree with Sayori's point. That's very cool. So that is a 1. So interestingly, this can't ever be a 7. Because if this was a 7, this would be a 2, 4. That would break both my ways to make 8. If this was a 6, this would be a 2, 3. That would break both of my ways to make 8. So this actually has to be a 9. That's the only option. And what are my ways to make 9 with 1 that don't break both my ways to make 8? 3, 5 doesn't work, so this must be 2, 6. And as soon as that's 2, 6, I know what this is. This is 1, 3, 4. Which means I know what this is. This is 1, 2, 5. And so these cells are now known. They are a 3, 4, and an 8. And so these cells are known. 1, 2, 3, 4. They are a 5 and a 7. These cells are actually a 5 and a 2. So that's the 7. That's the 5. These cells are a... Oh, sorry. This 2, 6 looks up here. That tells me this is a 7 and a 1. That's not a 1. That lets me fill in these. Sorry, these aren't... While I'm at it, these aren't 7. So these aren't 2. Important to keep your pencil marks clean. So what is this? This is a... Let's see, we've got 1, 2, 3, 4, 5, 6, 7. These are an 8, 9, and I know the order. It's an 8. That's a 9. And so now, owing to my careful pencil marking, I actually know that this is an 8, 1. Right? Oh, no, I don't. Darn it. I know that's not a 1, so that's not an 8. But annoyingly, there's still 3 spots that 8 could go. Darn you. I thought I was going to get something productive. These digits are... let's see. We've got 1, 2. We need a 3, 4. We got a 5. We need a 6. They're 3, 4, and 6 in some order. Okay. So this 5 is either 1, 4 or 2, 3. What about this cell now? So it needs to be makeable in 2 different ways. Oh, it's not 1, 4, right. Beautiful. The 1s look at both of these, so it can't be 1, 4, so it's 2, 3. Gorgeous. So this is 2, 3. this digit now has to be at least a 6, because in order to be able to make something in 2 different ways, it needs to be at least 6, and this needs to be makeable in 2 different ways. So this is 6, 7, or 8. I might be able to do better if I think about it. Yeah, I was noting the aligning 2s. Place a 2 over down here. This needs to be makeable in 2 different ways as well. It can't be 5 anymore. So this number is at least 6, and it's not 7. So this is 6 or 8. Can't be 6. Let's see. So if it were 6... right. If it were 6, this would need to be 1, 5, and that can be neither 1 nor 5. So actually, this is not 6. This is only 7 or 8. Got it. So if this is a 6, this is 2, 4... right, okay. If this is a 6, it doesn't work either, because if this is a 6, I need a 2, 4. It would have to be 2, 4, but then this would have to be 1, 5, but there's a 1 in the row, so this is the 8. So I'm making 8 the other ways, which are as 2, 6, and as 3, 5. These aren't 2 anymore. So that's going to do tons of stuff. So it's going to make that a 7. It's going to make that a 2 and that a 3. That a 6 and that a 2. Let's see. That 3, 5 means 3. It does have to be 2, 6 because there's only 3 ways to make 8, and we've already used 1, 7. So we know the bet cell is a 4. 8, 3. Whoever picked the bet cell didn't do a very good job of picking the bet cell. We know that these are a 1, 6, and we know the order. So this is either... Oh, it's not 2, 5. It's not 1, 6, so this has to be 3, 4. Wow, this is an amazingly smooth puzzle. That 3, 4 gives me a 1 here. Not 1s there. These digits are a 2, 3, 4, 5, 6, 7, 8, 9. 4 and 9. These digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 and 9. But I know the order on this one because the 3, 5 is there. So this is the 9, that's the 4, that's the 9, that's the 5. These 2 digits are 1, 2, 3, 4, 5, 6, 7, 8. 4 and 8. That pushes a 4 up here because these 4s align. These digits are... Let's see. Let's go ahead and fill in. That's not an 8. That's not a 1. These are not 4, 5. These digits are a 1 and a 2, 3, 4, 5, 6, and a 7. I don't know the order yet. So it's either this is 8 and this is 1, or this is 8 and this is 1. Those are the only options left, I believe. What about this cell? This cell now can't be 9, 8, or 7. So this can be 5 or 4 or 3 in theory. Can I rule any of those out? Ditto with this one, right? This one... right, this one. So this sums to at least 4, but it's not 4. So it could be... So this can be 5 or 6 only. 7s are done. Oh, wait, are 7s not done? Sorry, 7s aren't done. Sorry, in my mind, 7 was done. But if this was this can't be a 7, because if this were a 7, this would have to be 2, 5, and that's a 2, 5. So it can't be 7. That can't be 7, at least. This might be able to be 7. So let's look about this. If this was 5, it would have to be 1, 4. It can't be, so it's definitely not 5. If this was a 6, I haven't done any 6s yet. It would have to be 2-4 or 3-3. Well, it can't be 3-3. If it was 2-4, it would have to be 2-4 in that order. That looks okay. And if this is a 7, it has to be as 2-5. So that has to be a 2, and that has to be a 5. Is the moral that this digit's always a 2? I think the moral is that this digit's always a 2. 5 cannot be 2-3 because we've already used 2-3. And we aren't allowed to repeat it in this puzzle. So people are saying 6 doesn't work. If 6 is this, that could be 2 and 4. Aha! Right, there's a 4 pencil marked up here. Where did this 4 come from? Is this a real 4? Yes, it is a real 4. Because it's looked at by that. So right, so this can't actually be 6. It can only be 7 with a 2 and a 5, not in the order I tried to put it in. So therefore, that's a 2. So these are not 2 or 5. So these are not 4 or 7. So now we can look at this. Let's see, if this is a 3, it would be 1, 2. That still seems possible. If this were a 4, it would be 1, 3. Oh, there's always a 1 on here. That's the point. Whether this is 3, 4, or 5, there's always a 1. And so my 1's a line, and so this isn't a 1. Which means this is a 3 or a 6, which means it goes with a 3 or a 6. Which means these aren't 3, 6, which means they are 4 and 5. Means this isn't a 5. These are not 3, 6, or 4, 5 anymore. So this one is 1, 8. This one is 2, 7 in some order. This is not 1 or 2, so it's a 5, and that's the 1. The 7 looks up, makes that a 2 and a 7. The 4 looks over here, gives me a 3, 6 pair in the row, so these are a pair. Let's see, we've got 1, 2, 3, 4, 5, 6. They're an 8 and a 9, so that's a 9 and an 8. That 5 looks down here, gives me a 3 and a 5. Let's see, what about the rest of this? So the other 3, 6 goes here in the box. This 3, 6 in this box goes here, so it's a 3. So it's not a 3, it's a 6. It's a 6 and a 3 and a 6. These are a 2, which goes there, 3, 4, and a 5, which goes here. Let's see. This can't have a 4 on it, but that's okay. Let's see, what about these digits? We need a 3 and a 4. And a 9. Well, that's not exciting. Okay, in this row, that's not a 7. So I think this is a 6 or a 9, and it's not a 9, so that's a 6. Sorry. Oh, no, sorry. There's already a 6 in the row, so that just is a 9. Those aren't 9. So what is this? Oh, it's a 1, isn't it? It's a 1. Great. Okay, what about these digits? Let's just Sudoku this up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are not 7. These are not 6. That one's not 6 either, so that one is 6. This 3 looks up and says these aren't 3. So in fact, this goes 4, 7, 3. This 4, 6 looks over and makes that a 3, a 6, and a 4. That's pretty cool. These digits, we've got 1, 2, 3, 4. We need a 5, 6. We've got a 7. We need an 8, 9. These aren't 9 for sure. They aren't 6 either, so they're a 5, 8 pair. So these aren't 5 or 8. They are 6 and 9. which makes that a 7 and a 6. This isn't a 9, so that is a 9. Let's see. That 8 looks down and makes that a 4 and an 8. That 4 makes that a 3 and a 4. Yeah, I mean, I do know that this is from 1, 2, 3. And so this is not a 2 or a 3, so that's the 1. This is the 2 or the 3. But it's not a 3, it's a 2. So then that's a 3, and that's a 4. And a 4 and a 3. Okay, I thought I had milked this arrow for everything, but I had not actually. 5 and a 2, 8 and a 5, 9 and a 6, 7 and a 1, 3, 4, 5, 6, 7. That's an 8. 2, 3, 4, 5, 6, 7. Well, that was gorgeous. I loved that. That was delightful. I don't know how I've put off doing this for so long. I was very excited to do it when I first learned about its existence, and then I forgot that it existed until now. But I guess Arrow Day cures all wounds is the moral of the story. Delightful, quick puzzle. Alrighty, and there we go. We made it through 13 puzzles in one day, so we have set a new record. Alrighty, so I'm going to wrap up stream there for today. Thank you for joining us. I hope you enjoyed arrow puzzles. We got to do lots of variations of arrow puzzles today. You got to hang out with Zach. He had fun too. If you haven't yet, please like the stream. Liking the stream is great. If you haven't subscribed yet, please consider subscribing. And if you want to look into yet further ways to support, you can hit the join button down below to become a YouTube member. That gives you the green screen name there with a little windmill next to it like Kuraban has, as well as the emotes, like the fancy Zach emotes that you can spam when Zach dances. As well as the ability to vote on what puzzles I do next. Every stream I do a puzzle that's voted on by supporters. I do whatever one is the most voted on. So that is a lot of fun. And also, all of you are great at picking out puzzles that'll end up being a ton of fun. So I have greatly enjoyed, I think, every puzzle that has been voted on. Anyway, you can also, if you prefer Patreon to YouTube for whatever reason, political, personal, whatever, patreon.com/zetamath is also available. It can't make your screen name green, but it will let you vote. It'll get you access to the exclusive Discord where you can chat with people. If you want to join the fancy Satisfactory server, you can do that as well. Somehow Ranksk is saying that that's an average of 2.26 digits per minute. Somehow it sounds less impressive when you say that it's like 2 digits per minute. It sounded way more impressive when it was 1,053 digits placed, I have to say. But I'm going to hop off here. But I will see all of you very soon. I'll be streaming again on Saturday. In just a bit, Ranksk is going to be streaming some word games. So you can go and enjoy Ranksk's word games. It's in about an hour. So you can do that. Anyway, I look forward to hearing from all of you. If any of you have any puzzles that you recommend for future tutorial series, I have not yet decided what mechanic I'm going to do for the next tutorial series. But if you have a puzzle that you think would be great for a tutorial on, say, Renbon or whatever, or you just have any other like 2 or 3 star puzzles that I could do sort of following that would be pretty cool. So just let me know, be they your puzzles, be they other people's puzzles. If it's other people's puzzles, I can hunt them down or you can hunt them down for permission to stream their puzzles. Just let me know. All right, it's been great fun. I've enjoyed today a lot. I like arrows more than I thought I did. And I will see you on Saturday for more stream. Thanks for watching.